help you with, or a text editor like Sublime Text, is I can select the entire thing like this and do Command Control G. And this actually selects all the instances. And I have now multiple cursors. Now what I can do now is just add the static on all the instances, as you can see at the bottom and the top here as well, so that I don't have to repeat myself. Now let's go back, refresh, and look at that. We have our projects displaying. That's really, really cool. And just like that, we have our templates. Now we still have the components that we need to fix and the contact. Now the components we actually don't need, because if you go to the preview here, the components is just an HTML template that you can just copy and paste based on what components you need, but we don't actually need that on our real portfolio. The only other one that we need is the contact page, which is really, really important because we're going to use that for our Python server. So let's go back here. Let's remove the components.html. Or for now, we can just keep it there, but in the index.html file, we can go all the way down. And in the navigation bar section, you see over here how we have the components.html. We can just remove that, just like that. So we're not using it. Now, one thing you may have seen me do is copy and paste code, so that now we would have to do another route that says contact, and then once again do contact. But this is us repeating code. Based on what we've learned, can we improve this so this becomes more dynamic, so that maybe when we add a new HTML file to this profile, we don't have to constantly just copy and paste the same code over and over? Try that, and in the next video, I'll show you how we can do that. Welcome back. Let's make this a little bit more dynamic. We have our home route, but for all the other HTML pages, it'll be nice if this was generated dynamically so that we don't have to copy and paste code. So let's delete all of these and instead use this little syntax that we learned about, where we can dynamically accept different URL parameters. In this case, we can just call it page name. And this page name should be a string, right? So now we can use the string type to say, I want the page name. So this is going to be HTML page. And we want to render in the template the data that was entered in the URL. So we can actually give it the page name here as the input and print out the page name here. Let's see if this works. I'm going to save this, go back to our homepage, and it works. What if I do works? Yeah, look at that. If I go to About Me works. Contact. All right, contact is working, but the CSS isn't being applied, so we have to update that. And we still see the components. All right, so there's a few things that we need to fix, but everything is working dynamically, which is great. And you see that even index.html that we had issues with before is now working, which is great. So let's fix a few things. We've now made our code super simple and easy to understand, but there's a few bugs that we need to fix in our code. First is to remove the components. Now, the reason this is happening is that each page, if we scroll up to the top, so let's go to the About page, has the components link. So from each page, we just have to remove the components. So let's go to Contact, remove the components here. Go to Index, we've already removed the components for that one. If I go to Work is a little bit different. We'll get back to that in a second. If we go to Works, and again, at the top in the navigation, the components we can just remove, just like that. We also saw that the contacts page doesn't have CSS added to it. So again, we go back and we add the static folder here. Same with the favicon right over here. And then the JavaScript file at the bottom. If we save, go back, let's refresh, and go to home. If we go to works, that works. About me, that works. Contact, look at that. How pretty is that? All right. Now, a few things that I want to fix here. One is that we see that the numbers don't match over here. We want them to ideally match, right? So we have this working, but then about me and contact, that's kind of weird. Let's see why that is. If we go back, we go to contact. We see that in the navigation, we have 1, 2, 3, 4, which looks great. But then at the bottom, we see that the numbers contact me are a little bit off. So let's just do 04 for contact me. If we go to about, making sure that the about page or about me is 03. So let's do that. And now if I save and refresh, we have contact me, about me, works, and home. All right, 2 last things, and then we're going to get back to Python, I promise. One, I want to change this text so that it says my name, and maybe I'm a Python developer. So all we have to do is, once again, go to index.html and look for this text. Add your site or app content here. So we can see here it says, hello, I'm James Dean, French designer. So let's just say I'm Andre Nagoy. And let's say Python. Let's say expert. Sounds cooler. Working as a freelancer. Let's do an instructor, because I am an instructor after all. So that if I save and refresh, how awesome is that? Super, super simple. That looks pretty neat. All right, the last thing is the works part. If you look at my works and I click on discover, all right, so here you can add your own projects that you want. If I go to 06, I guess the links here aren't working since we only have one work. But let's say you wanted to add a different project. All we have to do is simply say work2.html and link in 002 here with work2. Let me show you how that's done. So let's go to work.html. If we do Control F and do 002, we see that these are the links. Look at that, 002, 003. So all we have to do is perhaps change the link here to work2.html so that it links to work2. Now, that's something that you can do on your own. Again, we don't want to focus too much on HTML and CSS because it's outside the scope of this course. But as you can see, we have a pretty neat website, pretty fast. It only took us a couple of minutes, and you now have a portfolio webpage. But there's one big piece missing, and one thing that Python can really help us with. That is this contact form. It wouldn't be a real portfolio website unless people can contact you, right? Maybe employers or people that need work done can actually send you a message. So over the next couple of videos, we're actually going to explore this, where we're able to send information to our server in the backend and actually capture it and save it and store it somewhere. I'll see you in the next one. Bye-bye. All right, everybody, this is going to be really, really fun. We're going to create an actual contact page where users can submit contact information and enter a message so that they can contact you online. Now, if we go to the Quick Start Guide on Flask and we go to accessing request data, this actually shows you how to handle it. And right over here in the request object is the code for us to actually grab information from the browser. Now, there's even things like file uploads, so we can get people to load their files and actually send it to our server. But for now, let's just focus on this. I want to copy the code first, and then we're going to talk about what's happening. Let's go to our server.py. We have our basic routes right here, and let's add another one like this. Now, the only thing I care about right now is this part right here. I want to create a new route that I'll name for now submit form. And this is something that we'll actually have to create. It's going to have methods post and get. And again, this is just the default. Get means the browser wants us to send information. Post simply means that the browser wants us to save information. But we won't worry about that for now. We also want to define a function called submit form. And finally, I want to just return for now a form submitted hooray message. So that's our submit form endpoint. But it's not doing anything right now. We're never calling this on the front end, on the browser. So how can we get this to work? Well, let's go to the contact.html and figure out when we click the button, what happens. And actually, let's just search for it. If I go to title page, you see that we have the send button. So when we hit send, we ideally send some information to the server. So let's Command F and look for the send text. And look at that. It looks like it's over here. Let's make this a little bit bigger, just like that, so we see what's going on. We see that we have a button of type submit, and this is the button that we're clicking to send. So it's on line 74. Now, at the top here, we see that we have something called form. And with form, we have an action that we can take. This is standard HTML. When HTML was created, the idea was to display pages, but also using this form, be able to send data to the server. And we do that using this action attribute. And in here, we can put post or get. And if you remember, that's exactly what we have here. This endpoint will be able to accept methods, either get or post. Now, we don't need to get into the details of what get versus post is, but a good way of thinking about it is we can send data with get by simply attaching the information to the URL in here. But ideally, we don't want to send people's emails and message in the URL. Ideally, we want to send it into some body of text that's not so clear and obvious. So in our case, we're going to use post, and I'll show you how this works. So we're going to have an action in here that is post. Now, the way this actually works is we will have to call the submit form, which, by the way, is what our endpoint is going to be, so that with the form, when I click send over here, it's going to run this URL, essentially, submit form, with a method that is post. So the action submit form will be posted when I click send. Let's save this and double check that it works. So I'm going to say submit form here. I'm going to save. And for now, I'm just going to return form submitted, hooray. If we go back and just write some gibberish, let's actually refresh, make sure it's new. If I click send, look at that. I get form submitted, hooray. And you see that the endpoint here is submit form. This was the action that we added in the HTML file. Again, if we go back, open up the developer tools, go to network here. Let's make this a little smaller. If I click send, look at that. In my network, you see that we have the submit form. If I click on it, I get the response, which is form submitted, hooray. And if I go to headers, you see that I did a post method because that's what I said. This is going to be me sending data to the server. You see that the content type is application xwww form URL encoded. This is just a standard data type that we can send when we use the form tag in HTML. But we don't need to worry about that because we now have access to the data that the user sends. So in the next video, we're going to try and capture the data that I sent to the server and actually read it with our Python code. I'll see you in the next one. Bye-bye. So we were able to submit our form. And ideally, now we have a way to capture that data that the user sends to the server. Once again, if I submit some sort of data and click send, I get form submitted, hooray. Now, if I open up the developer tools and refresh that, you'll see that we have a few errors that we have to take care of. One is this form submitted. So if I scroll all the way down, there's actually one thing I need to fix in order for my server to be able to read this data. We have to go into our contact.html, and we just have to make sure that all our inputs, that is email, text, and the text area, have a name attribute. And this is so we can actually grab the data on the backend. I'll show you what I mean. So let's have name here as email, name here as the subject, and then name here as the message. So that if I save this now, and I go back to my contacts and submit this again, well, we'll have to refresh it first. So let's refresh, send some messages. And if I click submit now, and we go to submit form, you'll see that if I scroll all the way down, I have a form data field. We now have email, subject, and message that we actually send all the way back to our Flask application. Because we now gave it these name attributes, it knows what to send. So this is just a quick gotcha. It's just an HTML form standard that we'll just have to add ourselves. Now, if we go to the Flask documentation, we can access these values using the request.form. So if we go back and we go to server.py, we can do something like they say in the documentation. I can say if request, and this request is something that we'll have to import, which I already have done from Flask. So if request.method, which is if we said that the method is going to be post, which if we looked at contact.html, we have the method as post. So if that's the case, then I want you to grab that data by doing request.form, and I can access different values like email or message like this. Now, an easy way for us to grab this information is actually to do a method called toDict, which is turning something, the form data, into a dictionary. So we're going to get everything as a dictionary. And then finally, to make sure that we get this data, let's just print data. and we just have to return something. So let's say return, and I want you to return form submitted for now. Otherwise, we'll just return something went wrong. Try again. If we save this, let's open up our terminal and let's go back to the form. Let's refresh. I'm going to close this for now and just submit our regular information. If I click send, form is submitted. I have some errors here that we're going to have to fix soon. But if I scroll a little bit up, look at that. We have email, subject, and message as a dictionary on our back end. We just transferred data to our Python app. How cool is that? Now, the reason we get this error at the bottom is because right now, when I submit a form, I'm still requesting the favicon icon. Now, if we go back to our application, you'll notice that anytime we visit a new area, our favicon is not showing. Well, if we go back to our page, let's go to index.html, we'll see that in the link over here, we're looking for our favicon.icon in static assets. But if you remember, we have our bolt.icon right in the static folder here. So all we have to do is just either rename some of those files, or in our case, we can just move this, call it favicon.icon, and move it into the static assets folder. Like so. Now if I refresh the page, you'll see that I have my new bolt favicon. Finally, I want to actually do something more interesting. Once a user submits a form, I want to have a little thank you message. Now, there's many ways of doing this, but the easiest way we're going to do is we're going to copy this entire file. So I'm just going to say duplicate and call it thankyou.html. Now, thankyou.html will be the exact same thing as the contact page that we created, except instead of the form that we have, so let's grab this form information. So instead of having this form, perhaps it will simply say, thank you. I will get in touch with you shortly. Just like that. Now, the cool thing that we can do here is that we can now redirect to the thank you page after they submit the contact form. And the way we can do that is in the server.py, we can import, let's make this a little bit smaller, and we'll import the redirect module. And all we have to do here, instead of saying form submitted, is we can say redirect to what route? Well, we'll redirect to thankyou.html. Like this. Again, because thankyou.html is in our templates, and because our routes are set up to change dynamically, we should be able to redirect to thankyou.html. If I save, and let's say refresh, submit some data in here, click send, look at that. Thank you. I will get in touch with you shortly. How cool is that? And there's many cool things that we can do here, right? Using the curly brackets like this, if let's say we ask somebody to submit their username or name, we can say thank you with perhaps their actual name that they submitted. So something like thank you Bob or thank you Ann. But that's something we've already talked about. For now, that looks pretty nice. So I'm able to now submit a contact form. Make sure that we don't get any errors. So if I click on send, look at that. HTML even tells me, hey, this has to be an email. Okay, let's send. And there we go. Everything is working. There are no errors. We're submitting the form with all our data, and we're receiving all that information right over here. How cool is that? So we now have our server.py set up to actually accept information. And now we have our website that's able to, well, hopefully allow us to have clients message you. But we need to do something with this data to store it somewhere. Because now this is in memory. Anytime I close the server, this information is lost. Ideally, we persist it somewhere. Or ideally, we store it somewhere so that in the future, we can go back maybe a week later and see who has submitted a form on our website. Let's do that in the next video. Hey, you're still there. I know this is a bit of a long project, but stick with me. We're getting really, really close. You see, up until now, we've built this whole system, right? We have our HTML, CSS, and JavaScript files that we got free templates for. And we also implemented our server so that the browser can actually send data to us, and we can actually save that data and even send a thank you HTML page back once somebody submits a form. Our web page is now something more dynamic than just text that people can read. People can now interact with our web page by submitting a form. And we now have sent this form data to our Python server. But there was a problem that I mentioned in the last video. That is, as soon as the server stops running, or maybe it crashes, that data is lost because right now that information of the form is in memory. Ideally, we write it somewhere on disk so that even if we stop the server, that information is still somewhere on a file. So that this file lives on this computer, just like a file lives on your desktop or laptop. So how can we do this? Well, we've done this before, right? We simply write to a file. Now, we're going to explore this topic a little bit more throughout the next couple of videos. But what I want to do is to close off some of these folders and create a new file in here that will be a text file. And this file will just be called database.txt, just a simple text file. And this database will act as our database where we store information that the server receives. So if you remember, we're going to store email, we're going to store subject, and then we're going to store the message. So ideally, we're able to append or add to this file as people submit the form. So how can we do this? If you want, pause the video and give it a try yourself. Otherwise, let's try this. We can create a new function here, write to file. And this write to file will receive some sort of data that we'll send. And we're going to say with open, again, something that we've seen before. And we're going to open the database. And again, because it's in the same folder as the server, we don't need to specify a file path. We can say database.text. And we're going to open in the mode of A. So that is to append to that file because it already exists. And we'll just call it as database. And in here, we'll say that the file will equal database.write and then write what we want. In our case, we want to write the email, the message or the subject, and then the message. And we can just extract that from our data, right? That we're going to pass in. So we can say that email is going to equal the data email. Subject is going to equal data subject. And then message is going to equal data message because it's a dictionary, right? And then all we can do here is just do an F string and say that we want first of all a new line so that there's a new line every time there's an entry. And we'll say that we want the email, comma, the subject, and then finally, comma, the message. So that's our write to file function. And then in here, instead of printing data, we can just simply call write to file and pass in the data. So let's save this and see what happens. I'm going to come back to the page and then click send. All right, looks like things have worked, but let's see if we actually wrote to file. If I go to database, look at that. I have my data, that is the email, the subject, and the message. And if I go back to the page, let's say go to contact again, and this time let's do a different email, some text, some more text, hit send, and let's go back. And how cool is that? We now have our own custom database where we store all these users' information. And the cool part is that even if I close the server, I still have this information with me. I can always come back and see who has submitted a form. Very, very cool. And if by now you realize this is how databases work, well, good for you. This is how databases work. This is why you hear the words database. A database is essentially a place for you to store data in a safe way outside of the server, right? Because if your information is in memory, as soon as the computer closes, well, that memory is gone. Instead, a text file like this, even if I shut down my computer and turn it back on, is always going to be on disk, and it's what we call persisting. That is, it persists so that it never gets deleted. But how can we make this better? Well, right now this is just a text file. This is kind of inconvenient and hard to read. Maybe we're creating a startup landing page and we're collecting users' information, maybe email, so we can email people when the startup launches. A better way to create a database is maybe using a CSV file or an Excel file. So in the next video, let's explore that. Welcome back. It's time to learn about CSVs or CSV files. Those are Excel files that we're going to try and create our database in. Now, luckily for us, Python has a CSV module. And we're going to use this CSV module to do the things that we're going to do, which is to write, instead of our text file, to a CSV file. Now, if we keep scrolling down here, you can read all about the CSV module and how to use it. But instead of going through it line by line, let's just code it and show you exactly how it works. So I'm going to create a new file, and this time it's going to be called database.csv. And let's go back to our server.py. And instead of having the write to file function, let's write another function, which will be the write to CSV. And this one will be a little bit different because we have to use the CSV module. So I'm going to actually import it. If we go to the documentation, you can see that we can import it just like this. Import CSV. That comes built in with Python. Now, in here, we're going to do something similar, except we're going to open the file that is the CSV file. We're going to append to this file, and we're just going to call it database, or in our case, database 2. So let's just say database 2 here. Now we have our data that we receive, but instead of a file now, we have a CSV or a CSV writer. So we're going to do a few different things here. First, we're going to write in our CSV these columns. Now, with a CSV file, by using these commas, so we have the email column, the subject column, and the message column, and the commas essentially say this is the end of this column, this is the end of this column, and this is the third column. So we can keep it the way that we have in the database.txt file. Now in here, let's remove what we have here. And we're going to say csv.write or writer to write to our CSV file. And this writer takes different parameters that we can give it. One is, where do we want to write this? Well, we want to write to the database 2. That is the file that we just opened. The second is a couple of options that we have. Now, if we go to the documentation and we scroll all the way up, you see that we have the writer, csv.writer, and then a couple of options. Now, this delimiter, quote character, and quoting are just options that we can give it that you can read on your own to tell it how we want to write into this CSV file. In our case, I want the delimiter to be the comma. That is, each item in a row will be separated by a comma. And whether we want any quotes around the characters, well, I don't want any, so this can just be an empty string. And then finally, quoting is going to be csv dot, well, we can just copy exactly what's over here. Let's just copy quoting, csv quote minimal. And again, just to practice this, let's say you wanted to know what quote minimal means. Again, we just look for that in the text, and it looks like instructs the writer object to only quote those fields which contain special characters. So essentially it's saying don't wrap data in quotes unless we really need to. Again, something that you don't have to worry about. This is more of configuration that you can just copy and paste. And you can read up on your own what each of these mean. The important part is the fact that we're writing to the database with some options. So now we have this CSV writer object that we can use. So this CSV writer can now be used like this. We can write a row, so write row, and this write row will contain the data that we want. And we have that, right? We want to write row exactly like we have above, like this. Except the way we write rows is that we give it just each parameter. So we want to give it the email variable, which we have here, the subject variable, and then the message variable. Just like that. Because we already have email, subject, and message, and the CSV writer is smart enough to say that these are going to be what we want, and we just pass it in instead of parameters actually as a list, like so. So that this row is going to contain email, subject, and message that we extract from the data. Now, if we didn't make any mistakes, this should work, but let's check this. Instead of write to file, let's do write to CSV. I'll save, go open up the terminal, go back to our page, and let's go to contact me again. Let's do w@w.com, some text, and hit send. Uh-oh. We have a bit of an error here. Quote character must be set if quoting enable. So it looks like I have just a bit of an error here. And that is because we actually need a quote character to not be empty in here. So if we're going to quote something, we just need to say, hey, what are we going to use? And in our case, we can use the quote sign with the double apostrophe. Again, we can use whatever we want. You might use this if you want, or this, whatever you prefer. So let's just do a quote that we use in a string. I'm going to save this, give it another go. Let's refresh. Actually, let's go back and submit again. All right, thank you. I'll get in touch with you shortly. And if we go back to our database, all right, we have our new data, but you see over here that we don't have a new line. Let's actually open this CSV file. If I go to database.csv and I double click here, all right, it looks like we're getting our data, but our database email and subject are a little bit off. Ideally, these are the labels and headers, and all the rows come after it. Now, let's go back and submit just a different user. Let's go A@W, add a couple of more, hit send. All right, we're adding new rows, but the only issue is that the first time we add a new row, we should have that extra spacing. Now, this is an easy fix. If we go to CSV and scroll a little bit down, we see that we have a write header method. So what we'll do instead is actually just add a new line option and just give it an empty string. So let's just clear everything. Let's just clear everything in here. We're going to save the database and just have server.py. We're going to go back and submit the forms a couple of times just to make sure that everything works. If I go back and go to my database.csv, all right, we have our data. If I open this now, there we go. We have our database right here with our headers and our entries, so that now I can have as many entries as possible and people can contact me, and I'll always have this database for me to check to see if anybody wants to work with me. Very, very cool. But there's one other issue here. That is, right now we're just using an Excel file on the same machine as the server. You see, there's a problem here because now my server and my database are in the same location. So yeah, when the server stops, my file is still saved. But what happens if maybe this computer breaks or something happens to it and I can't turn it on anymore? I've lost my files. Or maybe we have so much data that we want to store. Well, this is where actual databases come in. Databases specialize in storing information. Large-scale applications can use databases to store large amounts of data and then do really interesting things with them, kind of like an Excel sheet, but even more powerful. And on top of it, we can actually have a database on a completely different machine, maybe on multiple machines, so that we're guaranteed not to lose that data. Welcome back. Databases exist for us to store data that persists. That is, data that hopefully lasts for as long as we want it. So we can analyze the data, maybe we can grab it when we need it. And that's what databases do. And most of the time, when you're working with web development, you have the front end that focuses on the browser side of things. So that is the CSS, the JavaScript, the HTML. We have the back end, which is usually the server side, where we can use things like Python, Flask, Django to build a server. And then we also have this database side in the backend, where the server communicates with something like MongoDB, a type of database, to actually store this information. So instead of storing that information on an Excel file, like we have been, we can store it on an actual database, which gives us a lot more power. Now, again, this isn't a course about databases, so we don't need to fully go into the topic. If I go back to server.py, in the submit form, I want to wrap this in a try except block just so we can catch errors in a better way. So after the post, I'll do a try block, and we'll just indent this. And we'll also do a except here. And in here, we'll just return if there's an error, something, or let's just say, did not save to database. So that as we're testing this out, we know if something wrong has happened. In our case, we're going to check for the post. If it's not a post method, then we have an else condition that's going to return something went wrong, try again. And then we are going to try this piece of code. Otherwise, we're going to return did not save to database. All companies store data. From a simple record book of a small business, maybe even on a journal or a piece of paper, to massive companies like Amazon that need computers to store petabytes of data. Now, in order to store this information, pretty much every company, and sometimes individuals too, need something called a database. We saw in the last section how hard it was to have our server remember a new user. Every time the server crashed, the variable would get reset and then it would start all over. Or if we wanted to do a login or a sign-in check and iterate through the emails and passwords, doing a loop through JavaScript, that's inefficient. That's where database come to the rescue. So let's ask ourselves, what is a database? A database is a collection of data. And what we mean by data, there are many forms of them, right? There can be numbers, there can be dates, there could be password hashes, there could be user information. Databases allow us to organize this data in a way that is useful to us. And it makes data management easy. And something came out of that. And it's called Database Management System, or DBMS for short. It's a collection of programs which allows us to access databases and work with data. And it also allows control access to database users. So a DBMS is something in this box. Something that allows us a tool, a piece of software that allows us to communicate with the database, store information that's useful for us, and also allows us to update, insert, delete, look up, whatever is in the database. And this idea of a DBMS really started to take shape in 1960s. And now it is at the forefront of many exciting things. There's an entire industry of engineers that just work with databases because it is so important. Now, there are two types of DBMS that are really popular right now and that we're going to talk about in this course. And these two types are represented really well by Postgres and MongoDB. Let's talk about the first one, which is relational database. And this is probably the most popular. As you can see on the right-hand side, you see that all of these are relational databases. Postgres, Oracle, SQL Server, you may have heard of MySQL, SQLite. These are all types of databases that have this relational database tag to them. And the beauty with them is that they're all pretty much similar. They all follow a same standard format. Relational databases consist of two or more tables with columns and rows. So in this case, users is a table, and full name, username, text created at are columns, and whatever values they have here are rows. Each row represents an entry, and each column sorts a very specific type of information, like name, address, or phone numbers. And then the relation between tables and fields is called a schema. In a relational database, the schema must be clearly defined before any information can be added. And if this is confusing right now, don't worry, we're actually going to create these databases so it makes sense to you. If we had Twitter, for example, you can see over here the types of tables that we would have and how we would organize it. We would have a users table, a tweets table, a following table, and we can connect all these information, for example, by connecting different pieces of the table. For example, the username will be the same in the users table as it is in the tweets table. That way, we can say that the username in the tweets table is the foreign key of the username in the users table. And then from user will be the foreign key of username in the following table. Now, things like full name or ID, something that identifies each row in a table, is called a primary key. And we'll go through that later on in this section. All right, so all these databases, we're going to learn about PostgreSQL, but they're all pretty much the same. So once you know one, it's fairly easy to pick up the other ones. How do they actually communicate with a server, with the backend? Well, all relational databases use something called SQL. And SQL allows us to communicate, just like HTTP did, between the front end and the back end. With SQL, we're able to communicate with the database and modify or get or update however we want. And we'll have a video on this topic as well. All right, so that's relational databases. What about the second type? The second type is called a non-relational database or a NoSQL database. And once again, there are many, many different types of databases with some cool names like CouchDB and Hypertable. Now, a MongoDB or a non-relational database lets you build an application without having to define the schema first, unlike a relational database. If we go back to relational database, this schema or these tables have to kind of be predefined, right? We need to know how our app is going to look, make these tables so that once the app is public, we can start entering user information and tweets and followers. With a NoSQL or non-relational database, we can just define it as we go. And they all have different ways of storing this information. So each one is very, very different. And this is another powerful reason to use a non-relational database is that if your data requirements aren't clear at the outset of your project, and maybe you have a massive amount of unstructured data, you may not have the luxury of developing a relational database with a clearly defined schema. They offer instead a greater flexibility in that a non-relational database are more like folders, just assembling related information of all types. Now, MongoDB is something called document-oriented. It stores information as documents. Let me illustrate this point to you. I have my desktop here with two folders. One is a relational database, and here I have users, tweets, profile, following. And you can think of relational databases with this type of storage, where this folder lives somewhere on a computer that stores this information. And anytime we need to ask a database for something, well, we grab the users. And if we also want to grab the tweets of the user, we find the user that we're interested in, then find the tweets of the user that we're also interested in with the foreign key that links to the users. And we can also find however many followers that user has
we grab that information and display it on our web app. MongoDB, on the other hand, will actually have each user as a document. So if I wanted to grab the first user, well, I just grab this document and it has all the followers, the tweets, the profile, everything is in this one document. And you might be thinking, MongoDB looks like a better choice than having this way of doing things, right? Well, it depends on your need, and that's why databases is such a complex topic. It really, really depends on your situation. You can see this MongoDB way being very useful if you had something like a profile, maybe a LinkedIn profile. But if you needed something where you're working with just following data or just tweets data, maybe with the tweets, you want to see what is the average tweet size. Well, it's really easy to just grab this file and calculate that versus this way where you might have to extract it from each one of the users. So it really depends on your needs. Let me show you another diagram that might be useful. When we look at relational versus non-relational databases, you can think of relational as each table has a blog post, a blog tag, a blog comment, and it links these tables to give you the blog information. Versus a non-relational that stores this entire blog post in an entry and has comments, tags, categories, and all other related data just in one single place. So what does MongoDB use to communicate? If we go back to our example here, we had SQL for relational databases such as Postgres. Well, MongoDB has its own what we call query language. And it is just the MongoDB query language. But they both aim to do the same thing. That is to communicate with the database, provide an easy way for the server to communicate with the database. And in this section, we're going to be talking about that. And we're going to finally connect the dots and show you the power of databases once they're connected to a server. I'll see you in the next one. Bye-bye.
Welcome back. We have our Flask application that saves user contact information to a CSV file. And this is all great. It's working really, really nicely, right? We have a beautiful website. We even have contact forms. But there's a problem here. You see, we're running the browser as well as the server on the same computer. But this isn't real life, because if I give this URL to a friend, they're not going to be able to see it because this address points to localhost. It's saying localhost like this. It's the same thing, but localhost simply means your computer. So it's not like anybody else but us can access our app. That's not very fun, is it? Ideally, we can create this app so we can send it to all our friends, our family members, and possibly future employers. So how can we do this? In this video, I'm going to show you a really fun, easy way to deploy your application or your website online. We're going to use something called Python Anywhere. And Python Anywhere is going to allow us to host our files, that is, all the files that we have here, onto a server that they give us for free. So this is completely free. All you have to do is simply log in, and you can click on sign up. You can see that they have a different pricing plans. So you can actually pay for their service, but for a beginner plan where you can create one web application, we can do that for free. So let's create a beginner account and create your username and password. Agree to the terms. Sure, I've read everything. Oh, somebody else took my username. How dare they? Let's go with Andre N. So again, create your own account. And there we go. We have our dashboard. Now, the way Python Anywhere works is that we need to load up the files on a machine. Kind of like how we have our files over here on our computer, we need to somehow upload them to Python Anywhere's computers. Now, the way we can do that is using GitHub. So I'm going to open up my GitHub account. I'm going to click on New Repositories. And I'm going to create my project here. So let's just call it Portfo, because it sounds kind of cool and all the trendy names are short like this. So this is my portfolio project. I'm going to keep it public and then initialize with a README and then create repository. Now, from here, I'm going to clone this repository. If you have SSH set up, you can copy the SSH, otherwise use HTTPS, which might ask you for your GitHub password when you clone. So all I have to do now is to open up a new terminal. Let's make this a little bit bigger. And say git clone, and then copy and paste the URL so that it clones our project. Now from here, if I open this, we have our web server and then our portfolio, which is our GitHub account. So we can just copy the files here. Now, the ones that we actually need is we need the database, CSV, because these are going to be the files that we want to upload to Python Anywhere. So for now, let's just select the CSV file, the server.py, the static folder, the templates folder, because those are all the files that run our Flask app. Now, if I copy and paste this in here, you might be asking yourself, what about the other files? Well, there's a neat trick here, because these files over here were created because of our virtual environment, right? We have things like Flask installed. We have libraries like Python 3.7. We have our PyCache folder. Essentially, these folders created the virtual environment for us. However, there's an interesting trick here that we can do. We can run a command called pip freeze. And remember, you might have to do pip 3 based on what type of installation you have of Python on your machine. But if you do pip freeze with this little arrow and then requirements.txt, notice what happens as that requirements.txt gets added to my project. Watch this. Do you see that? I get a requirements.txt. And this requirements.txt, if we click on it, we see here that we have the requirements for our app to work. And the cool thing about this is that the Flask and then the Jinja for our templating, which we actually include in our libraries here, can now be used with the requirements.txt to not necessarily upload them to GitHub, but instead use this file as a way for us to install on any future machines any of these dependencies. I'll show you what I mean. For example, what we could do is upload all of these files to Python Anywhere, right? But that's a lot of files and a lot of work. Instead, we only upload the critical files that we wrote plus the requirements.txt, and automatically Python Anywhere is going to be able to install Flask and the Jinja and all the other requirements by looking at the requirements.txt. So for now, let's go back to our desktop and copy the requirements.txt as well into our Portfo page. So we now have all the files that we need for GitHub. If we go back, we can simply go into our Portfo folder and then simply say git add everything, then git commit and give it some sort of a message, my portfolio website. There we go. And then finally, git push origin master. And just like that, if I go back to GitHub and I refresh, look at that. I have all my files for my portfolio project. So using GitHub, we can now upload really easily to our Python Anywhere dashboard. The way we're going to do this is to actually now clone this repo with all these files, and we'll use HTTPS. Let's copy this and then go to our dashboard. Now in here, in the console, we can hit bash. So this will open up the terminal where our computer that is hosted by Python Anywhere exists. Let's make this a little bit bigger. In here, I can say git clone and clone this repo. There we go. And now, if we do ls, and remember this is a Linux machine, so Linux commands like ls is going to work. So we see that we have the readme text and the portfo. So let's go into portfo. And we see here that we have, look at that, all our files on our machine. Now, the cool thing is that if I go back to the dashboard and I go into my files, you see here that in the directories, I have a portfo project, which is my files that we've created. How cool is that? So I now have all the files necessary for me to run the app. But how can we run an app? Well, we have a web app tab. So remember, with the free tier, we get access to one free web app. So let's open up the web tab and add a new web app. So unfortunately, with the free tier, you can't have custom domain names. That is a way for you to say andrenagoe.com or whatever websites you want. Instead, they're going to generate one for you. But that's something that you can look into on your own if you want to pay for it. But for now, let's just use the free tier. So we can select the Python framework that we want to use. And I'm actually going to do manual configuration. We can pick whatever Python version we want. Let's do 3.6 for now because that's what we've been using. And then finally click Next. There we go. We have our Python project at this URL address. But if I click on this, all right, I get a hello world. It's working, but this isn't our portfolio. So how can we make that work? There's a few things that we need to set up. First, I'm going to link you to this tutorial on showing you how to set it up in case you have any problems. But let's go step by step. First, what we need to do is scroll down and enter the source code. So that is, where is the code that we're looking for? If you remember, let's go over here to Files. We have our portfo folder. So what we want to do in the web is to say that we want portfo in here. And it's going to automatically create that link for us. So that's where our source code, our server code exists. Now, if we go back here, we've gotten our code onto Python Anywhere, and then we have to set up our virtual environment. So we have to open up our console. Let's make this a little bit bigger, and then just run these commands. So in our case, because we're using Python 3.6, we're just going to copy this, go to our dashboard, into the bash once again. So that is the computer that we're going to serve our files from. And then copy and paste to create a virtual environment called my virtual env. And while that's installing, our next task is to install Flask. So once again, we'll copy this. So let's run pip install Flask. And you'll notice here as Flask is being installed that we're now in a virtual environment. See here how it says my virtual env? which was what we told it to name our virtual environment. And then the next step is to run this command. Well, actually, this command won't do anything because this command, work on, simply takes us to our virtual environment, which we already have created. This is for next time whenever you, let's say, go back and open up the console to make sure that you're always working in our virtual environment. Now in here, if I look at the files, I have my Portfolio project, but I can also run using the requirements.txt that we have. In case we have a lot of dependencies, we can actually run this command so that it reads our requirements.txt to install any dependencies. Oh, couldn't open up the file because we have to cd into our Portfolio first, and then run this command. In our case, we don't have that many requirements and everything is set since we installed Flask. But this is how we can use the requirements.txt to install all our dependencies. Awesome. So going back to the tutorial, we see that we've set up our virtual environment and we need to go to our web tab to set up our virtual environment so that it knows where the web tab to look for this environment. So going back, we can now go to our web. And I know this is confusing. This is what happens when you do configuration on a website. It's one of those things that you just have to learn or follow documentation. In here, in the virtual env, we will simply, as they ask, add the name of our virtual environment, which is my virtual env. So again, we'll copy this and automatically it gives us the link. Now finally, if we reload our application, it'll take a few seconds, but when it's done and I click, I get the hello world. Something is still not right because we want our server to be running, right? So it serves us the index.html. This video is getting long, so let's take a break and see you in the next video. Now the last step in order for us to deploy our Portfolio website is to go to the configuration file right here. When we click on this, you'll get a whole bunch of text. And we can actually delete a ton of these things. You'll see over here that you can have things set up based on what framework you use, like Flask. So because we're using Flask, let's remove all of this code. Just have the Flask section. And we'll remove the comments. So we have import sys. And it has some description here that you can read on your own. But the key thing that we want is to remove the comments from here. Just like that. And then we want to make sure that the directory, so Andre, has a path to Portfolio. So remember, our directory was home, username, and then the name of our project. Next, we want to make sure that we give the name as the name of our file. So in my case, it was server.py. If you remember, I have server.py right over here, and we're exporting it as app. So the app is the variable and server is the file name. So if you have a different file name, let's say you have run.py, then you'd put run here. So let's do server. Let's see it save. And let's go back to the web. If I reload and run this, we get an error. Now, an interesting feature of Python Anywhere is that we can actually look at the logs. So over here, the log files, we can see what errors or what the server is logging. So in our case, let's look at the errors. Module not found error. No module named server. All right, that's interesting. Let's see why that might be. So if we go back to our configuration file, the reason that we got the error was, well, because I misspelled the path. So it couldn't find the server. So port fo. If I save this, go back to web, reload, and click on our website, holy moly, we have our portfolio project live. That link over there, I can share with anybody, and they could see it on their computer. If they're halfway across the world, let's say in India, yep, they can see my portfolio. But you want to know what the coolest part is? Well, the fact that all of our pages work, but also our contact form. So if I do something like, let's make this a little bit bigger so you can see, r2.com, some subject line, and then, oh, somebody's super excited. If I hit send, that worked. And the cool part is that next time, let's say somebody contacted you, all you have to do is actually go back to Python Anywhere. So let's go to a new page of Python Anywhere. Go into the files, and then check out the database.csv, and look at that. You have a new entry into your CSV file. And I can even save the file, I can download the file, so that later on, a week from now, I can check up on the progress and see how my portfolio is doing. And now I hope you're starting to see the power that comes with this. We've created an entire web platform ourselves. We've created the HTML, CSS, and JavaScript files. Well, we used some templates, but we still modified them to our liking, and you can continue to update them and change them to your liking. But we also created a server ourselves that also contains a CSV file that will be saved on this machine. And we moved that machine from just our computers to someplace like Python Anywhere that has a dedicated server or a server space for us, so that it's always running. And this is how things like databases and places like AWS, Google Cloud, Azure, and any other database or server platform works. They allow you to use their machine. They make sure that they're going to run fast, that they're always going to be on. And databases allow you to save things. So instead of saving items in a CSV, we can save it into a dedicated database so we can do more operations or we can store more information. But I hope that opens up the world of web development to you and how everything is connected. In just a few hours, we're able to create a pretty neat looking portfolio, right? I mean, yeah, there was some configuration, some issues, but now that you know how to do it, I bet you see a whole lot of possibilities of what you can do. You can now customize this site, whichever way you want. Maybe learn a little bit more HTML or CSS to make the website a little bit more to your liking. Maybe you want to add some JavaScript to make it even more interactive. Or maybe you want to explore different things, like perhaps hosting this application in some place other than Python Anywhere, or maybe creating your own database. The possibilities are endless. So I hope this was exciting to you. This is one of my favorite topics, and it was a lot of things that we covered in a short amount of time. You're not going to be an expert web developer just from a few videos, but I hope this at least shows you the world of web development and how you might want to be involved in this world. Good job getting this far. This was a really tough section. If your brain hurts, don't worry, go take a nap, and I'll see you in the next video. Bye-bye. Let's talk about a possible career path when you know Python. And one is testing and automation. Now, what is that? Why would we use this? Well, think about it. If, let's say, you had a company that was working on an app, you want to make sure that this app works properly. And what a lot of companies do is hire people who can help with testing. Now, we have a section on testing with Python in this course, where we write unit tests through code. But usually when people work with applications, we're human users. We perhaps touch the screen if the app is on an iPad. Perhaps we scroll through and submit a form. We need to test and automate these steps to make sure our applications work. And companies hire Python developers in order to help with automation. You see, through programming, we can actually interact with something like a browser or an app and mimic human actions to make sure that the application works as expected. Now, this isn't just for phone apps. This works all across software. If you're working with software, you want to make sure that it works properly. And instead of hiring thousands of people to test your app, you could totally do that. You can also, through code, mimic thousands, millions of users playing through your app and testing out your application. So, in the next couple of videos, I'm going to show you how a testing automation person might work with Python. It's going to be a fun one. Through code, we're going to perform actions on the browser. Let's get started. Now, one of the best tools for browser automation is Selenium. And Selenium works not just with Python, but with lots of programming languages. But what it gives us is the ability to browse or use a browser without a human involved. Just through code, we can act and move around the mouse, click on buttons, and interact with a website. And in this section, we're going to be using Selenium. Now, in order to install Selenium, as you can see, we'll have to use pip install. Now, at the bottom here, you see that it says you may consider using virtual env to create isolated Python environments. Now, we already know about this, right? You could install pip install like this and have it available across your entire machine. Or you can use something like pip env to install it just for your specific project. Or you can use PyCharm and use their automatic virtual environments. Now, we've covered those topics in the other videos, so I won't here. In my case, I'm just going to install it globally like this. So I'm going to get started. First, we're going to install Selenium. So I'm going to say pip, in my case pip3, install Selenium. Awesome. Now, once you have Selenium installed, you can create a file. In my case, I have an automation.py file here. Let's make this a little bit bigger and this a little bit bigger. Let me clear this. Now, the next step is to, import in our file. So I can say import, or actually from Selenium package that we just installed, we can say import WebDriver. Now, WebDriver is going to allow us to drive the web through code. However, in order for us to be able to use Selenium properly, if you go to the installation page here, you see that there's something called drivers. You see, Selenium works with these drivers because each browser, like Chrome, Edge, Firefox, and Safari, has different drivers to interface with the different browsers. So based on what browser you want to use to automate things, you have to install each of these drivers. In our case, let's use the Chrome driver. So we would just click over here, and you can see over here that we have the different Chrome drivers that we can use. You have the current releases, so the latest versions. Now, usually the latest releases are not what we call stable. That is, maybe they're just brand new, so they haven't been tested enough. So what I like to do is to actually go to the Chrome driver tab here and make sure that we select the latest stable release. So based on when you watch this video, this version number might be a little bit higher, but as long as it's a stable release instead of the latest beta release, which is Chrome driver 76, then that's fine. So let's click over here. And you'll see that as soon as I click here, it'll give me zip files that I can install based on my machine. Now, in my case, I'm using a Mac, so I'll just install the Mac driver. And once I open up the zip file, you'll see that I get this Chrome driver executable. Now, an executable is kind of like a .exe on a Windows machine. If I double click this, it's going to run some code. It's some binary code that we can run on the machine. But this is our Chrome driver. This is going to allow Selenium to be able to open up our Chrome browser and manipulate that browser. Now, in my case, I'm going to move this to my desktop because that's where my automation Python file is. There we go. Now, if I close this, and by the way, if you go to PyPy and click on Selenium, the package, it'll actually explain some of these installation steps as well. So you can actually run through this quick setup as well. Now, in our case, now that we have the Chrome driver, what we need to do is to now create an instance of the browser. So let's just call this Chrome browser. And this is going to equal the web driver that we just imported. And then in here, use Chrome as the browser. And then inside as the parameter, remember this is the Chrome class that WebDriver gives us, we have to give it the driver in order to drive the browser. Now, because our Chrome driver is in the same directory as my file, I can just do a // or use a string and say Chrome driver, which is the name of the driver. Now, let's make this a little bit smaller so we can see everything. Now, in here, if we had multiple projects, we'd ideally use Chrome driver, not just copy and paste Chrome driver everywhere into our project folders, but instead, you'd put it into your path. What does that mean? Well, just like when we installed Selenium, when we did pip3 install Selenium, usually when you install something globally, or when you have it available globally, if you're on a Mac or Linux computer, you usually will put it under user local bin folder, and you'd put it inside of this folder. If you're on a Windows, you'd usually put it in its path in the Windows folder of the C drive. And if you do that, you can actually just keep this as blank. And the driver will actually look for the Chrome driver in this path. But in our case, we'll just leave it like this. So make sure that the Chrome driver is in the same folder as the file. Now in here, let's print out what we have as a Chrome browser. So I'm going to just run this file. Oh, and I get an error during handling of the above exception. All right, it looks like I get a file not found error, and that's because I made a little typo here. It should be Chrome driver. So let's save that again, give that another go. And did you see that? Chrome just opened up for me. So right now, automatically by running Chrome browser, I got an instance of the Chrome browser. So let's see what we can do here. Let's say we change our browser to just be like this. If I go here and do Chrome browser dot maximize window and run this method, let's run our file. Now, when we run this, nothing happened. And the reason is you see over here that we get an error, and you might get this as well. It says not created exception, message, session not created. This version of Chrome driver only supports Chrome version 75. So you have to make sure that the driver that you install, in our case it was the stable one, is compatible with the version of Chrome that you have. Most likely you'll have to update your Chrome version. So you see over here that I have version 74. But in here it says, hey, this is compatible only with Chrome version 75. So how can we fix this? We're simply going to relaunch. I've updated my Chrome version. Again, if you're not sure how to do that, you simply go to Chrome and go to About Google Chrome or Preferences, and you'll be able to update to the latest version or make sure that you're using the version that matches your driver. Now that we have version 75, let's try this again. I'm going to run my file. And look at that. I get Chrome is being controlled by an automated test software. So I've just created a new window, a new instance, which is what we've done here with the Chrome browser. And I've just said maximize window. Now, if I remove maximize window here, and I simply run this again, you see that right now I have another window, this time with the window, well, not maximized, just the default sizing. So every time I run this, I create a new instance of the browser. Very, very cool. Now, let's close these for now. And in the next video, we're going to explore how we can use this to actually move through web pages. Now, if you haven't gotten this far, take your time to make sure that the versions match, that you're able to run a browser from your command line. And in the next video, we're going to do some really cool things. I'll see you in that one. Bye-bye. Let's start getting into some interesting things we can do with Selenium. Now, what we're going to use for this exercise is going to be this website called seleniumeasy.com. Specifically, the /test part, because this website gives us a nice testing ground for us to play with a website. For example, if I do input forms here and do simple form demo, I can actually use this website to test out, typing stuff in, showing message, and seeing if we can do this with just code. So the first thing I'm going to do is copy this URL. And in our case, we'll just pick input forms and simple form demo. Later on, you can try it by yourself, trying out different things. But this tries to mimic most website functionalities, like form inputs, tables, alerts, and modals, and allows you to test your code really nicely. So let's copy this URL. And the first thing I'm going to do is, well, we're automation testers. We don't really manually type things in anymore. We let Selenium do that for us. So the first thing I'm going to do is say, hey, Chrome browser, I want you to get this URL. In my case, I'm going to say, hey, this is the URL that I just copied and pasted. Chrome browser, just get that for me. So let's run that code. And check it out. I've opened up the browser with Selenium and it took me to the URL that I specified. So most of the times, this is going to be your first line where we go to a specific URL. Now, I want a window to be maximized. So once again, we'll just say Chrome browser, and I'll say maximize window so that we'll have a full-fledged window this time around. Now, I'm going to close this once again because every time we run this code, a new window is going to open up. So let's just close it for now. Now, the next thing I want to do is to check that we're on the right page. Now, the way Selenium works is that it's going to look at this page and try to grab elements or find elements in this page. And it uses HTML that this page is built on to do this. Now, HTML simply is if I right-click on anything in the page and I click on Inspect, a developer console is going to show up. And in the Elements tab over here, it actually shows you how the page is structured using HTML. HTML is what allows web pages to get displayed in a browser. And they simply contain information about each element. In our case, see over here how it says complete automation testing tutorials? HTML says, hey, I want you to write this text right here. So that let's say we go to the name and slogan, or let's open up this. We see that we have Selenium made easy right here. We have an image, which is right over here. Essentially, HTML allows us to display some text and some basic content on a website. So with Selenium, we're able to grab these elements and check them and modify them and do what we want. Let's go all the way up and show you this. Each HTML page always has a title tag. And a title is simply what gets displayed up here at the top. In our case, it says Selenium Easy Demo. So what I can do is actually copy this and say, hey, in our code, is the string Selenium Easy Demo, is that in Chrome browser dot title? Now let's just print here and see what we get. I'm going to run this code. The browser opens up, and if I go back to the code, look at that, I get true, because that text is in the title. If I do something like Python Easy Demo, and I run this, you'll see that I'll get false. Now, an easier way for us to check our code than just running print all the time is to use the assert keyword that comes with Python. Now, you won't see this around too much because what's going to happen here is if we assert something, if this returns false, it's going to actually error out and exit out of the code. So if I run this, you'll see that I get an error with an assertion error. So this is a good way for us to test if something exists or not. But let's go back to what we had before, which is Selenium Easy Demo. That should give us true and not error in our code. Now, another thing here is we probably have a ton of windows here. So let's close them up. And don't worry, I'll show you how to actually close these later on if we want. So I showed you how I'm able to extract the title from here. Another thing I can do is, let's say, hey, I see over here in my HTML that there's a head tag and then there's also a body tag. So here, could I do something like, hey, assert body? If I click run here, it looks like we're not able to grab body. So what can we do here? Well, another way for us to interact with a page like this is using selectors. Now, the selectors, I'll provide a link to some of the cheat sheet here that we can use. But the selectors are simply ways for us to grab items from a page. We can grab items by ID, by name, by class name, by tag name, by link text. There's a ton of different things that we can do. Now, to show you over here how that would look like, if I go to the HTML page, over here, the elements, you'll see that if we wanted to grab, let's say in our case, we want to grab this button, well, I can right click, click inspect, and see over here that I have the button. It has a type, it has a class, and it has some text, which is show message. If I go to the cheat sheet, I see here that I can grab things by different options. We can do it by CSS, we can do it by the link text, we can do it by tag name, we can do it by class name. And you see here that it says driver.find element by class name. So this is how we can select it. So let's do that. I'm going to copy and paste this and simply say, hey, Chrome browser, I want you to find element by class name. And what was the class name that we used? Well, in our case, the class name is, let's say, button default. So I'm going to say btn default. And this is going to be our button. So if I run this and simply print button like this, if I run my code, you'll see here that I'm able to grab from the Selenium WebDriver a web element. And it looks like it's an element. I'm not really sure what's happening here, but we are grabbing something, a button. Now, this button element that we've grabbed is exactly like we see it here. If I, again, inspect the element, we've captured this part of the code. So this Selenium now contains this button for us to use. And as a shortcut here, you see over here how it says $$0. This actually allows us to select this element and use it in what we call the console. So if I clear the console and just say $0, you'll see that this is the element that we have captured. Now in here, there's different ways that we can interact with it. One of the ways is to say something like get attribute and an attribute called inner HTML. Now, inner HTML is simply going to grab whatever is inside of this HTML, which is the button, and then you can see over here that the button's closing. So we want to grab the show message. If I do something like this, let's say we call this button text, and we print the button text. If I run this, I'll actually get an error because you can see here that I did the syntax wrong. I tried to print the button text and then got the attributes. So instead, make sure we move the brackets like this and run the code again. There we go. You see over here that we have show message. So I was able to, through code, inspect the page, find out what I want to control. In this case, maybe it's this button. And I was able to grab the text using the get attribute method. Again, all these methods I will link to. They all are something that you just have to get used to when you get into automation. But if you understand basic HTML, then they're quite easy to understand. There's actually not a lot of them. I would say there's probably 20 or so really useful methods that you can learn and use. But you know what? Right now, this isn't that exciting. I mean, yeah, sure, we've opened up a browser. We got to, look at a button and display the text that it shows. But I want to actually mimic something that we would do on a browser. Let's say we had this input. And I want to modify this HTML page where I enter some sort of text. I click show message, and just like as if I'm signing into a website or upvoting on Reddit. Let's automate that in the next video. All right, it's time to do something useful with our Selenium driver. We want to try and grab this input, put some text in it, then click on show message, just like we would on a website, maybe where we're trying to sign in automatically to test the sign-in functionality or to test some sort of a form functionality in our app. How can we do this? Well, let me clear this first, just so we have a clean palette, and start with a few things. The first thing I like to do when working with Selenium is to make sure that as we progress through the code, we're doing things correctly by using these assert commands. So I can say assert, and we want to assert that this button text, which we're going to use, which is show message, we want to assert that this show message actually exists on our page. Now, an easy way to check this is to say Chrome browser, and instead of title, we want to just check the page source. And page source is simply, if I right click here and look at the view page source, is simply the HTML version of the entire website that we see, which should have the show message button. So by doing this, hopefully, if everything works up until line 12, we should just get true without any errors. So let's run that. All right, we don't get any errors. Everything is good. Now let's move on. The first thing I want to do is grab this input. So I'm going to inspect. Or let's close this so we have a better view of this. And use inspect on the input. We see that the input over here has it has an ID of user message. So we can grab this with ID, if you remember. And we scroll up to our cheat sheet here. We see that we can grab elements by ID using the find element by ID method. So let's do that. I'm going to say Chrome browser dot find element by ID, and the ID name that I wanted to grab was the user message. So let's do that. I'm going to say user message. And the first thing I want to do now that we've grabbed this ID is I want to make sure that there's no text in here, maybe from a previous user. So usually when grabbing inputs, I'll do something like user message. Let's create a new variable here called user message. And I'm going to say user message dot clear to clear wherever is in the input. And then from there, oh, and let's make sure this is underscore like this. And then from here, we can use the send keys. And send keys says, hey, in the user message, send these keystrokes as if a user is typing and give it the string. Let's do, I am extra cool. That's kind of silly, but that should be fine. So we're going to mimic typing I am extra cool into that input after we've cleared it. So let's see if this works. I'm going to run. Whoa, how cool is that? Do you see that? We just automated typing into a box and it says, I am extra cool. Awesome. Now the next step is we want to grab this button and then simulate a click on it so that your message gets displayed on here. If I click show message, you see that I get this printed. Let's close some of our browsers because I feel like we have a ton of Selenium browsers open right now. That's better. So now that we have this, once again, we can select the button. So remember, we can select the button just like this. But, well, let's not call it button text. And I like being specific here, so let's call this show message button. Now this show message button, which we've grabbed before, the first thing we want to do is to, well, simulate a click. Just like that. So we send keys and then we click. So let's see if that works. I'm going to save this and run. Looks like that didn't work. Let me check what happened. We get a name error. Button text is not defined. Oh, and that's because we did not fix the naming in here in the print function. So let's just change the name here. We can actually just comment this out because we don't need it printed anymore. And let's run it again. Whoa, did you see that? Also, did you notice how fast that happened? I am extra cool. It got click show message and now my message appears. Very, very cool. Let's say that we wanted to grab this information. What can we do? Well, once again, we can right click. So let's use our default. Let's right click, inspect. And you can guess by now that this is starting to get easy. We see that we have the ID of display. So we're going to grab that and say this is going to be the output message. And the output message will be the Chrome browser dot find element by ID and give it the display. And maybe now to verify that this is working, I'm going to do an assert method and say, hey, I want to assert that the I am extra cool, how many O's is that? 4 O's, that looks right, is in the output message. And what we want to do is to actually see the text. So we can actually say the inner HTML, like we've done here with get attribute, or we can just say text. So if I run this, no errors, everything is working. Now, this is a simple example, but did you notice how fast everything happened? I mean, if a human was to do this, you'd have to select here and type this in. Then you have to click show message, and then your message finally gets displayed. The reason testing automation is such an important part of software development is that you can do things really, really fast. You let the machine control the browser extremely fast so you can test as many times as you want, millions of times. You can simulate clicks, you can enter information, just anything that a human can do, Selenium lets you use as well. Now I want to show you one other way to select that is very, very common. We've seen that we can do find element by ID, find element by class name, but another very useful one is something called Chrome browser dot find element. Instead of class name, we use something called CSS selector. And CSS selector, we're not going to learn CSS here, but CSS in a browser is the styling that you get. So for example, if I was to look at the button and I do inspect, you see that the class has button default. And in a class, this is what we call CSS. This tells it, hey, these are the styles that we want. You can see over here in the styles tab that we have button default and button. And this controls our styles on a web page. For example, if I uncheck this, my button, well, now has no styling. If I uncheck some of this as well, again, the button styling goes away. So we're actually able to use CSS selectors, again, something that you can Google on your own, or I teach my other courses, to actually grab this. So the way we would do something like this and grab button default is to use the, let's say, CSS class dot button. And this is a CSS selector. For example, if I wanted to grab all buttons that are under the form get input, which is ID get input, then I would do pound, which stands for ID, get input. And then say all forms that have the ID get input and anything that is a child button, I want you to grab. So that if I do user message or user button, I'll say 2 here. If I print this out now and say user button 2, this should have been selector, not select. Let's fix that. You see that I'm able to grab this element that way as well. All right, let's take a break because check out all the windows that I just opened up. This is getting a little insane. So in the next video, I'm going to show you how to close all of these. I'll see you in the next one. Bye-bye. Welcome back, Automation Masters. Now, up until this point, we've ran this code quite a bit of times, and you see that now I have a ton of Chrome browsers open. That's not good. How do we close these things? Well, quite easily, actually. All we have to do is say Chrome browser.close. Now, this close method is going to close our browsers. However, a lot of people sometimes have issues with this method because browsers are constantly being updated. And sometimes Selenium has some bugs where it doesn't close this properly. So this may work for you. Now, in my case, if I run this, all right, well, that actually worked, But there are instances where this won't work, so you might have to actually call this twice to make sure that it closes the instance. Now, using close is going to close the current window that it's open, which is what we're doing here. With quit, you actually get to close the entire Chrome driver. So let's do quit now and see if this works. All right, so that also quit the browser, but if in your code for some reason you're opening up the browser twice, it's going to quit all sessions. Unfortunately, because these ones are all past instances, it's not going to know how to quit them. We should have, quit them from before. So you're going to have to manually close these for now. But at least now you know that you just add this at the end. Sorry for showing you how to do that at the very end. But I had to keep it open so I can explain all these things that are happening to you. But ideally, you quit the browser afterwards. Now, this quit and close actually causes a lot of headaches, and sometimes it may not work on a browser. This depends on the versions that you have installed. There's a ton of forums online that you can look up and say, hey, why isn't my browser quitting? So it's a heavily debated thing that you can find information online on. If it doesn't work for you, you might have to call this twice, or you might have to check that the version you're using is working properly. Now, some of you might be asking, this gives you a lot of power, right? Because, I can start writing bots to go through websites. Maybe I want to write a little bot that goes on every single Reddit post and upvotes it. Or maybe I click like on a Facebook page over and over and over. Maybe there's a voting contest going on, and I can just write scripts to automate people signing in, random people signing in, and upvoting, let's say, your submission. So there's many good ways to use automation and many bad ways to use automation. Maybe you want to send personal messages to your Facebook friends. Well, you can automate it and message thousands of them all at the same time using something like Selenium. But you see, websites are smarter than that, because most websites will detect when it's a robot controlling it versus when there's a human, because of how fast things are happening. No human is going to be able to send keys and click that fast, right? So Selenium actually has thought of that. If we actually go back here to the site that I originally showed you, which I'll link to, if you scroll all the way down to waits allows us to actually wait and simulate actions at a bit of a delay. So most people that write automation scripts on websites will use something like sleep or wait to make sure that there's pauses in between actions, so that, websites aren't going to say, hey, this is definitely not a human. I'm going to block their usage. For example, here on the Udemy website, I tried to write a script that did things really, really fast, and you'll see that Udemy actually blocks my activity and says, hey, please verify that you're a human. So that it says, hey, I'm detecting something that makes me believe that this isn't a human. I don't want our servers to get logged with all this activity because, companies like Udemy have to pay for, let's say, interactions on the website because they're talking to backend servers. So you'll notice some of these things. And you want to be careful with automation that you're usually testing on your own product or your company's product, and that you're not abusing the other websites and trying to, let's say, game the system. But using something like wait actually allows you to at least not do things as fast as possible so you don't get detected as easily as possible. With great power comes great responsibility. And Selenium is a great tool for testing. A lot of companies hire testers and automation testers for this specific reason. And it's a great career option for you. However, you can also do bad things with this. So be responsible. Don't do anything that might get you in trouble. not advocating for anything of that. But I hope this gave you a little test into what automation testers do. And you can use Selenium not just on browsers. You can use them pretty much on any screen. You can run them on Android devices, iOS devices, pretty much any screen. I hope that was fun, and I'll see you in another video. Bye-bye. Oh boy, here it is. The coolest sounding section in the entire course, machine learning. Now, throughout the course, we've learned that machines are really, really good at certain things. Machines can perform tasks really, really fast. And we learned through Python that we can control these machines and get them to do tasks for us. Now, these machines or computers are really good at things that we can describe, right? That we can write in code. If-else blocks to do something. Computers are really good at working on tasks that have these defined rules. All the way up to a game of chess, right? When you play a game of chess against a computer, we could technically have if-else blocks, lots of them, to see how to move each piece and what the pros and cons are. But then as soon as we stop having these specific rules, things start to break down. For example, what is a cat? If you could describe that to a computer, or you had to program in Python and try to write that code in Python, would you be able to? I mean, sure, you can say, hey, a cat has fur, a cat has whiskers, a cat meows. But then the computer asks you back, what is a meow? What is fur? The harder things become to describe, the harder it is for us to tell machines what to do. In this section, we're going to tackle this problem. And we tackle this problem using something called machine learning. And you've definitely heard of it because it is a big buzzword right now in our industry. Because with machine learning, you have so many applications. We could have self-driving cars, robots, vision processing, language processing, recommendation engines, translations, stock price predictions. There's so many applications. The goal of machine learning is to make machines act more and more like humans. Because the smarter they get, the more they help us humans accomplish our goals. Now in this section, we're going to go over some theory to get us familiar with this topic, and then do 3 projects on both data science and machine learning to understand this topic a little bit more. Don't worry, don't get intimidated. We're going to try and simplify things and have fun along the way. Let's get started. Now, up to this point in the course, we've talked about Python careers, and we've talked about being a backend developer using Python, about testing and automation, about being a general Python developer and doing scripting, being a software engineer and just writing software using Python. But we haven't really touched on the subject of machine learning or research analyst, data scientist, data analyst. And you see, all these fields kind of overlap. So what is machine learning? When we talk about machine learning, you have to keep this diagram in mind. You see, it all starts with AI, or artificial intelligence, which simply means human intelligence exhibited by machines. An AI is, well, a machine that acts like a human. And currently, in our industry, we have something called narrow AI. That is, machines can be just as good or even better than humans at a specific task. For example, detecting heart disease from images, or at the game of Go, or even video games. But narrow AI that we have currently simply means those machines can only do one thing really well. They can't be like humans and have multiple abilities. That's called general AI, and it's something that we're very, very far away from. Now, machine learning is a subset of AI. And machine learning is an approach to try and achieve artificial intelligence through systems that can find patterns in a set of data. And actually, Stanford University describes machine learning as the science of getting computers to act without being explicitly programmed. That is, getting machines to do things without us specifically saying, do this, then do that, then do this. And don't worry, we'll explore that more throughout this section. Now, you may have also heard of deep learning. And deep learning, or deep neural networks, is just one of the techniques for implementing machine learning. For now, you can just think of it as a type of algorithm. But then we have this thing of data science. And often the role of a data science and a machine learning expert are quite overlapping. And most job descriptions actually don't even have a clear distinction between what is a machine learning expert and a data science expert. The field of data science simply means analyzing data, looking at data and then doing something with it, usually some sort of a business goal. So when we talk about machine learning, there's a lot of overlap with data science. So throughout the next couple of videos, we're going to be talking about both of these topics because both of them relate and overlap. And you can't do one without the other because you need to be able to understand data and work with data to do any of these things. And that's why when we talk about careers, often things like machine learning, data scientist, data analyst, or research analyst are similar because they all work with data. And from that data, they want to derive some sort of an action for the business, for the company, or for the person. All right, that's enough for now. Let's move on to the next video. All right, I know what you're thinking. You're thinking, Andre, I have no idea what you're talking about. What is machine learning? You haven't really told me anything. I have nothing to apply it to. Well, let's go back to this topic of machines and computers and the fact that they don't really understand words, right? If I ask my computer, hey, is this a snake? Is this a python? My computer is going to, have no idea what I'm talking about. When I look at an image of a snake, no matter what color it is, no matter whether it's a cartoon or a real life image, or whether it has different directions with different animals in it, I can identify a snake right away. Our brains just know. But to tell my computer what a snake is almost impossible, right? Because there's so many factors. A snake doesn't have legs and arms, but an airplane doesn't have legs and arms. A snake has scales, but then the computer is going to ask me, what are scales? But with machine learning, we can actually teach a computer to know what a snake is, or at least pretend like it knows. So how do we do this? Well, you remember this diagram, I hope. It's simply what we do in programming. That is, we give an input, let's say a list of 1, 2, 3. We give it to a function, and there's an output of 2, 4, 6. So clearly this function multiplies our list, items in our list, by 2. And often our programs are procedural. That is, we have if this, then that, do this, then this type of conditions. We tell the computer what to do. We write as programmers the input and the function. And all the computer does is actually just calculate using the input and the function, the output. And it can do that really, really fast for us instead of having a human do something when, let's say, a list is millions of items long. Machine learning changes this idea. It says, hey, give me the input and give me what you want the output to be. That is, give me all the data that you have. And by the way, tell me what the answer is, or at least what the output that you want. So in this case, I want the input to be a list of 1, 2, and 3, and the output to be a list of 2, 4, and 6. And then the interesting part is that as developers, we give this input and output, but with machine learning, we say, hey, machine, you figure out what this function is. Because if I give you, let's say, instead of a list of all these snake pictures or maybe animals, and I want you to tell me if this image has a snake or not, or maybe these 100 images, which one of them have snakes? Well, I don't know how to tell you how to do that. So instead, you figure it out yourself. Here are all the pictures, and here is what I expect the output to be, either snake or not snake. And with machine learning, the function is generated or created by the machine. Sounds really cool, doesn't it? And this is machine learning. It's simply a function. So instead of us writing the function like we have before, with machine learning, the machine writes the function. We just give it the input and the output. And the word function can be replaced with a model. You might have heard of the word machine learning model. That's all a model is. It's a function that receives an input and returns an output. Another word might be algorithm, a machine learning algorithm, a machine learning bot. And at the end of the day, it's a brain. We're pretending that this machine is a brain that understands the inputs and gives us the desired output. Now, the interesting side effect of this is that often when we talk about machine learning models, these functions are really hard to understand. Because the computer comes up with this function, as a human, it's hard to really understand how it works. And as these models get more and more complex, it becomes harder and harder for us as developers to understand how it works, which raises a lot of issues. But we don't need to get into that. Now, as you can see, the main part of this is that in order to train this machine to create this function, we have to give it data. And for it to be really, really good, we have to give it lots and lots of data. And then we want to test to make sure that this data that we give in gives us the correct output. So at the end of the day, machine learning is simply a computer writing its own function based on the inputs and outputs. That's pretty cool, isn't it? I'll see you in the next video. Bye-bye. One thing that I really like doing in my courses is to actually understand the why of everything. Everything that we learn, there should be a reason we're learning it, right? And you might be asking yourself, why do we even care about machine learning? How is that useful and how do we get here? Well, if you think about a business, because most technology evolves from business needs. We have the advent of computers and the ability for businesses to use computers to do things really, really fast and efficiently so that they gain an edge. And then we got spreadsheets. Spreadsheets like Excel files and CSV files were amazing because we can store data that businesses generate, such as maybe customer data, into an Excel file. And then people got really, really good at analyzing these CSV files, these spreadsheets, to make business decisions. Maybe forecasting that December sales are going to be high because, well, the past 2 years we've had really high December sales because of Christmas. And then as companies got more and more data, we started getting this idea of relational databases. Spreadsheets were great, CSV files were great, but we started getting more and more information and data, and we needed a better way to organize things, to understand things from our data. That's when we got things like MySQL, which allowed us, instead of using spreadsheets, to use a language called SQL to read information from our database, write information to our database, but similar to spreadsheets, use the data that we gathered from the business to make business decisions so that our business becomes even more profitable. And then in 2000s, we had this fancy term of big data. We had big companies like Facebook, Amazon, Twitter, Google that started accumulating more and more data. an insane amount of data that you simply couldn't contain in a spreadsheet. User actions, user likes, user purchasing histories. This idea of big data meant that we had so much data. These companies had so much data. And sometimes, unlike relational databases, which had to be a structured form of data, sometimes we got really messy, unstructured data. And that's when we started getting this idea of NoSQL, where things like MongoDB came into existence, where you can store unstructured data and hopefully make business decisions out of that. Maybe if you were Amazon, you can use customers' purchasing history to recommend different products. And ever since then, this idea of data, getting more and more data, has turned us into using machine learning. Because at some point, we have so much data that as humans, we can't just look like we did at spreadsheets and look at columns and rows and make business decisions. I mean, we still could, but then we'd be wasting all this data that we've been getting over the years. So companies like Facebook and Google that collect massive amounts of data every single day are turning to things like machine learning, so that instead of humans looking at the data and trying to figure things out, we give this data to machines so that they're better able, even better than humans, to make business decisions. And this idea of machine learning really came to be because of this growth in data that we received from businesses, as well as the improvements in CPUs, GPUs, that is graphical processing units, and computer advancements. So using the massive amounts of data and massive improvements in computation, we can use these machines to give them this big data and make decision for us, just like we used to with spreadsheets. Now, this is a simplified version of how we got here, but I hope it gives you a reason as to why businesses like this idea of machine learning. I'll see you in the next video. Bye-bye. Welcome back. Up until now, I've been blabbering on about what machine learning is, and I hope you have a bit of an idea of why we have it and why it's useful. But at the end of the day, the only reason that we care about machine learning is that we're able to use machines to predict results based on incoming data. That's it. Now, this idea of machine learning, and don't worry, I know we keep talking about theory, but I promise we're going to get some coding exercises first. But I do want to talk quickly about some of the machine learning categories that you often see. And keep in mind what I said. That is, machine learning is simply about predicting results based on incoming data. And all these subcategories simply do that. For example, we have the idea of a supervised learning, which is a subset of machine learning. In this supervised learning, the data that we received already has categories. Think of it as a CSV files with rows and columns labeled. We have labeled data and a test data that is labeled so we know if our function is right or wrong. So in a supervised learning scenario, we can do things like classification to decide, is this an apple or is this a pear? Machine learning model simply draws a line to decide, hey, this is an apple and this is a pear. Or we might do something called regression instead of classification, based on inputs. For example, predicting stock prices. Another way that we might use supervised learning is, for example, to hire engineers based on inputs, based on years of experience, based on maybe age, maybe where they live, what type of computers they have. All these sorts of inputs that are labeled can be used in a supervised learning system to decide, should I hire this engineer or should I not? Now, sometimes we have data that doesn't have labels, and this is called unsupervised learning. Again, think of it as a CSV file without perhaps the column names labeled. Sometimes with things like clustering, we need to create these groups or at least the machine, to create these groups. For example, we give it a bunch of data points, and then the machine decides, oh, this is a group, this is a group, and this is a group. Or we can have something like association rule learning, where we associate different things to predict what a customer perhaps might buy in the future. When groups don't exist, we call it unsupervised learning. We can't tell the machine that they are right or wrong like we can when we do apples versus pears, since there are no true categories, but we let the machines just create these categories for us. Finally, we have this idea of reinforcement learning. And reinforcement learning is really interesting because it's all about teaching machines through trial and error, through rewards and punishment. So the program simply learns a game by playing it millions of times until, well, it gets the highest score. It doesn't know what it's doing at first, but then it tries to maximize the score and eventually figures out that, hey, maybe I should try and move where the ball is coming. So this is seen for skill acquisition or real-time learning. And you see it a lot in machine learning programs that play, for example, video games. Now, I'll link to a resource so that you can dive into these topics more deeply. And we'll actually talk about this a little bit more and understand them a lot better once we go through some of the exercises. But the idea here is that machine learning has different categories and different ways to accomplish its goal. And topics like neural networks, decision trees, support vector machines, k-nearest neighbor, are simply algorithms that are used with these subfields in order to come to these predictions. But remember the key thing. All of these, what they're doing is trying to learn from the data that it receives and predict something. I'll see you in the next one. Bye-bye. All right. I think it's time for us to actually start practicing some of these skills instead of just talking about theory. Because I know right now, everything looks super complicated. You think that to be a machine learning expert, you have to have a PhD and you have to be really, really smart with math and statistics. But often that's not really the case. So in this video, I want to show you what it actually means to do machine learning or data science. So in this Machine Learning 101, let's talk about what a machine learning expert does. The first thing that a person does is to usually import the data. That is, we have some sort of a CSV file, and we're going to import that data, and we know how to do that with Python, right? We import a CSV data file so that we can use it in our program. And don't worry, these are the steps that we're actually going to show you when we do our upcoming projects. So the first thing is to import the data. Next, what do? Well, we clean the data. That is, in an ideal world, we have perfect data. All the columns, all the rows of a CSV file are filled in, and everything is perfect. But that's often not the case. Sometimes you have missing labels. Sometimes you have missing cells or data. And sometimes we have just unusable data that's really, really bad. So we ideally clean the data so that when we use it later on, it's not going to give us any errors or make bad predictions. Now, number 3, what does a machine learning expert do? Well, we split the data. And this is an interesting one. We usually split the data into what we call a training set and a test set. What does this mean? Well, splitting the data simply means just deciding we have, let's say, 100 rows of Excel, and we decide that the 80 rows are going to be our training set, what we give the machine to learn from, and then the last 20 rows are going to be the test set, because we have to tell the machine whether it got the answer right or wrong. So we need a way for us to test with our pre-existing data whether our model is good or bad. Again, this is something that we'll explore, but usually you split your data, your Excel sheet, into a training set, what we use as input, and then the test set, what we use to test the output that machine learning function gives us. And that's really easy to do. We just decide, hey, 80% of the data is going to be training set and 20% is the test set. Up until now, these three things are pretty easy, right? And as we'll see, they are quite easy. Next is we create a model. All right, this one sounds really, really hard, right? We just went from splitting data to all of a sudden we're creating this function, this model that our program creates. But the funny thing is that most likely what you do when you create a model is to import an algorithm. You're not going to write the algorithm from scratch yourself. Usually you use a library like scikit-learn, which we're actually going to use to simply do an import and then decide what algorithm you want to use, like decision trees or k-nearest neighbor, and we'll actually see how to do that in an upcoming exercise. So that's really nice. Somebody has already built an algorithm for us that creates the model based on our training set. And the running joke is that when people think about machine learning expert, they think of all these mathematical equations that people do, but most of the time it's people just simply importing from a library an algorithm. That's it, a one-liner. Next, what do you think we do? Well, we check the output, right? We create the model, that is the function. We have the input, which is the training set, and then we check the output of this model with our test set. So the test set, we're going to say, hey, is the output matching what we expected? So once we check the output, what do? Well, we improve. So most likely the first time around, it's not going to get it completely right. So based on the test set, we say, hey, we can probably improve something. So as a machine learning expert, you might give it extra inputs, that is maybe an extra column in the Excel file, or you might want to change the model or the algorithm that you used to create this model. That's it. These are the 6 steps of what you do, and you just repeat these steps. Now we'll come back to these and I'll link to this in the resource so that you can always have it in the back of your mind. But right now, you just learned something really, really fundamental. You see, Facebook here, this is pretty much how they run their machine learning pipeline. And this diagram now should make sense just on those 6 steps that we talked about. We define their goals, that is, what do we want to accomplish? We gather the data. We parse the data, that is, we clean it, we split it into training data and testing data. We then do model creation and we experiment with different algorithms. And then we finally test our data, see how accurate it is based on our testing data. And then we just go back and try different things until our model or our function is in line with what we defined as our goal. Isn't that cool? You just learned how Facebook's machine learning structure works. Now, let me ask you one question before I end this video. What do you think the hardest part of this entire process is? I made it sound very, very easy, right? Think about it. Ready for the answer? The hardest part is actually grabbing the data. Because the more data we have, the better. The more inputs we have, the more training sets we can have, so that we can improve the model. And yes, we can decide what algorithm to use to create a model, what inputs to use during the training set, but the more data we have, the more options we have as machine learning experts. And it's really tough to collect good data, or what we call data set. And companies like Google and Facebook, are really, really valuable because they're the only ones that can collect that much data. And that's why machine learning is pioneered by these companies that have large sets of data. Because you and I just simply don't have enough data to really make machine learning worth it. Most companies don't actually need machine learning or can even implement good machine learning because they don't have enough data. You need big companies like Amazon to use machine learning because they're the only ones to have access to that data. And that's why they're so valuable. They can share their model, they don't care, but they usually keep their data private because that's what gives them a competitive advantage. All right, so now we know the steps of machine learning. The next is to learn what tools we can use to do these steps so that we can finally start learning and building our own machine learning models. I'll see you in the next one. Bye-bye. Welcome back. So up until now, we've learned the steps of machine learning, and we learned the theory about machine learning. The last piece of the puzzle is what tools do we use in order to learn about machine learning so that we can finally start doing some exercises and projects. And this is why Python is actually one of the most popular languages when using machine learning. Because Python has such a big community and it's such a easy expressive language, as we've learned, that it has a ton of libraries and modules that really help us do machine learning in a really fast, efficient way. It's not that Python is just the only language that you can do machine learning in. It's that Python has the best tools available currently to do machine learning. So what are these tools? The first one is NumPy. And NumPy is definitely a must when it comes to machine learning. It's a library that helps us to use lists and arrays in Python, and specifically multi-dimensional arrays, which are used very, very often in machine learning. So we're going to be using NumPy. And then the next one is Pandas. And Pandas is used for what we call data analysis. Pandas gives us an idea of this data frame, which allows us the functionality to manipulate data in tabular structure with rows and columns. That is, we get to usually read a CSV file using Pandas. It's going to extract this data into something called data frame, and you can do all these amazing transformations and aggregations using these data frames. And don't worry, I'll show you how to do this in the next video. So we have NumPy for working with lists and arrays, Pandas for usually working with something like tabular data, so CSV files, and then we have scikit-learn. And scikit-learn is that really exciting create a model part, where we import the scikit library, and scikit comes pre-built with, as you can see, different algorithms that we can use. So we can do classification, we can do regressions, we can do clustering, just by importing this library. And then we use something like matplotlib. Now, matplotlib, again, is another library, what we call a charting library. It allows us to visualize data in a nice way. And there's many tools that are built on top of matplotlib that help us visualize data in any different way that we want. Finally, the two last crucial tools that we need is, first of all, Jupyter Notebooks. If you remember, in the developer environment section, we talked about Anaconda and how Anaconda, by installing it, gives us access to the Jupyter Notebooks. And Jupyter Notebooks are really, really useful because up until now, we've written code in PyCharm or Sublime Text or Visual Studio Code. But Jupyter Notebooks are really, really useful when we do machine learning or data science because, as we'll see, it allows us to step through our code and actually output and keep track of all these things that we've been doing. and also see visualizations, something that you can't really do in a text editor like Sublime Text or PyCharm. So you can step through each data analysis stage and have these notebooks visualized and potentially even give to different people in your company so that you can create a story and share it with others. So it's a notebook that allows us to communicate better. And it's a very critical tool that is pretty much standard now in the data science and machine learning field. And as you can see, these are crucial tools in our tool belt that we're going to use throughout the next couple of videos. But all of them work really, really well with Python. And it's why Python has become such a standard in the machine learning community. The final piece of the puzzle, though, is that data, right? When we import the data and clean the data, we talked about the most difficult part being the actual collection of the data. In order for us to learn about machine learning, we actually need some data to work with. Now, we're not Facebook or Amazon or Google or Apple, but there's another useful tool called Kaggle. And Kaggle is a community of machine learning experts where you can do competitions, you can look at other people's Jupyter notebooks, but it also has data sets. That is, we have free access to data, to massive amounts of data that are openly accessible. If you want to learn about crimes in Boston, about the PGA Tour, about gas prices in Brazil, you can actually download for free these data sets so that you can play around with machine learning. And we're going to do just that in the next video. So for now, make sure, if you haven't, get your Jupyter notebooks ready. Again, check the developer environment section where I show you how to set this up, and then create a free account on Kaggle because we're going to start getting our hands dirty with some coding. I'll see you in the next one. Bye-bye. It's time to finally start coding. And in this exercise, we're going to be exploring some data that we're going to grab from Kaggle. It's time to do some coding. So open up your Jupyter notebooks. Now, in my case, I already have some files here, but usually it'll just be whatever files you have on your desktop. It doesn't really matter because we're going to create a new file here and make sure that the notebook is going to be in Python 3. So once you create that notebook, title it whatever you want. In our case, we're going to be exploring some FIFA soccer data sets. So let's just call it soccer. Now, in order for us to learn about data science and machine learning, we remember our steps, right? We have to import the data. So we get the data from what we explored last time, which is Kaggle. If you haven't registered already, make sure you do that. Otherwise, just sign in. And once you're signed in, just go to datasets. Let's make this a little bit bigger. And within the datasets, again, we can pick whatever we want, but I feel like checking out the FIFA 2019 dataset. Now, I usually like looking at the scores here to make sure that it's a good dataset. In this case, it looks like the FIFA 19 complete player dataset is looking pretty nice. We have 2 megabytes of data. It was uploaded 8 months ago, and it's a one file CSV file. So you can actually click on Quick Look here, and it'll show you some other information that you may need. In our case, it's a CSV file, so that's great, but just a heads up, it is a bit of a big data set. So if we click on it, we can just simply click on Download and wait a little bit as your datasets gets downloaded. Now, I want you to unzip this file and put it on your desktop where your Jupyter notebook is. So you want it in the same folder as the soccer notebook that you just created. Let me do that. So now if I go to my home, I see that I have data.csv, which is the file that we imported from Kaggle. As you can see right now, it looks like a massive amount of data. We can't really read it because it's in CSV format. Now, if we go back to our soccer notebook, we're going to use the pandas library to do our data analysis to see what we actually get from Kaggle. Now, in our case, we used Kaggle to grab our data, but you can imagine that there's different ways to gather the data. You can, for example, like we saw, use something like Beautiful Soup to scrape web pages so that you can understand it better. So you can use any type of data possible. Ideally, if it's in a CSV format, then we can use pandas and really do some neat things with it. So let's take a look. Now, luckily for us, by opening Jupyter with Anaconda, remember the Anaconda Navigator, we actually have access to libraries like pandas automatically. So all we have to do is simply say import pandas, and we can do as PD just so we have a shorthand instead of typing out pandas every time. So if I do this, I now have access to pandas. And with pandas, I can do read underscore CSV to actually read our CSV file. And because our CSV file is in the same folder as our soccer notebook, I can just simply give it the string data.csv, which is what we have over here downloaded. So if I run this, I get my data right here. And look at that. I have my pretty data with nationality. We have links to photos. We have the name of the players, the IDs, the age, and a ton of other things. Now, the neat thing with pandas is that we get this output as what we call a data frame. And pandas allows us to manipulate this data frame so that we can do interesting things with it. So usually what you'll see is you'll just create a variable data frame equals pd.readcsv. So that now this data frame is what we get down here. All this information is now in our data frame variable. And we can do interesting things and run different methods and properties on it. So for example, if I do data underscore frame dot shape, it'll give me more information about my data. In this case, you'll see that a tuple object is not callable. I get nice errors in my Jupyter notebook, and that's because shape is actually not a method, but instead a property on data frame. So if I run this again, look at that. This is the shape of my data. I have 89 columns and, well, a ton of rows. Now, I can also do different things. And this is the neat part about Jupyter, is that I can just leave the input and output here. And if I do a different cell block, I'll still have this information. It will still have imported pandas as PD. So if I do now data frame dot, let's do describe, I'll be able to run this. And again, it shows or describes the data that I have. With describe, we get the count. So for example, the overall age accumulated. We get the mean age, that is the average age of the player, so 25. And we also get interesting things like maybe the oldest player is 45. The highest jersey number is 99. And all this different type of data. Finally, if I do something like data frame dot values and I run this, I get all the values of my data. And you see here that it's an array that has different players in it. So remember how I said libraries like NumPy work with arrays and lists in Python and help us manipulate them? Well, as you can see, our data frame is stored as an array of each individual player that we could potentially manipulate. And what we've done here is we've simply imported the data. So we learned the first step of our ML steps. That is to import the data. We found the data and we used pandas to grab our data into a data frame. Now, there are many different things that you can do with pandas. And I want you to, after this video, I'm going to link to this resource so you can try different methods and properties on your data frames to see what type of things we can do. So I want you to go through this exercise and just try different things. For example, in filtering here, we can try and learn about filtering our data frame. So again, if I just copy and paste this, change this to our variable that we have. So data frame. And then we want to filter, let's look at the shape of our data or see what type of data we have. You know what? Let's filter by age. So I'm going to say data frame. We're going to go by age. And I'm going to say age is going to be older than, let's do 40. If I run this, and age should be capitalized here. So I got a key error. If I run this again, there we go. I grabbed the head, which means just the first couple of people, of players with age over 40. And I was able to do that just by looking at some of the pandas documentation and learning about filtering. So I want you to explore this. It's not too long. And try out different data manipulation techniques so that you get familiar with pandas. Again, you don't need to memorize this. Often, you usually will just look at the documentation and grab the data that you need. In the next video, we're going to try and solve an interesting problem with this data set. I'll see you in the next one. Bye-bye. Welcome back. In the previous video, we learned about importing the data and using the pandas library to manipulate our data frame. Now, let's learn a little bit more about this step, which is to clean the data. And in this case, let's try to solve an interesting problem. Let's say that instead of this filtering, what we want to do, or what our boss comes and tells us, is that he or she wants to know, well, what players are a good deal? What players are the best in terms of skill, but are also lower salary, so maybe we can afford them better. So let's say that the boss wants a few things from you. If we go back to Kaggle here and look at our data, it'll actually have a link to all the columns that this data has. And let's say our boss wants to find out the current market value of the player and the wage. So he or she wants to know which player is undervalued right now, and maybe we can grab that player for a really good deal. So what we want to grab from the data is the value, the wage, and obviously the name category of the player. Now, if you want, you can pause the video and try to do this yourself. Otherwise, let's give it a go. Let's create a new variable called a DataFrame1. And this is going to grab, using the pandas library, the data frame method, which will accept our previous data frame that we've grabbed, which is our entire CSV file. So let's say data frame. And then we're going to select as our second parameter the columns that we want. In this case, we can give it an array of columns that we want, which will be name, wage, and then finally value. So let's just print df1 to see if this is working. There you go. Just like that, we have the name, wage, and value of the player. Holy moly, Messi has quite a high wage. That's a nice wage. All right, let's keep going. Now here's the next part. We have this table, but the data doesn't really mean anything to us right now. Let's say we want to sort the data now. Because what we want to do is we want to compare each player's wage with the value and have perhaps a different column called the difference to see which player has the biggest gap between their wage and their value. Well, let's try and give this a go. Now, ideally, we can just create a different column by simply saying df1, we're going to add difference, and this difference column is simply going to equal the data frame that we have below over here, and it's going to be the value minus df1, the wage, just like that. Now, if I run this, let's do df1 and click run. I get an error. If I scroll all the way down, I see unsupported operand type S for minus. So I'm trying to subtract a string and a string. And we've learned about this before, right? You can see over here that the wage of a player is in euros, and they get paid a lot. So sometimes you have the M, which is for million, or K for the thousands. So we need to convert this into an int, right? So we can do that quite easily, again, using Python. Now with this part, you can try and solve this yourself and try to convert these values and wages to an integer and remove the euro sign and the M or the K for the thousands. Or if you want to just do this quickly, you can even Google around, because this is a common problem. All you do is Google for pandas, convert string to int, or in my case, look at that. Googling around, I found convert the string 2.90k to this in pandas data frame. So it looks like they are asking the exact same questions that we have. And again, as a developer, you have to really learn to start Googling and finding answers on your own, because most likely other people have the same questions you have. Now, if I scroll to the answer here, you see that I get some answers that look overly complicated, but I really like this one. So value to float. So we're changing a value to a float. We give it some sort of an X, and that's it. So this converts our value to float, and you see here that it replaces different things for us, such as the K, M, and the B. So that's perfect. Let's copy this, and again, I'll link to this resource so you can take a look for yourself. If I go to our soccer, let's enter the function that we have here, make sure that it's formatted properly. So we now have the value to float function, which is great. If we go back to the question here, unfortunately, they only remove the last item in the list and not the beginning portion. So we can just do that ourselves because we want to remove the euro sign as well. So there's actually a pretty easy way of doing this using regex. So let me show you. We can do a wage variable that equals df1, our data frame. We're going to grab the wage column. Let's make this a little bit bigger so you can see. And this wage column is going to be replaced. And the replace method allows us to use regex. So what we can do is we'll say that we want to remove the euro sign. So let's just copy it from here. Just like this, with an empty string. And then the third parameter is to just say regex equals to true. Now, if we go to regex101.com and we copy what we just did, so let's just copy this. If I do anything with a euro sign, you see that it is highlighted over here. That's what the regex does. Again, This is something that I just experimented with. Trust me, I don't remember this off the top of my head. I just looked it up before this video. So we replace all the your signs with the empty string. And then finally, if we go to our Stack Overflow answer, you remember here that in order for us to use the value to float, we just simply do .apply value to float. So again, if we go to our soccer, we'll just say .apply value to float, which is what we have up here. And we can just do the same thing for the value as well. So let's say value is going to equal value here, and the same thing being applied. And then finally, with these new columns, we can just update them by simply saying df1 wage is going to equal wage. And then data frame 1 value is going to equal value. So because now these are going to be integers, I can now run this minus operation, and hopefully, if we didn't make any mistakes, this should work. Let's have a look. All right, look at that. We have a new difference column, which just subtracts value from wage. Awesome. The last thing I want to do is to actually sort this so I can better understand it. So let's do, for the last part, say sort values. Again, another thing that we get from pandas. And we'll sort by the difference column. And we'll say ascending equals to false. So we get the biggest difference first instead of lowest to highest. So if I run this now, look at that. I get the players with the biggest difference all the way down to the lowest players. Very, very cool. So this was a bit of a longer video, but I wanted to show you the idea of cleaning the data. That is, we removed any unnecessary data, we converted types or cleaned things up in case we needed anything, and then perhaps even added extra information that we might need so that we can improve or get insights about what we might want to do next. Let's take a break and I'll see you in the next video. Welcome back. We finally created some data that our boss can finally use. The difference between wage and value of a soccer player. But this is kind of hard to read. Wouldn't it be nice if we can visualize this data? And that is a big thing that a data scientist does. It analyzes the data, understands the data, cleans the data. But at the end of the day, if you want to present this to anybody, you need it in a format that is easily understandable for somebody that might not be a data science expert. So let's visualize this. Now, we talked about matplotlib, which is what is often used to visualize this data. Now, this library is very extensive, and you can read the documentation on your own. But a ton of other libraries have been built on top of it to simplify and make it easier for us to visualize data. One of these libraries is called Seaborn, and is really, really easy to use. Let me show you. So we have this data. If we go to a new cell block, and just a reminder here, the way Jupyter Notebooks works is that it has to run all these inputs. If you refresh Jupyter Notebooks and you have a notebook and just click on run for one cell, it won't have the previous cells in memory. So you have to make sure that all these cells are run in order for you to execute this part. Because if you just restarted Jupyter Notebooks, it won't have any of this in memory. But anyway, just wanted to make that note in case you have an error. Let's use Seaborn to visualize the data we have above. So again, Seaborn, you can just read the documentation, and there's tons of tutorials online that you can follow. But I'll just show you the easy way of doing it. So we're going to import Seaborn. We're going to set up Seaborn by just running set. And now we can just create a variable, graph, and call SNS, or sorry, I should do Seaborn as SNS, just so we don't have to write Seaborn every time. So SNS.set. And then we're going to say graph equals SNS, and we're going to use the scatter plot as the graphing method that we want to use. And on the x-axis, we're going to use the wage. And on the y-axis, we're going to use the value. And the data we're going to use for the graph is going to be data frame 1, which is what we have up here. So if I run this, all right, we should have the graph now. So let's actually print it out. If I click run, look at that. How easy was that? Seaborn was imported for me, and all I had to do is say what graph I wanted, what were the values, so that is the x-axis and the y-axis, and what data we want to use, and all of a sudden I have a graph. How cool is that? Just like that, using some really nice Python libraries, I now have a notebook that shows my progress of exploring this data. But we have one problem here. You see, I have all these scattered dots, but I don't really know what they mean. Wouldn't it be cool if there's a way for us to hover and actually see which player represents the dot? Well, we can do that with another library. And this one is called Bokeh. It's a hard one to say. Bokeh, whatever you want to call it, is another library that allows us to actually have interactive visualizations. So again, if I go back, I can use it in a similar fashion that I did with Seaborn. I simply say from Bokeh, this is going to be really hard to say, and I'm going to say dot plotting. So from the plotting library, I'm going to import the figure and show functions. And then also from the bokeh.models, I'm going to import the hover tool, which is going to allow us to hover over these things. Again, you don't have to memorize these. If you go to the documentation and look at the quick start, you'll actually see this, or you can even Google for it. So if we actually go to the quick start guide, you see that we have the two libraries that we imported, plotting and models, and it shows you how to get started quickly. As a matter of fact, we can just copy and paste this line, which allows us to plot title and x-axis. So let's do that. And I'm going to give the title as Soccer 2019. The x-axis label will be wage, and the y-axis label will be value. And in here, I can give it different parameters that perhaps I want. For example, I can say plot width for how many pixels I want my plot width to be, and same with plot height. We'll say we want that to be also 700 pixels. And then finally, I can say what type of tools I want to use. In our case, we're going to create a hover tool so that we can hover over this figure. So this will be our graph right now. Next, if I do p.show, or actually the way it would work is we do the show that we import from here, and we run it like this. And you know what, for now, let's not use any of the hover tools. If I click run here, looks like I have a bit of a mistake here. I deleted show by mistake. Let's click run. And look at that. It actually opens up a new HTML file for me so that this could be interactive, but right now it's empty. We actually have to draw the circles of our plot, but we have wage and value, and the title, Soccer 2019. If we go to the quick start, we see that we can do lines, and we can do circles as well with different type of options. And because we're doing a scatter plot, let's do exactly that. I'll go back and in here, say that I want the circles that we're going to create. And again, don't get too confused if this is new to you. Again, this is all just a library and the documentation that you have to read if you want to get familiar with it. So we'll have the circles, wage and value. So that is the x-axis and the y-axis values of the circles. And then we'll say size. We can give it a size of, let's say, 10 for now. And the source of the data will be from df1. So that's what we want the circles to contain. If I now run this, I may have spelled something wrong. This should be size. If I click run, look at that. I have my data points, which is great, which is what we had before. We have a new HTML file that's generated, but I want to be able to hover. So if I go to, let's close this for now. If I go to the quick start guide and let's just search for hover, we see that we have the hover tool. And we have all these options that we can use for hovering again. Oh, I like this one. But I'll just show you the basic syntax. Essentially, what we want to do is we use the hover to equal the hover tool that we're importing. And in here, we can say that the tool tips is going to equal a list that contains some tuples. So it looks like we can use the tooltip like this. So let me just copy this. So we have the tooltips, we have the index, and then the X and Y axis. In our case, it's wage and value. And we'll change this to wage and value. And we don't care about the ordering, but we actually want to add another field, which is the name of the player from the data. So as you can see, in the hover tooltips section, or for basic tooltips, it'll show you exactly what each value represents and how you can represent it. And you have the dollar signs and the @ signs. So in our case, we want to individually have the wage and the value displayed here. So we're going to use the @ sign, unlike the X and Y dollar sign, which just simply gives us the X and Y value. So I'm just going to change this to the @ sign, and then finally also have the name property as well. Now the final thing we need to do is to just give this tooltips as the tools inside of this figure parameter. If I now run this, it looks like another error. Let's see. So it should be a hover tool here. And give it the array that we want. So that if I run, hey, look at that. We have an interactive plot that we can actually analyze. So we see here that Neymar has a pretty low wage compared to his value. What about Messi here? Well, Messi is definitely getting paid a lot compared to his value. So you might find some good deals for trades, maybe with Mbappe. Very, very cool. Now, this is just the tip of the iceberg. When it comes to visualization libraries like this, there's a lot of trial and error and learning how the library works, how to visualize this properly. And up until now, all we've done is this part right? We've imported the data and then cleaned the data and maybe have done some visualizations with it. We haven't really done any of these parts yet. Up until now, what we've been doing is mostly data science, trying to grab data and understand it for business purposes. I want you to explore this data set a little bit more, maybe try out some of these data visualization libraries. But for now, I think we have enough to move on and get into some more machine learning concepts. I'll see you in the next one. Bye-bye. Welcome back. That last project was a little bit overwhelming because we used a ton of libraries and a lot of data visualizations that are very specific to a library. But we haven't really touched the topic of training the data and creating models. So in this project, we're actually going to do some machine learning. It's going to be a lot of fun. But I want to give you a warning. This is just a taste of what machine learning is like. If this is your first time, it might seem a little bit overwhelming. But just like with anything, it's all about practice and repetition. But hopefully, by the end of it, you will see the 6-step process and how it actually works. And at the end of the day, you'll also realize that it's not maybe as complicated as you might have initially thought. So let's get started. The first thing we're going to do is create a new notebook with Python 3. Now, this time around, we're going to use a different data set, and a famous one when it comes to machine learning. It's called the iris dataset for the iris flower. So if I type in iris flower, it's a dataset that has all this information about the iris flower that actually has different types. So we're going to create a machine learning model that can detect types of the iris plant. Now, luckily for us, we can access this data very, very easily using scikit-learn. Scikit-learn, if you remember, was another library that is really, really powerful to help us with machine learning. So all we have to do is say from scikit-learn dot datasets, and scikit-learn comes pre-built with some good datasets that you can explore on your own. And we're just going to import the iris dataset, or lowercase I, just like this. So that if I do iris equals load.iris, just like this, and I click run, oh, and this should be an underscore. So we now have the data loaded. And if we go back to our REPL, we've imported the data. We don't need to clean the data. We learned about that in the previous project. But because scikit-learn has these data sets pre-built, we can assume that it's clean data that we can use in our models. The next step is to split the data into training set and test set. But in order for us to do that, we can use this concept of X and Y in machine learning. So X, this capital X, usually means the inputs that we want to give to our machine learning model. So in our case, we'll say iris.data will be our inputs. So that is the data that we get. So let's actually see what that is. Let's run. That's the data. You see that it's just some massive arrays. And Y is going to be the target. So if I do .target and I click run, you'll see that this is the target. Now, what this means is we want to find or create a function that takes in X, which will be our data, and outputs the Y, which is the target, that is the answer. Now, in our case, these are the answers, 0, 1, and 2. But if I Google iris dataset, and I go to the Wikipedia page here, you'll see that there are 3 types of iris. the Setosa, versicolor, and virginica. And each one of these is represented by either 0, 1, or 2. So if we look at our data set, this target is the types of those 3 iris flower types. So the target in this case that comes preset with the scikit-learn library is this is the data of the images. So again, if I remove this and hit run, this is the image. So each list is a piece of data that represents by some parameters the iris flower. And then we have the target, which is the answer, is when we input this data, what is the output? Which one of the 3 flowers is it? Now, if I go to Kaggle, and I actually type in the iris dataset, you can see that the columns are, well, the length of the petal, the sepal length, and then the species name. So you can see here that these are the columns that it's testing for. And you can see these are the numbers that we get in that array, and each one corresponds with different type of the iris flower. So let's get back to that. I'm going to say that capital X is going to be our data, our input. And then Y, lowercase y, and this is just a standard, will be our target. Finally, we actually want to get the feature name, so each item in the list here is a feature. Remember, that's what these columns are. These columns are the width, the length of the petal, and the sepal. So we can store that by simply saying feature names as the iris dot feature names, again, which comes pre-built with the iris dataset. And then the target names will be the iris dot target names. Again, if I run this, let's do feature names first. There's the columns. And if I do target names, you see that these are the 3 options. So up until now, we've imported the data. We didn't have to clean the data. We haven't really split the data yet, but we're at least starting to understand our data and perhaps what it contains. So once we've understood the data, and knowing that we have this information, we can now start splitting the data into a training and data set. Because right now we're doing supervised learning because these are labeled, right? We have all the data that we need, and we also have the answers that we need so we can test our model. By the way, before I show you how to split the data, what do you think the type of X is? Can you guess? It's a NumPy array. Remember that library NumPy that I told you allows us to use multi-dimensional arrays? Well, underneath the hood, this dataset is a NumPy array. It's a little bit more feature-rich than just a Python list. Anyway, let's start to split our data. So what we want to do here is from the scikit-learn library, I want to grab the model selection. And in here, we're going to import the train test split. Now, what is that? Let's Google and find out. So again, if I go to the library documentation, you can see that the train test split simply splits array or matrices into random train and test subsets. So it just randomly decides for us how it's going to split the data into the training data and the test data. So now we can use it in an interesting way. We can simply say X is the training data set, the X test data set, the Y train data set, and then the Y test data set. And again, we can just assign that to variables by using the train test split function that we import and give it the X, the Y, and some different variables. So for example, over here, if you can see, we have things like test size or random state or shuffle, different variables that we want. Again, you can read this on your own. In our case, let's just say that the test size will be 0.4. Now, let's have a look at what kind of data we have now. So if I do print X, the train data, and we can do dot shape here. And we'll also print the test shape. If I run this, it returns what we call a dimensionality of the array. So that is how many rows and columns. So it's got 4 columns and 90 rows. So our train data has 90 rows and our test data has 60 rows. If I change the test size here to 0.5 and I click run, you see that now I'm splitting the test size between 50% being for train, 50 for test. So we can actually change things up and try different things and manipulate the train and test data size. Ideally, though, we want to have more train data than tests, just because remember, the more data we have, the better our model is going to get. And this is going to be the same for the Y-train and the Y-test variables as well. Congratulations, we've just split the data into training set and test set. We now have some exciting steps ahead, such as creating the model. Let's take a break and learn how to do that in the next video. Welcome back. We're now getting to the exciting step of creating a model. How can we do this? Well, we've split our data now, and luckily for us, scikit-learn comes pre-built with some tools for us to use to actually build this model. So what we can do is actually import from scikit-learn different types of algorithms that we can use to create our model. In our case, we're going to use the k-neighbors classifier. But just to show you, if I go to scikit-learn models or model selection, you see that we have a ton of different types of things that we can do. We're going to use the nearest neighbors, which is a very standard, easy to use algorithm. And I'll link to some resources so you can learn more about it. And specifically do the nearest neighbor classification, which is going to do exactly this. It's going to try and divide up the data into different segments. But as you can see here, we have so many models to pick from, or so many algorithms to pick from. And one of the jobs of a machine learning engineer is to actually figure out which algorithm to use. But again, this isn't a full machine learning course, so let's just use the neighbors module. And from there, import the k-neighbors classifier. Hopefully I spelled that right. Now the way the k-nearest neighbor classifier works is we can just use it as a function. And all we have to give it is how many neighbors we want. That is, how many classifications do we want? In our case, we know that there's 3 types of iris flowers. So all I'm going to do is give it the parameter n neighbors of equal to 3. And then finally, we're going to try and fit this data and use this algorithm by giving it the train dataset and the Y train output. So that if I run this, well, nothing comes out of it. Hopefully, we've created our model, but there's no way for us to test it, right? If we go back to our steps, we need to check the output, right? We've created the model. Yes, it's as simple as what we just did, but we now need to check to see how good our model is. How good is our function? Well, we can use the predict now to predict and try out our tests. So we can use the X test dataset and give it to the Y underscore predict variable, which will be our predictions. So what the model predicts based on this new input X test data. Now, the cool thing that we can do now is to actually compare the output of Y predictions that our model created with the actual answers. Because remember, we created 4 different data sets, right? We created the train data sets for X and Y, and also the test data sets. So for the X test, we gave our new model the test data, which we have the answers to, and the model predicted, so this function was run to try and predict what type of flower might be based on, remember, the columns that we gave it. And now we have our predictions. So we need to compare the predictions with the Y test variable. And again, scikit-learn to the rescue has a nice tool for us to do that. All we need to do is from scikit-learn import metrics. And we can now print the actual accuracy of our model. And all we do is say metrics dot accuracy, make sure I spell that right, accuracy score. And the function takes the Y test data, which is the correct answers, and the Y underscore predict, which is the predictions that our model made. So if I run this, I get an error because I haven't run the block with the Y predict variable being created. So let's do that and then run this. And there we go. That's our accuracy. Metrics.accuracy score tells us that it's 96% correct. That's pretty amazing. Our model, which we just created in, honestly, 3 lines of code, is 96% accurate. How cool is that? So if we go over what we just did, we imported the data, we split the data into training and test set, we created a model by using the k-nearest classifier in scikit-learn, we checked the output using the Y prediction and Y test variables, and now we got the output. So now we can improve, if we want, our machine learning algorithm. So let's do that in the next video. We've just created our model. Remember, a function that gives us the desired output. And right now we want to improve on our model. So how can we do that? Well, there's a few things, right? If you remember, all we've done is split our data into test and train. But one of the things we can do as a machine learning engineer is decide how much data to give it to train. For example, if I decided that I want 80% of the data to be the test data and only 20% to be the shape or the train data, that is, the model will have less data to learn from. If I hit run here, and then let's run the rest of the blocks, and then finally this one, you see that my accuracy went down because I'm testing less data. That's not very good, is it? But what if we just give it less data to test? What happens then? If I click run on all of these and run here, I get 100% accuracy. Does that mean that this is the best option? Well, not really, right? Because what happens now is that our test size is super small. We only have 15 inputs that we're testing. And yeah, we got 100% because we're learning from 135 data entries. But because our test data is so small, although we got 15 out of 15, we can't be certain that our model is that accurate because, well, we only tested it 15 times. So this is a trade-off of how much data do you want to train it with and how much data do you want to test it with. And that's why companies really value data. The more data we have, the more we can train our models. Okay, what else can we do to improve this? Well, another thing we can do is with the parameters in here of the k nearest neighbors classifier is to perhaps do 4. If I hit run here and run again, all right, our accuracy is a little bit lower now. Because we're only testing for 3 types, 3 classes, ideally we match that with our nearest neighbors. Instead, if I do 4, what it actually does, if we go to our nearest neighbors classifier, it's creating 4 segments for us to evaluate, when instead we only need the 3 iris flower types. So let's keep that to 3. What other things can we do? Well, another thing, if we can collect more data, is to perhaps have more columns or parameters. These are sometimes called features. And the more features that a machine has to look at, the more information it can have. That doesn't mean that the more features, the better, but it does mean that maybe if there was another feature that we can look at for the flowers, there's a better model that we can build to predict what type it is. So that's another way to improve it. Finally, the most interesting part is the actual algorithm that we use. In this case, we used k neighbors classifier, which I just told you that we're going to use. But we can use any type of algorithm we want. If we go to the scikit-learn library, there's different things that we can do. For example, we can do a decision tree if we want to, and use a decision tree classifier. So how can we do that? Well, I simply import something different. I can import the decision tree classifier, and instead of the k neighbors classifier, we now use the decision tree classifier, which we don't need to give it any parameters. And if I now run this, I have to change this to tree. So if I run this and we run our accuracy test, all right, I get 9.33. Pretty much the same as we had before. And if we change this to 50, let's run this one more time. 0.92. But if you remember, when we had the neighbors classifier with the same parameters of test size of 0.2, our accuracy was actually better. This time around, we got 100% accuracy. And you'll notice that this constantly shifts. As we train our model, sometimes it gets it right, sometimes it doesn't, because it's constantly learning. But you see that the accuracy with the k neighbors classifier is a little bit better. So this way, we are able to improve our model so that we can now perhaps try these steps all over again until our model is perfect enough, or at least close to perfect enough for us to make business decisions. Very, very cool, right? Let's do a few more things in the next video. Let's say that we've created our model now. We have our KNN, iris.predict function that we can now run whenever we want to perhaps use. Let's say a user inputs a whole new photo that we haven't seen before of an iris flower, and we want to predict what that flower type is. How can we do that? Well, let's create a new variable here. Let's say sample equals, and create our own sample data. If we go to our data over here, we see that the data set over here has 1, 2, 3, 4 parameters. So this is an array that contains 5.1, then 3.5, 1.4, and 0.2. So let's just enter some numbers here. Let's say that here we have 3, then 5, then 4, then 2. And then the second image has a parameter of 2 and 3 and 5 and 4. So that's our sample data. We can now give our KNN predict function, which is our model, the sample data. So let's say that's going to equal the predictions variable. And let's just do something neat with some list comprehension here. We'll say that the predict species is going to equal the iris.target names p for p, which is the variable that we create in the predictions. So I'm just using a little nice shorthand Python syntax to hopefully give us the prediction answers. So let's say print, and then our predictions is going to be the predict species. So that if I run this, oops, what did I mess up here? Target names, not target names, target names. Let's run that again. There you go. These are my predictions. So the first one is versicolor. The second one was predicted to be virginica. Well, it's hard to say if it's right or wrong, right? That's why we have a test data set so that we know the answer to these questions. Ideally, we have a human label these so that we can test and see if this was right or wrong. Right now, we don't know if it's right or wrong, but at least we know that it's making predictions, and it's making predictions at a 96% accuracy based on our y-test data. Very, very cool. Now, what we've learned up until now, at the end of the day, all it did was create that function that our machine can use and predict any future input. And there's many applications of this, right? We now have a function that as a programmer or a developer, you can use throughout your code bases, maybe on a website, maybe on a robot, to try and receive inputs and predict something. Whether that image is an image of a snake, maybe a user sends a image that is not safe for work, well, maybe that predict model can predict and see if it should be uploaded or it shouldn't. But there's a problem here. You see, right now, we don't have that much data because we've only used a data set that has 150 rows. But in real life, to train a really complicated model, you have millions and millions of rows. And this function of fitting and running the kn.fit takes a really long time. And most of the time, you're running these types of operations on something like a GPU or a graphical processing unit. And sometimes in the cloud, because you wouldn't be able to do it on a regular computer. Now, this part is very, very time consuming. So you wouldn't want every user that submits an image of a snake to actually run this function. We call this model persistence. And model persistence is important because next time we want to make a prediction, we want to save this model, this function, to a file and use that file for predictions. When you're on your iPhone and you're using, let's say, a machine learning feature, it's not going to run and train the model right there. Ideally, that model's already there on your phone. And this idea of model persistence is important. So let me show you how to do that. Once again, scikit-learn to the rescue. With scikit-learn, I can say from scikit-learn import job lib. Now I can save my model using the job lib module by simply doing job lib.dump and dump the model somewhere. So we're going to dump the K and N, which is our model. So we're going to dump K and N, and we can call it whatever you want. Let's say mlbrain.joblib. That's the extension that we're going to have to use since we're using the job lib module. And this stores the trained model in a file called a binary file. So if I run this, and I get an error. And that is because we have to do scikit-learn.externals. So this is just a way for us to import the joblib module. So if I run this again, there we go. If I now go to my Jupyter notebook, you can see that I have a joblib file. So now, in the future, instead of me retraining the model, I can just simply do job or model, since we assigned it to a variable, and say model equals job lib. Actually, we don't even need the equal sign here. We can just dump this. So let's just run that. And we can just assign it now to the model whenever we need it. Say model equals job lib.load and load the name of the job lib that we want, which is the mlbrain. So now if I do model.predict on the, let's say, the X test data, and I click run, look at that. I get my predictions. And if I now copy the code, which was the sample data over here, so let's just cut that out and paste it in here. If I click run, there we go. Our model, and instead of predict, we'll just do model.predict. If I click run, look at that. This still works. So I was able to save my model so that I don't have to keep training it, because that requires a lot of power, so that my user, whenever a user wants to use my model, they just simply use the joblib load to load it up and then use the predict method. And this is how models work in real life. And anytime we make an improvement to the model, we simply just dump it again, maybe to a user's phone, so that they can use it. But this way, only the business owners that have a lot of compute power can train the models as they get more and more complex. Holy moly, we did it. That wasn't too bad, was it? I mean, there's a lot of new concepts. And machine learning is a big, big topic that could be a whole course in its own. But I hope I was able to narrow down the essence of machine learning so you understand what's happening when people talk about ML. We're simply doing these steps. And we've learned about all of these steps so that now you can start to improve on them and learn how to perhaps improve at each step of the way. Now, I've created a little notebook here that you can actually follow. I even have done some visualizations for you here using matplotlib to show you some of the iris dataset and kind of explore it on your own. But the key here is that you use Jupyter notebooks to visualize data, to manipulate data, to clean data. And then slowly, as you start to learn about your data, you start making predictions to test your data, to train your model on this data set. and hopefully get it to the point where you can make some important business decisions. Now, this iris dataset isn't necessarily useful to somebody like Amazon or Google. But using these basic principles, you now have the ability to increase the ability of a model from just detecting flower types to detecting all sorts of images, image recognitions. Self-driving cars all use the same principles. But at the end of the day, all we're doing is creating these models or functions by giving them inputs and some of our outputs to see how good we can create that function. And all we're doing is moving ourselves away from the function writers to simply the data aggregators and the people that change the inputs here and there to try and make the function as good as possible. Now, the topic of machine learning is really, really vast. There's different topics that we can explore, but the key thing is that there are a lot of tools. And in order for you to do machine learning really well, you need big data sets. So companies that we talked about, like Microsoft, Amazon, Netflix, can do machine learning really well and invest a lot of money into machine learning because they have these data sets available. Now, you can create your custom models, but these big companies also offer things like retrainable models. That is, very general models like Vision, AutoML Vision, that you can train, but they initially at least have created the base model for you. Or you can even use the pre-trained models, which essentially do everything for you. It's that model that you can just plug and play and use, and you get the benefit of all that data that Google collected. They just give you the model that you want to use. You want to do translation? Well, you just send them the text and they'll respond with the translated text for you. Because remember what I said, the value is not necessarily in the model, but in the data that we use in creating that model. This was a big topic. I hope your head doesn't hurt. And if you don't get everything 100%, don't worry. This is a big topic that is constantly evolving. And there are so many advances happening every single day that even the experts are overwhelmed. The idea of this section was just to introduce you to the topic so that maybe if this piqued your interest, you can explore these topics on your own further along. I'll leave some resources, some of my favorite resources for you so that you can explore this a little bit further. But for now, good job getting this far. I'm really proud of you. I'll see you in the next one. Bye-bye. Our final project in the course, and I want us to have a little bit of fun. This one is going to be nice and quick, but also a ton of fun that hopefully gets you excited about the power of machine learning. Now, my personal opinion is that most of the machine learning moving forward is not about creating our own models or doing really complex math and statistics, but instead it's in the ability of us to use pre-existing models to solve business problems, to solve human problems. And I want to demonstrate this by using a great library called Image AI. And as you can see here, let's make this a little bit bigger. It's a Python library built to empower a developer to build applications and systems with self-contained computer vision capabilities. That is, instead of us having to build a computer vision model all from scratch, we can use pre-existing tools to use something like this library to solve a problem or maybe create an entire business around a model that is freely accessible to us. And I'm going to show you this awesome library that's going to do some really neat things. So I'm going to link to this resource, but what we're going to do is we're going to create an image recognition app where we feed it some photos and it's going to be able to tell us exactly what that image has. That's pretty cool, right? Let's get started. So if we read through the documentation, it actually has a pretty good overview of what we can do. Now, as you can see here, we have to install a few things for us. So let's just copy this, and I'll go over what some of these do. So we're just going to copy and paste. Make sure that you're using pip version 3 based on your installation. We're using TensorFlow and Keras and OpenCV, which is an image processing library. And TensorFlow and Keras are very popular machine learning libraries. Now, we're going to install this. And as this is being installed, it's quite a bit to install, so just a heads up that these libraries tend to be heavier. And then we also want to install the Image AI library. So let's copy this, and let's see if this is done. Nope, it's still going. Give it a bit of time. Let's clear this and run the Image AI upgrade. All right, so hopefully we have these libraries installed. And what we can do is, well, just simple image prediction. So I've created a folder here, Really Smart Brain, that has an empty Python file and 3 images that I'll attach to this lesson. We have a giraffe image, a Godzilla image, and a house image. So let's see how we can use the Image AI library. What we can do is say from Image AI, we're going to use the prediction module, and we're going to import the image prediction part of it. Now, we also want to grab these files, so I'll just do a simple import of the OS library so that I can say execution path will equal the os dot get current working directory. That is, wherever I'm running this from, get whatever directory we're in. So that's just saying present working directory. It'll grab this directory for us. So that's the execution path. And we can instantiate the prediction, image prediction that we just imported by saying image. Oh, and this should be capital I. Let's make this a little bit bigger. So I'm going to say image prediction to instantiate it. And in here, we can do some different things. If we go back to the library, we're using the image prediction option here. Keep in mind that this library actually can do different things like object detection, which is really, really cool, or video object detection. But for now, we're interested in the image prediction. So if we go to tutorial and guide, you'll see exactly here what we can do to do the predictions. So let's just copy this for now and go over what it does line by line. We have our prediction variable, and we set the model type. That is, we decide what model we want to use. Now, this library has a few models that we can use. And these are really popular models that are already pre-built. For example, Google Brain Team has this model that's created. The Facebook AI Research created this model for image processing, and then ResNet, a very famous model by Microsoft. Now, we'll use the SqueezeNet because, as you can see, the size of the model is quite small compared to the other ones. That is the downside of these models. Sometimes they can be heavy, but the smaller the algorithm, the faster the prediction time, but the less the accuracy. So instead of using the ResNet, let's use SqueezeNet. So I'm going to change this to SqueezeNet. Next is to set the model path. So again, we're using the OS to find the model that we want to use. We actually have to download these models if we want to use them. So you can see here, if I click on it, I get a little download of the SqueezeNet. So again, the more accurate ones will just have more bytes of data that you have to download. So it's up to you. I'm going to use the SqueezeNet though. So now I get this file, which I can move into my project folder. So let's go to desktop, go to Really Smart Brain, and then plug it in here. So again, this is a binary file that we can just use as our model. I'm just going to copy the file path or the name so that instead of the ResNet, we'll use the SqueezeNet model. Awesome. And then finally, we want to load the model and then make some predictions. If we go back to the documentation, we can make the predictions by copying this piece of code. We see that we have the predictions and the probabilities, that is how confident the model is in its prediction. And we're simply saying, hey, predict image. Let's make this a little bit smaller. Predict image, and we're going to give it the image that we want to test. In our case, instead of 1.jpg, we'll say giraffe. So let's say giraffe.jpg, and we'll keep result count at 5. And then finally, we do a for loop. So for each prediction, we're going to zip the predictions and probabilities and just print out the output that we want. Let's actually see what this does. I'm going to save this and run our brain.py. Oh, I have to say Python 3 brain.py. So we get actually the answer here, but I want to talk about the error that you might encounter. So if you see over here, I get some errors in my code. And again, this is something that depends on the machine that you're running this from. You might have different issues, but these are mostly warning based on my library versions that we've installed. Again, depending on when you're watching these videos, some of these warnings might appear to you based on, again, the TensorFlow, the OpenCV, the image AI libraries that we use, or I might even get issues with my CPU that doesn't support instructions that this binary, which is the H5 binary that we installed, does not actually support. But in the end, we still get an answer right here. Let's make this a little bit bigger. We get, it's not looking good. It looks like 28%. It thinks that this is a ruffed grouse. I don't even know what that is. Let's Google image that. A ruffed grouse. Oh, that's really funny. Look at that. So it thought that this is what the image was of, and it was 28% confident. It thought it might have been a prairie chicken. That's 10% confidence. A cheetah, a partridge. All right, so it didn't really get it right, did it? That image does look a little confusing. So unfortunately, that model wasn't accurate enough. But you can see here what the code is doing, right? The code, when we loop, says, hey, I want 5 results of your predictions, and then I want you to grab the predictions and the probabilities, the confidence that you have in these predictions. And because SqueezeNet is not necessarily the most accurate, it didn't figure out the giraffe image. But what about Godzilla? That's another tough one. Let's do the Godzilla image. If I save and run this again, let's clear. Again, we're waiting, and there we go. We have American alligator, 46% confidence. Does it look like an alligator? All right, that's not too bad, actually. We also get the common iguana for 18% confidence. All right, last one. Let's do house. If we do house here, save and hit run. Hey, look at that. We get boathouse for 58%. By the way, I also just downloaded the ResNet model, which is supposed to be a little bit more accurate. It's about 100 megabytes. So that took a bit of time, but I want to see if the accuracy improves. So I just changed set model type as ResNet and changed the path to now the new model that I have. All right, we don't need to open that. So let's give that a go. I'm going to run again. You see here that it took a little bit longer than previously because it is a bigger model. But it looks like it thinks this is either a church or a boathouse, but it's pretty sure it's a church. All right, it kind of looks like a church. What about the Godzilla image? Let's do Godzilla. See what they think of that. All right, it's super confident that it's an American alligator. All right, still not great, but what about the giraffe? Let's check out the giraffe. If I run this, oh boy, this is not that great either. So as you can see, it's hit or miss. The idea is that this is never going to be perfect, but ideally we create a model that is useful enough to derive some sort of business outcomes or positive business outcomes. Now, this was just a little taste of what you can do with Python and machine learning. The real power comes when you combine pre-built models that big companies have already built for us to use them to solve our day-to-day problems or our business problems. And that's why Python is so popular, right? It's the idea of the developer community. There are so many libraries, so many tools that are given by the community to everybody who uses Python. Python is popular because our possibilities are endless. As you saw, there's so many career opportunities, so many different projects that you can do. So I encourage you to explore this library, explore other libraries, and see how you can use Python to make your life easier. I'll see you in the next one. Bye-bye. I can't believe it. You're watching the final video in the course. You did it. You went through hours and hours of video. And trust me, it was painful to make, but I also understand that it wasn't easy. Most students that watch this course won't finish the course because it does take a lot of dedication. It does take a lot of hours, and it does take a lot of practice to retain what you learned. So for getting this far, I want to thank you. It really means a lot to me that you decided to spend your valuable time learning from me. It allows me to do what I do because of you. So give yourself a pat on the back for getting this far, for not quitting, and hopefully for learning a little bit of Python. I hope you had fun, and I hope I didn't make the course too boring for you. And I hope at the end of it all, you now feel comfortable with Python to do all sorts of things that we described in the course. You definitely deserve a break, so thank you once again for being part of it all. And I hope to see you in my other courses because, well, in the world of technology, there's a lot to learn out there. So until next time, I'll see you in the next one. Bye-bye. In this video, we're going to talk about Git and GitHub and source control. Now, you might remember GitHub from our previous section where we used it to put the website online. But I'll show you that it is so much more than that. More importantly, Git and GitHub is used by most professional companies, and it is a skill that is expected to be known by all developers now. So this is an important section. One of the first things most developers have to do on their first day at the job is to submit something called a pull request, which uses Git and GitHub. We'll get through that in this section. Don't worry. You're going to learn all of this, and it's going to make sense. Let's first start with source control. Up until now, we have only worked on small files. No team members, just ourselves, just a couple of files. But in real life, you're most likely not the only developer on a team. Most likely the projects are huge. There's many, many files. Source control allows us to make sure that multiple people can work on the same file from different locations. Think of it as Google Docs that allows people to collaborate on one document. But enough talk. Let's actually check it out. I have over here set up two folders. One is for myself, Andre,
who just started a new job at X company. And I have Marcy here, who has been working at the company for a while, and she has project files over here. I'm actually using the files from our background generator video. Now, without Git or GitHub, what I can do is just copy and paste these files. So I have whatever Marcy has, and we can start working on these files. I can have my developer environment here with my terminal and my Sublime text, and I can work on whatever changes that need to be made on the app. And Marcy over here also has her own version where she can work on it. And we're both working on the same project. But let's say that both Marcy and I are working on this project, and she decides to change the project name from gradient background to super background. And at the same time, in my project, I decide to call this cool background. Well, now you'll have to set up a meeting between myself and Marcy and decide how we should change the code. And this is a small example, but you can imagine that as different programmers work together, there's always going to be this issue of one person changing one thing and another person changing another thing. This is where source control came in. And source control is a way to control this, where we have one place instead of our own computers. In this case, it's just represented by the folder that I have in here. Instead of each of us having a copy of the project, with source control, we have a copy of the project, but there is a centralized location up somewhere, maybe owned by the company or somewhere on the internet, that has the ultimate version that we each talk to make sure that we each have the same version. Getting GitHub is a way to do this, to be able to use source control. And as a matter of fact, it's the de facto way of doing this. So like I said before, this is most likely the tool you'll be using every single day at your workplace. So if I go to the GitHub website here, what it allows us to do is it's a central place that both Andre and Marcy can talk to. So even though we work on the same files, the same project, I can ask this central location, such as GitHub, hey, has Marcy made any changes? And Marcy can ask, hey, has Andre made any changes? And every once in a while, you'll get something like this where we have cool background and super background, where we have something called a merge conflict. What GitHub allows us to do is say, hey, I noticed there's a merge conflict. I see that you guys have both changed your background. I don't know who's right, but here's the information. Andre and Marcy, can you guys talk amongst yourself and figure it out? That's pretty much the workflow. So let's actually see what this looks like. The first thing we want to do is set up a GitHub account. If you haven't done it in the previous exercises, you absolutely should start a GitHub account. It's free. And like I said before, if you're a developer, you just need to have it. It's where everybody puts their projects. It's where you work. You'll be spending a lot of time on this website. You might remember that when we had the GitHub project, I also told you to get GitHub for desktop. Although we used that to make things simpler during that video, this is actually not the recommended way of doing it. It allows you to visually see and interact with GitHub, but it's kind of looked down upon by employers, and most people use the terminal or the command prompt to actually do this. So I won't be teaching you this way just because I think it's bad practice and getting used to the terminal is important. I'm going to close that and we're going to get this started. The very first thing we're going to do is we're going to click on Start a Project. And here we're going to call it whatever we want. We'll call it Background Generator. And you also want to leave it as public, and we want to click on Initialize this with a README. And we'll click Create Repository. And what that does, well, we've created a new project on GitHub. And here, the README, which is just a file that describes your project, you can see that it's here. We can type into the README whatever we want and it'll describe our project. But let's go back. If
Marcy, let's say Marcy has been working at this company for a long time. I'm actually going to remove my files here. Marcy has been working at this company for a long time, and the employer finally decided, hey, we need to use GitHub. We're going to hire this new guy, Andre. We want to make sure that you both can work on it, on the project together without any issues. Can you put the project up on GitHub? So what Marcy will do is she will go to GitHub, create background generator, and then she's going to click right over here to clone or download. And she's going to make sure it says use HTTPS. And from here, you just click on this button, which copies this link to your keyboard. Then Marcy goes to her terminal. And right now we're in Documents. We want to have the project in the Marcy folder. So I'll cd into Marcy. If I click ls, I see that, yep, I have my files. Now, the first command that we're going to learn is called git clone, and then copy and paste what we copied from the website. We're just saying, hey, clone this project from github.com. So I press enter, and there you go. Everything is downloaded. If I go back to the folder now, I see that I have background generator. If I double click this, you'll see that I have a .git folder here that's actually hidden. You might not even see it on your laptop if you don't have this feature on your computer enabled. But this .git now allows me to communicate with GitHub. So what we can do now, Marcy can copy and paste these files and put it into background generator. Now let me show you the next git command. Marcy right now, if we see, she's in her folder, but now we need to go into background generator, because if we do any git commands here, well, it won't work because it's not a git project. We need to actually go inside of the project that was created on GitHub. So I'm going to cd into that directory. Notice here, I have my terminal set so that it actually shows me what GitHub location I'm in, and I'll explain what master means later. Now that we're here, we can look at all our files. Yep, I see that now I have my README, which I created on GitHub, plus the files that I copy and pasted. We need to sync this so that if I go into my background generator, instead of the README files, Marcy can put up her files on GitHub. The way we do that is our second command, git status. It tells us that we have untracked files. That is, we have index.html, script.js, and style that are untracked. And it says use git add file to include what will be committed. So now that we see our status of what we have in our folder, we can say git add and the file name. So I can do index.html, git add script.js, and git add style.css. Let's clear this so we can see it. And now I can do git status again just to see what our status is. And now I have your branch is up to date, changes to be committed. You see that now with add, we've said, hey, we want to add these changes. We have new files that we've added and says to be committed. So the second step is to do something called git commit. And git commit says, hey, I'm committing that these are the changes that I want to make to GitHub. And it allows you to pass a message so that on GitHub, it'll show the message. When Andre comes back in, he can say, oh, Marcy added these files and this is the message. And we do that by doing this. And within here, within the double quotes, I can say adding, starting project. Close the bracket, press enter. I'm going to clear this. Now there's one last step. We did git add to add our changes, then git commit to commit and say, yeah, we're locking in those changes. And then finally, we need to let github.com know that these are the changes. So we do git push. And there you go. It has now been pushed to this repository. So if I go back and I refresh, look at that. It's the same thing that we did when we put up our first website online, but instead of using the desktop version of GitHub, we use the command line. And now we have our project, which is very good. Now let's go back to our example. So Marcy has been working on this project. There's a Git repository, and I just joined the company, and now I need to start working on this. What do? Now I need to access GitHub and get the copy of background generator. The way I do that, well, I go into my folder and I do the same thing. I do git clone, and then I copy and paste the repository just like before. Git clone and clone the repo. And there you go. If I go back to my folder, look at that. I have background generator. So we're both working now on background generator, but not off of each other's files. We're working with whatever version is on GitHub. All right, so now more realistic. We go back to working, and on the first day of my job, I say, I'm going to change the gradient background title, actually the H1 tag, to cool generator. If I save this and I do git status, well, I'm not in a Git repository right now. If you remember, I have to go into background generator. Let me open that up a bit so you can see. There you go. Again, these Git commands won't work if you're not in a folder that has the .git folder. So let me do that. cd into background generator. I'm going to clear this, and I'm going to say git status. And look at that. It tells me that I've modified index.html file. And if we remember, I will say git add. I only have one file. I can do index.html. But if I had multiple files and I want to just commit all of them at once, I can just do the period. So I'll do that, and then git commit, and I'll add a message changing title. I press enter. I'm going to clear this. Okay, and again, I do git push, and it looks like everything went through. So let's open that up and check it out. I now refresh here, and well, we haven't seen any changes, but we now see that we have 3 commits. We have the initial commit, the adding background project that Marcy did, and it shows you all the files that were added. And if I go back, I have the changing title commit. And now I see that, yeah, Andre just changed the background generator, which is in red, to cool generator. So as you can see, we have a history of all the changes, and we can always go back if there's any mistakes. But there's one issue right now. If I go back to the code and I go to Marcy's computer, I see that, well, she still has background generator here. Why is that? Well, because her computer doesn't know that GitHub has been updated. The next command I'm going to show you, this is the last one I'm going to show you in this video, is git pull. So remember, git push to push the changes to github.com, and git pull to pull whatever's the latest. So I do git pull, and there you go. You see over here that it shows me that index.html file was changed. Now you see that my title has been changed to cool generator. Let's just say that Marcy saw my first change and she really, really likes how I've added cool generator, but I think she wants to make it capitalized. Again, she's going to save that. She's going to say git status. All right, I have my index.html file, git add, then git commit, and I'll add the message capitalize title, and then git push. there you go. Again, I go back, I refresh, and now there's 4 commits, and we see that capitalized title is the new changes. The first day of work is done. I come into the next day of work, and well, I want to start with whatever the latest project is of background generator. And let's say Marcy worked all night to change that title to cool capitalized. I want to make sure that I have the most updated version. So what I do is when I get into work in the morning, I'll say, well, I want to make sure that if there's any changes that Marcy made, I know about them. So I'm going to say git pull. And notice here how the title's going to change after I do the pull. And now I click to Sublime Text, and there you go. Cool generator. All right, in the next video, we're going to expand on this and show you what happens if both Marcy and Andre make the same changes. What does GitHub do? I'll see you in that one. Bye-bye. Welcome back. Let's continue from our previous video to talk about a more advanced workflow in Git and GitHub. Now, up to this point, both Marcy and I have just been working on, over here, branch master. What does that mean? Well, it says branches, but I only see master here. And you might have noticed one issue with the way that we were doing things. That is, if it's my first day on the job and I just changed the title, but maybe we didn't even want that change. Maybe that breaks our branding or breaks our app. But I was able to do it so easily to change it into master. Maybe Marcy didn't even know that I've added that change. And that's a big problem, right? You don't want to put things into what we call production, into what the user sees, if it's going to break our website. If you're a big company like Facebook, that could mean millions of dollars in lost revenue, even if you have a bug that lasts a few hours. So I'm going to show you a more realistic workflow that you'll have, and that is with branching. Let me show you what I mean. I have over here a visual of what Git is really, really good at. Up until now, we've been working on what we call master. That is the master branch. Think of the master branch as the authority. This is the right way that our app or our website should look. And up until now, when I added the cool background title, well, I went from background generator to cool generator. And then when Marcy changed it to capitalized letters, then we went to here. And we just went in a linear fashion from one end to the other, to the other, to the other. But like I said, that is a bit of a problem. So a better thing to do is what we call branching. If I wanted to change the title, I will create a branch and just call it little feature, for example. And I just work on that branch on my own without affecting the master branch, what the user sees. And only when it's finished, when Marcy has reviewed it, when we have tested it and everybody on the team's okay, then we bring it back into master. And you can see over here with the big feature, you can keep going for a long time on your own branch. And only when you're done, do what we call merge into master. I'm going to show you how that works today. I'm going to close this and remember our example. We have Marcy's computer here with all the files, and we have my computer here with all the files. We both have our workstation set up. And now you see what master in my terminal means. And I'll show you in the notes afterwards how you can have this set up so it tells you what branch you're on. But we can see that we're both on master. That's my computer. And Marcy's computer is also on master. We want to make sure that we're both up to date with the latest GitHub. So Marcy's going to do git pull, and I'm also going to do git pull. And let's say that I'm now working on a new feature. And because it's a better workflow not to work on master, and this is a good tip generally, don't work on master, always branch off. If I do git branch, it'll show me that, well, I only have one branch, and that is master. But we can add to it. We can say git branch new or little feature. And now if I do git branch, I see that I have little feature, but master is highlighted because I'm currently on master. So the way I would go to the little feature branch, I'll say git checkout little feature. And there you go, switch to branch little feature. And now I'm on little feature branch. So what I've done is I've branched off of master and now created little feature. Let's create a bit of a change. I'm going to say in the little feature, we're going to change the current CSS background title to say, this is the background. I'm going to save here. And again, I do my simple workflow that we did in the last video. Git status. I see that, yep, we have the index.html change. I'm going to clear so we can see. So now that we've made this change, let's do git add. And again, just git status to make sure everything went through. Yeah, we're ready to commit index.html. So we'll do git commit. Message will be changing text. Perfect. Let's clear that. And now, again, in order to let GitHub know of the changes, we need to do git push. So we'll do git push. All right. Let's go to GitHub and see what happened. We see that now we have this yellow bar that just showed up and says you recently pushed branches. So if I click on this green button here, compare pull request, it shows me what changes I have, which is I've changed the title. And here I can let Marcy know, saying, Marcy, I've changed the text. What do you think? And I click on create pull request. And now I have my PR. And you see here how it says merge pull request. Well, if we go back to our diagram, I've created this little feature. And now I'm saying, hey, Marcy, I've just done this new change. What do you think? Is it okay for me to merge it into master? And what will happen here most likely is Marcy will come, see this pull request. You can see that we're on the pull request tabs. So she'll be able to see them and seeing, oh, Andre just did this change. She'll look through the changes and she'll say, well, if she likes this, she could be like, looks good. She can click on start a review. And you know what? She likes this, so she's just going to approve. Now, Marcy or myself, usually you don't want to merge your own pull request. Somebody on the team does it. Can now just say merge pull request. Confirm merge. And there you go. Some teams like deleting the branch afterwards, so you can just click delete here. If I go back to the code, well, I don't have the branches anymore because I just deleted it. But in my master, if I go to index.html, I see this is the background. So now Marcy can go to her project and say git pull. And again, she has the latest update. Now let's talk about some conflicts that can arise. Now let's say Marcy wants to change something, and I also change the same thing, and we get a merge conflict. Let's see what happens. So let's say Marcy wants to create a new feature saying, we'll call this one big feature. And she'll say git checkout or git branch big feature. She'll say git checkout big feature. And if I do git branch, we see that, yep, there's a new branch here. Let's clear that. And she'll say here that she wants to change this back to background color or background generator because all the users are complaining that the title changed and they like the old title. So she's changed that. She has done the git add, git commit, reverting back to old title. Perfect. And then she's going to do get push. Oh, let's clear that first, actually. And we do get push. The first time you get this, you might get this error saying that there's no upstream. You just copy the code that they give you here. Perfect. Now if I go back to background generator, I see the big feature pull request over here. And just to show you that you can have multiple commits, let's say Marcy decides to, oh, this is me. Marcy decides to add an exclamation point here. She can just say again, she saves this. That's clear. She'll say get add, get commit. You do this a lot, so you'll get really, really good at Git after working at a company for a while. And she'll say added exclamation. Oops. That's not what I wanted to do. Git commit. Commit. Added exclamation. And she'll do git push again. And let's go back to GitHub. If we look at the pull request, it'll actually have both of these, reverting back to old title and added exclamation. And we see over here both of the changes. Create the pull request, needs changes, Andre. So while this pull request is out there, I decided to start a new branch called, let's just call it conflict for now. And I'll do get checkout conflict. And now in the conflict branch, I decide to change this to just completely remove the cool generator. I save that. Again, I check my status and index.html file has been changed. So while this is happening, I get Marcy to merge the pull request. So she's entered it into master. Her pull request is in. And now if I go back to my conflict and I do get status, and we have to add these. So get add, then get commit. I'll just do a short message here, just check. And now, if I go back to master, oh, I have to do get checkout master. Again, before I push my changes, I want to make sure that I have the latest version of master, so I'm not changing anything or I won't have any conflicts. So I'll do get pull to get the latest. And now I go to get checkout conflict branch. And I can do this command, git merge master. So I'm saying merge whatever is in master into conflict. Marcy has been working on the big feature and she's merged it. So now master has the big feature branch. But I've also created another branch and I've been working on my own on the conflict branch. And the conflict branch doesn't know anything about master. So I'm saying, hey, whatever's in master right now, which includes the big feature that Marcy worked on, pull it in and make sure that there's no conflicts. So I do that, and I get conflict, merge conflict in index.html file. Now, if I actually click on Sublime Text, let me open this up so you can see it better. Oh boy, I get this weird little syntax. It's overwhelming at first, but it's easy to see what's happening. Head is where my branch is at, and it shows me that here to the end, I don't have the H1 anymore, but in the master branch, we have background generator. Now I can talk to Marcy and say, hey, Marcy, do you want to keep the background generator title? And she'll say, yes, that was the right thing to do. Don't change the background. Well, in that case, I just remove these lines and remove this and save now. If I do git status now, okay, we have the modify status here. Let me just make this smaller again so you can see. So let me clear this. What we do now is we have to do git add, again, because we made those changes. And we have to do git commit fixing merge issue. And I forgot the M. Let's try that again. M conflict fixing merge issue. Let's clear here and do git status. Nothing to commit, working tree clean. And if I do git push, well, again, I get this error, but I want to show you this time around. If I do git push origin conflict, it now works. Let's go back to GitHub. See what sort of things we have. We have the conflict branch. And if we look at the conflict branch now, well, there's nothing changed because, well, I just reverted all my changes. So it's completely empty. There's no changes now. So Marcy would be like, hey, did you mean to make this PR? It's empty. So I'll see this message on my PR and I can keep going. And that's pretty much the workflow that you'll see in Git. I'll leave the commands for you after this. But you see, it's very, very nice to work with. You learn a few commands, and as long as you have this visual model of every time you're working on something, you always create a branch. You title it with whatever feature you're working on. And every once in a while, you want to pull master and merge master into your branch to make sure that you're not missing out on any updates that other developers or teammates have done. Once you're done with your feature, you make a pull request by doing git push. And that pull request, you'll add comments and people will review your file changes. And if they want you to make a few changes, then you can do again git add, git commit, finally make your changes, and then you can merge pull request. And once that's done, then everybody else on the team, there's now a new master. So everybody else on the team should do git pull as well. It does take a bit of time to get used to, but is a really, really nice workflow to make sure that everybody on the team works on the same files, same projects without causing any errors and making sure that everybody collaborates well. And that's it. Hope you found this useful. I'll see you in the next one. Bye-bye. In this video, we're going to talk about how to contribute to open source and actually take you through the steps. But first, for those who don't know, what is open source? Well, a lot of technology that has been created on the internet that we know today has been built on top of open source projects. And open source projects means that anybody can view the code. Anybody can see the code of a program, can inspect it, can modify it, can enhance it. In this way, the idea is that by sharing this information with everybody, we get everybody's input and we use the collective mind to improve software. Not only that, but it also benefits everybody, right? For example, the most famous example of an open source project is Linux, an operating system just like Windows or Mac OS, except it's built by everyday programmers. And it's code that is completely open sourced. Anybody can inspect the code, add on to it, and it's become so successful that most of the cloud that we know of, the servers usually run Linux. AWS, Google Cloud, Microsoft Azure, all of them use Linux. Some of you might be running Linux right now as you watch this video. So not only do you get to work with other developers from around the world, where you can build great projects by just working in teams, by learning how open source works, well, you don't have to create something as big as Linux. You can create a project with a friend, something very small and simple. It doesn't really matter. The idea is of collaboration, of openness and sharing code to hopefully improve on the collective knowledge. Finally, a lot of employers actually look upon open source contribution as a plus. So if you're able to put in your resume that you're an open source contributor, well, that's a good sign. Plus, it teaches you valuable skills using Git and GitHub to work in teams. If you're looking for job experience but you don't have a job, contributing to open source is the perfect way for you to learn how to work in teams and mimic a work-like scenario. This is a really important video and something I'm really excited about. So let's show you how to make your first open source contribution. Improve your resume, learn some real-life skills, and have fun along the way. Now, we've actually created some open source projects for you for this course. We have the Zero to Mastery repository here, where we can see that we have about 64 projects open right now with about 2,000 contributors. That's a lot of people, and this number is bound to increase. Now, this place was created as a practice ground for you, a playground. Nobody will yell at you if you break things. You can contribute, add silly things, whatever you want. It's a testing ground. The idea is to have as much fun as possible and make it as easy as possible to contribute to open source. Now, within that organization, we have a great community of administrator or management team that will help you with these open source projects. By the way, who are these administrators? They're right here. Ignore my name. I help out as well, but they do a lot of the heavy lifting. And they are past students, just like you, that have had a bit of experience now. Most of them are working full-time, but they are now helping out the community by helping with our open source projects, our Discord, and generally just helping our community grow. So shout out to them. If you get a chance, say hi to them on Discord. They definitely do a lot for this community. They're very active on Discord and they really help maintain all of our open source projects. So let's learn how to make our very first open source contribution. I do want to note here that this isn't the only way for you to contribute to open source. This is just a playground that we've created for you. But once you contribute here, you can go off and contribute to all the other open source projects all over GitHub that you can find. You can contribute to projects like React and Angular. The world is your oyster. Or you can just stick to these, as we actually have a ton of projects here that are fun. We have events going on like Hacktoberfest. Well, we'll get to that shortly. We definitely have a great community of developers and we can create some awesome projects together. Now, the way you want to get started is to first go to the Start Here guidelines. Now, in the Start Here guidelines, and I'll link to this page, you actually have a 4-step guide to get started. The first thing you want to do is to actually watch the Get Started guideline. A fellow student actually created this guide for you to follow the steps that I'll mention in this video. So you always have this as a reference. So after this video, definitely check out this document as a reference. But otherwise, once you've browsed through the document, make your first pull request. So if you've already watched my Git and GitHub videos, you should be all set. Otherwise, hopefully you're familiar with Git and GitHub. Now, the first thing we want to do is to actually add our names to the contributors.md file in this project. So if you go up, you'll see that we have a contributors.md, which stands for Markdown file. And if I click on here, you see that all the contributors that we have over 1,000 contributors. And if you scroll down, these are all their GitHub names. So your first task is to actually add your name to this list. So how can we do this? Well, we can just clone this repository, but a more recommended way of usually contributing to open source is to fork the project. Fork essentially means copy over the entire project and put it on your own GitHub profile. So if I click fork here, And we see over here that you can select where you want to fork the project and you want to select your profile. So once we fork this project, we make a copy of it. It's like we own this repository now with our own version of the Start Here guidelines. So once we have this, we can clone this repository using SSH or HTTPS, whatever you prefer. In my case, I'll use SSH so that I don't have to use my password every time. I can now say git clone and clone this repository. Now we can cd into Start Here guidelines, and we can open this up in our favorite text editor. Now, once here, let's clear this. We have the contributors file, which we need to add our name to. Now you can see here the contributors file is getting quite long because, well, we've got a lot of students who are contributing to open source. But at the very end, make sure you're at the very end here, you want to add your own name. Now here's the thing. Right now we're on the master branch, but I'm going to show you what a good practice is. We have our forked project, and we want to create a new branch to work off of instead of master by saying git checkout -b to create a new branch. And we want to name this branch. In our case, let's just name it test. If I hit enter, you'll see that now I'm on a new branch called test. And in this branch, I can add my name to this contributor list. In your case, you'll want to use your own GitHub profile. So we're using Markdown here, which is a syntax to write and have some functionality. For example, if we go to the contributors list, you'll notice that they are all clickable links. So we essentially use the same notation. We do a dash, square brackets with your GitHub username, and then in the parentheses, we just have the actual URL that you want to link to. In our case, the GitHub username that you have. So your GitHub username here, GitHub username here. Once we do that, we can save this file and now go back to our terminal and say git status. And we see here that, yeah, we just modified our contributors.md file. And if I do git diff to see any changes that we've made, we see that we've added this new line. So let's clear this. We have our name all set up, and we can now add this commit by saying git add and dot for everything. We'll add everything, and then git commit, and we'll write a message that says added my name to contributor list. There we go. So now it's time for us to push these changes. Now if I do git push origin master, well, right now what that would mean is that we want to push to origin, and the origin is this Start Here guideline, which I forked. So the origin is actually my version of the project. And if I want to push to master, that is the main branch. But we don't want to do that because ideally, we want to be able to also change and add our name to the original Zero to Mastery Start Here guideline because this is the main project. So what we can do is instead of master, push to our test branch. So we say git push origin test. There we go. Now, if I go back here and go to my project and I refresh, I now have two branches, the master branch and also the test branch, which I just updated. So one way to do this is to click on New Pull Request. And you can add comments here like, I've added my name to the list, and you can tag some of our maintainers. In my case, I'll just tag myself. If I do create pull request, I now have my pull request. And notice here how my pull request is now at the Zero to Mastery Start Here guideline. So that if I go back to our Start Here guideline, I see that I'm part of the pull request now, right here. And because I've tagged one of the management teams, so in this case, it was myself, or you can tag any of the management team that we have. Now, in this case, I'm cheating because I also help manage this. So I can just myself merge the pull request. Most likely in your case, you won't be able to merge it yourself. But if I click merge and confirm, there we go. I've merged my project. I've deleted the branch and the pull request is closed. If I want, I can even delete my own fork. But for now, let's keep it the way it is. Let's check the Start Here guidelines and see if my name has been added to the list. If I scroll all the way down, hey, check that out. There's my name on the list. So I've been added to the contributors list. That was pretty easy, right? And the cool part is that now if I go to my profile, I actually have Zero to Mastery as one of my organizations. So if you're able to add yourself to the contributors list, you can actually join the Zero to Mastery organization and have this little icon appear on your GitHub profile. And lots of GitHub profiles have organizations, so people usually have their workplace icon in here. So it's just a nice little thing to have on your profile to show that you're involved in the programming community. So we've just made a pull request, which was step 2, and that was pretty fast, right? Finally, the next step is to go join an actual project and start contributing the way we just learned in our Zero to Mastery organization. Now, there's actually a guide that we provided for you to figure out what project you choose, what's going to be good for you. We also have in our Discord a group projects section where we can look at some of the current projects that are happening, or you can just go to the Zero to Mastery organization and pick any of the repositories to contribute to. Now, in the next video, we're going to contribute to one of these projects and show you a real life scenario. I'll see you in that one. Bye-bye. Welcome back. We've just done our first contribution, which wasn't that crazy, right? We just went to the Start Here guideline and added our names to the contributors list. But let's actually contribute to an open source project now. Now, in our community, every month we do coding challenges. Now, you can search for coding challenges here, but this month is a special event because we're actually doing a Hacktoberfest event. And this happens once a year in our community in October. And you can see that if we click on the Hacktoberfest 2019 link, so depending on when you watch this, you might have a different year. You see that we've provided for you an opportunity to contribute to an open source project. We actually have Animation Nation. We have a Santified project and also a Python project. And you can contribute to any one of these. So if we look at Animation Nation, well, people have contributed their CSS animations here. Ooh, this one looks nice. We also have the Santified project. So people have created a little Santa website. That's kind of nice. Very, very cool. And then we also have the Python art project that actually does something really cool. If I go to the website here, it'll actually turn an image into ASCII art, which is really, really cool. Now, there's tons of projects that you can do, but let's try and do this Animation Nation project. So the first thing I'm going to do is go to the project repository and follow the steps that we've done before. That is, we fork the repository. We now clone this repository. Let's git clone. And while that is being cloned, let's look at the instructions. Now, most open source projects will have instructions on how you can contribute. In our case, we have a nice step-by-step guide. So in the art directory, create a directory name after yourself. Okay, that's nice and easy to do. So let's cd into the Animation Nation project. Let's open it up in Sublime. And we see that there's an art folder. And in here, we have to create our own name or our own folder with our name. I've actually already created a folder called Animatron that has a little CSS project with index.html and CSS. So just to show you, let's move this, or just to show you, this is my little animation using some simple index.html and CSS. Nothing too crazy. Now, all we need to do is move this into the art folder as the instructions have given us. And now we've added our project. Let's see, where's Animatron? There it is. That's my project over there. Next is to, well, within this folder, make sure we create two files, an HTML file and a CSS file, and link the CSS file to your HTML. Using only HTML and CSS, create a work of art. So I've actually already done that. Again, if we go back to the project, I have an index.html file, very, very simple, that's linked to a style sheet. And this is my styles that I've added for my animation that has these little lines. Now, the last part here is to add my own card to this section, to the include.js file. So let's just copy this, go to the includes or include.js, and you see this is where everybody enters their information. And right here, we can just add what we copy and pasted. Make sure the indentation is proper. So the art name is going to be called Animatron. Page link is going to be, well, the name of our folder. So Animatron index.html. And then the GIF name, which they suggested that we include a GIF. So if I remember correctly, the GIF name was trans.gif. Again, I just created a little GIF of my animation. So we'll call it trans.gif. Author is Andre, and the GitHub link is my GitHub link. All right, so that should be good. Let's now make a pull request. Now, notice here how I did all these changes on master. Ideally, we created these changes on a new branch. So we can actually just do that now. Git checkout B and call it Animatron. So if I do git status now, I see that I have two changes. That's good. Let's do git add, git commit, adding my artsiness to the project. And then finally, git push origin Animatron. All right, if we go back to the project, we see that we actually now have a little icon that says compare pull request. If I go back to the forked repo, 0 to mastery, you see right over here that I also have this yellow banner. So if I click on this and say, please add me to this list, and we'll link to, this is Joy, who's one of the managers. So I'm just going to say, please add me to the list. We actually don't even need to tag her because she will check this occasionally. So I'm going to create a pull request. It's now opened. That's awesome. So please add me to the list. If I look at my file changes, you can see that these are what I've added to the project. So if I now merge pull request, again, you won't be able to do this, but some of our management team, people who are managing the open source projects, will be able to merge for you. We can delete the branch since we have merged everything. And now let's see if the changes have been made. If I go to the Zero to Mastery Animation Nation, so if I now look for my project, hey, look at that. There's my little animatron project that, well, there it is. There's my CSS. That's beautiful. Now, the way this project is designed, it randomly selects the CSS animation. So it might not show all of them at the same time. So you might have to refresh this a few times. But just like that, I made my open source contribution. Now, there's a ton of projects here that you can join. And like I said, this is a playground for you to test, make mistakes, because this isn't a real workplace. We want to practice these skills before we actually go into work and make big, dangerous changes. And that's open source. I highly, highly recommend that you get involved. It's a great way to work with others. It's a great way to learn how Git and GitHub really work. There's no doubt that there's a lot that an individual programmer can do. However, the progress and scale that something can be built is really compounded when many people work on something together. Go make your first open source contribution and have fun building things with your fellow programmers. It may one day lead you to impress a potential employer. See you in the next one. Bye-bye. The most successful people that I know, and I'm not just talking about developers, I'm talking about all the successful people that I know, are masters of learning. We all have the same amount of time in the day, 23 hours, 56 minutes, and 26 seconds. However, some people are able to accomplish more than others. Why is that? I'm a big proponent of efficiency. If you're able to learn something in much less time than somebody else, then you can compound the benefit over your lifetime. Now, I know many people have different learning abilities, but this isn't a contest with others. This is a contest within yourself. Figure out what makes you successful in learning. Don't compare yourself to others. Whether you're a visual learner or maybe you need to take breaks every 30 minutes, figure out what your best learning style is. Learn how to learn. Don't just watch videos blindly at 2 times the speed and expect to learn everything. Find the most efficient way that works for you and keep practicing. By learning to learn, you become a better developer. As developers, we have to constantly learn throughout our career. Our learning never stops because technology is constantly evolving. So if you want to be a successful developer, you have to learn your best learning style. It is better to figure out what makes you tick, what makes things clearer for you now than later on in your career. Start early, figure out what is the best method for you, because it's going to be a skill that you're going to use throughout your career. This is something that we started our course with. The idea that when learning something with our limited time and resource, we need to make sure that we understand the most important concept. Why are we learning this? Why is this worth my time? And why is this something that I should dedicate
this time to. Too often we see new things in the developer ecosystem. It is always exciting to be working on the newest and shiniest thing that everybody is talking about. But remember, those libraries and frameworks and configuration files and tools, those things come and go. They're always changing. You can be a master of Webpack one day, and 2 years later, nobody cares because there's a better tool out there. The things that stick around are the fundamental computer science topics and software development practices. Sure, these things change over time as well, but they always evolve slowly with why in mind. When learning new things, make sure you understand why the solution was created. What problem is it solving? And why is this the answer to your problems? If you're able to do this, you stop being a player in the game of catch-up in the developer ecosystem, always trying to learn the latest library, the newest tool, the coolest functions to learn. It's like a game of hamster who's constantly trying to keep up with the wheel, trying to run on that wheel. But instead, be an observer who is watching the ecosystem evolve from above. Watch how new libraries come and go. Understand the why of each libraries, what problems they solve. Understand the big picture, why we do things. But be the observer, not the hamster. You'll have a happier, longer career overall. Trust me. You won't be constantly trying to catch up with every library and framework this way. This big picture vision is what makes a senior developer or a manager or a leader. They don't have narrow vision. They see the entire ecosystem and they are able to make smart decisions because of that. So always start with why. In this video, we're going to set up our terminal to look nice along our newly set up Sublime Text. As you know, the terminal is just a text-based way to communicate with the computer instead of the graphical user interface that we normally use. As developers, you will spend a lot of time with the terminal, especially as you become more and more senior in your role. So let's make it better. If we open up the terminal, I have it open already for myself, you see that we have the word bash here. Bash is a type of shell that a terminal can have. And what do I mean by that? Well, just as the name suggests, it's just the casing around the terminal that is customizable. There's actually more than one shell. Bash is just one of them. One of my favorites are OMyZSH, there's the fish shell, and they all have different things that you can do with them, but it's just another way to customize your workstation. Before I get into that, let's just customize our bash. The way we do that is we can first start off with getting something other than just having this to the left. The way we do that is we type in nano, which is a text editor, and then we do squiggly line /bash_profile. And here what we opened is a file that is the bash profile. So this is what our profile will look like. This file gets read every time we open up the terminal. In here, we can put in a bunch of things that we want our terminal to do. One of the cool things that I really think is fun is updating your PS1 variable. And I'll link to this website. And there's a bunch of examples here that we can use. Let's just pick one that, like this one over here, all we do is copy and paste this. And within our bash profile, we can just copy and paste. And as you can see, our PS1 now equals a whole bunch of gibberish that we don't really need to worry about. We see over here that to exit, we need to do Control X, then save modify, we just press Y, and then press enter. Okay, nothing happens, but the way we fix that is we now do source and then bash profile. It essentially reloads our profile now.
And look at that. We now have a cool little prompt to the left. So you can set up your PS1 to display whatever you want. If you want your current directory to display, that's great. If you want your username to display, that's good as well. You can set up in a ton of ways. The other thing that the terminal lets you do, if you click on something like edit background color, you'll get a few things that you can change in your shell. You can change your color based on what you want. And if I bring this over here, you can also click on the profile, and actually it gives you a bunch of pre-built ones that look really cool. Let's do Pro actually. Very nice. Again, you can customize this as well. And as I mentioned, a different operating system, you have your own ways to customize it. But every single one usually has a profile and a way to modify what gets displayed based on your needs. Now, the one that I really, really like is a shell that's different than Bash. And I've used this one before, which is really, really good. It has a ton of themes that you can use. They have a bunch of options and you can play through them. The one that I really like is the fish shell. It's very simple. It has all the operating systems on it. And I install it using Homebrew. For those on a Mac, Homebrew is a way to install anything from the web. So instead of me going to a website and installing something, I can use the command line to download things. If you go to the Homebrew website, brew.sh, you can actually just copy this link into your terminal, copy and paste it, press enter, and it will install Homebrew for you. I already have this installed, so I'll just exit that. The way I install fish, you can see over here, all I have to do is say brew, install fish. And while this is happening, I want to show you another option. So we have the terminal over here, but iTerm, which again is specific for Mac, is really, really nice and it's way more customizable than the terminal. So I prefer using iTerm 2. If I open this and double click, and look at that. This looks way nicer already. So let's just compare them side by side. I have my, let's make that a little bit bigger. I have the Bash shell here, and I have the fish shell here. Although they both are in the desktop right now, they're running on different shells. The fish shell has, just like we have with the Bash profile, has its own profile. So you can set it up. And you can set up which one gets activated when you first open up the terminal or iTerm. What I recommend is to set up your workstation in a way that's nice to you. My preferred way is to use iTerm and the fish shell. But if you want to use Bash, that's great. The beauty here is that if I type in Bash, I get taken to the Bash profile, and if I type in fish, I get back to fish. iTerm also lets you just customize everything really nicely. If I go to preferences, you'll see here that I have appearance, profiles where we can have colors set up. And there's a ton more you can do with your terminal that I won't get into this video because everybody has their own way of doing things. I just wanted to show you a basic setup so that now you have a nice environment that you can work in. I'll see you in the next one. Bye-bye. Hello and welcome to the Ask Me Anything video that I just impromptu decided to do after we hit 1,000 students, which was just last week, and we already have over 2,000 students. So I want to start off by saying absolutely thank you. Thank you so much for being part of this course. It is beyond what I expected. I thought I'll get a couple of, 100 and call it a success, but I've really, really loved interacting with a lot of you. We have students from over 100 countries, and everybody's so excited to learn with so many different backgrounds, and I just love the community that has come out of it. Like I said, it was beyond my expectation, and I love that everybody's so excited about learning to code. So thank you so much. I've created a couple of videos for you to watch, but I think the community that's forming around it, that's supporting each other, and hopefully in a few months, helping each other to become the web developers that they want to be, I think that's the most amazing part. So again, thank you so much. I'm just going to answer a few questions that some of you have asked to celebrate getting to 1,000 students. The first one that I see over here is from Ashley, and she asked, what was your biggest hurdle after starting a new career field? I think the biggest hurdle that I encountered was definitely the imposter syndrome. You may have heard of it. It's the idea that you feel like an imposter. You feel like everybody else knows this stuff except you. You sit in a room and people start talking and you realize that you have no clue what's going on and you're afraid to ask questions. And I think that's the biggest hurdle. Realizing that when you read something or watch videos online, people have practiced this and made sure that there's no mistakes in their writing and their videos, and I did this as well. And what this means is that what we project onto our videos or onto our blog posts isn't exactly us being perfect. It's us iterating and making sure that we check our mistakes and fix them. So nobody out there knows every single answer about web development or coding. We all are beginners and we are problem solvers. We're really, really good at solving problems, not just dictionaries that know everything. So really realize that you're not an imposter. You're not less than everybody else. Everybody has these difficulties, and I think the biggest thing you can do as a developer is ask a lot of questions. Anytime you don't know something, ask questions. Don't feel like you're the only one that doesn't know. Most likely, other people in the room don't know, except they are afraid to ask a question and raise their hand. So I think that's the biggest hurdle. You get over that and you get comfortable asking questions to your coworkers when you don't understand something. I did that a lot when I first started coding, and I was able to get answers and progress a lot faster than most people that didn't ask questions. All right, so next question was from Mike. Other than JavaScript, what is the most important language to learn? I have to say, probably, other than JavaScript, Python is a really good language to learn, mostly because it's used a lot in machine learning. And it's a very, very fast growing field. And I'm going to write a little bit of a blog post on it so people can get familiar with it. But Python is definitely interesting. The other one I would say is Solidity, which is the coding language that is used in building distributed applications for Ethereum. If you haven't heard about blockchain and all the hype with cryptocurrency, I think Solidity is a really interesting one. In 2018, we're going to see a lot of distributed applications being created, and there's a huge demand for developers who know that language. So I think those two are pretty exciting. I'll be writing a blog post about it so you can get more information. But yeah, you should look into those as well as JavaScript. But focus on JavaScript first. All right, next question was by Wasim. And he asked, if you were to hire a React developer from students who completed this course, what would you be looking for, and what questions would you ask? All right, so I think I would ask, number one, what's the benefit of React? Did they just learn a couple of syntaxes and know React, or do they actually know what problems React solves? And I go over that in the course, so hopefully you understand it as well. And then I'll also ask about what are its shortcomings. When is it a bad time to use React? Because I've seen a lot of people who get really excited about the technology and think it's the greatest gift ever without understanding that not every problem can be solved by one library. I think React is great for some things, but not for everything. And there are a lot of shortcomings that come with React that you should know as well, because if you're able to understand the pros and cons, well, I think then you truly understand the library and you're able to make a good decision as a developer. And it's something that I try to do in this course, which is not necessarily learn a bunch of functions and ways to do things, but deeply understand them, know what problems they solve and when they're good to use. And if you deeply understand that, then I would 100% hire somebody, because I know that they have deep knowledge about something and not something superficial, which in turn means that they're able to do more than just follow instructions. They're able to think on their own, and it doesn't just follow the rules and follow what I say, but can think for themselves and make good decisions. All right, next one by Josh. Which programming blogs do you read most frequently? I definitely like Medium. Medium is great for technical blog posts. If you haven't been there before, just medium.com and just follow anything. Actually, I would say just follow the top 10 articles daily and browse through them and see which ones are related to technology. I think they're really, really good. It's actually how I started this course. I wrote a Medium blog post that became very popular, and I thought, hey, maybe I should create a course. The other one is Software Engineering Daily, and that's a podcast that is really, really good. And it's not just about web development, it's just about software engineering in general. And it can get very technical at times. It really gives you a good grasp of what's out there and the technology as it evolves. And then finally, for JavaScript, there's a JavaScript weekly newsletter. You can Google that and sign up for it, and every week it'll give you updates on JavaScript. Okay, a few more questions we have. What did you do prior to your career change? So I've actually had an interesting career, I guess. I used to train tour directors around the world, so I'd fly to Costa Rica, for example, and train people. I also had a small business that I actually used to run yoga and surf retreats. So I've always worked with people, and every once in a while I would need a website made. And I would give a bunch of money to a developer and never know what was happening behind the scenes. The finished product would never come as I wanted it. And it was kind of this black hole that I was throwing money into. So I wanted to learn it for myself, and that's kind of how I got into the field. And next thing you know, I really, really enjoyed it and decided to make the career move based on the fact that A, it's a great industry to be in, and that I found it interesting. The next question was, how did you get your first job as a dev? So I actually got my job as a developer 5 months after starting with HTML. I didn't know what HTML, CSS, JavaScript, any of that stuff was. Didn't really know how the internet worked. 5 months later, I got a job. And not even as a junior developer, but as an intermediate developer. And that's nothing to show off, but just to show you how fast you can progress through this career if you really work for it and understand the fundamentals. So the first job that I got, I actually applied by messaging a bunch of companies that I was interested in and finding their email, their CEO's email, and letting them know that I was interested in a role and that I was solving a specific problem that they had. So I would research a company and say, hey, I noticed that, your website or your app could have this and this fixed. This is how I would do it. Or I would message a CEO and be like, hey, these are my past achievements. I've recently turned into a developer, and I guarantee you I will work twice as hard as anybody else on the team, and just kind of make a grand promise, I guess, in order to really catch your attention. So another question was, and how did the interview go? I actually had multiple offers when I first got my developer role, and I think I was able to get those offers not because I was the best developer in the world, and by no means am I that now, but I think in the interview what I was able to do was to convince them that I will work harder than everybody else. And I made sure to do that by showcasing that A, I come from a different background. I'm not a computer programmer that graduated with a degree, and I turned that actually into an advantage by telling them all the other things that I've done beforehand, and then finally showing them that I was a self-taught programmer just like yourselves, and showing that I had the ambition and determination. So that by the end of the interview, I was able to convince them that although I may not be the most skilled developer out there, I'd be the hardest working, and I would make sure that I would learn these things so that I'd become a really, really valuable employee in 6 months. And I think if you're able to do that, you'll be surprised how many more offers you'll get, because there are a lot of developers out there, but it's really, really hard to find developers who A, can follow instructions, B, can work hard, and C, aren't so confident in their abilities that they have a narrow vision and don't take others' inputs. So if you're able to convince somebody that you're going to help them out, you're going to work really, really hard, and that you're going to be an asset to them that will make their life easier, I think that is a great, great way to land a job. All right, next question from Wan is 3 books that have inspired you in some way. And I've chosen non-coding related books just because I think the coding related books, all the popular ones, everybody knows, or you can Google them around. But the 3 books that have really inspired me, one is the 4-Hour Workweek by Tim Ferriss, that some of you may have heard of. It's a very popular book. I don't like the actual content, tips, and tricks, but I really like the way that Tim thinks, and he thinks in efficiency. And I'm obsessed with using our limited time to the most efficient degree possible. So that means, what is the best way for me to learn a topic and not waste my time? What is the best way for me to learn something and get rewards as soon as possible? And I'm sure you can notice in this course, that's what I did. I wanted to find the most efficient way possible to start earning money as fast as we can and start working in teams as soon as we can, because, well, we have limited time and we're able to learn a lot more when we're surrounded by others, when we're working in development teams. So that book, not just in developing, has really influenced my life to make sure that I think critically about what I do to grow in career, personally, financially, emotionally, just everything, to try and look at everything and analyze things. The second book was the So Good They Can't Ignore You. And this book is by Cal Newport. And it's a book that I read and it changed my thinking completely once again. And it taught the idea that passion isn't really a thing. When we're young, we think that, we're passionate about traveling, we're passionate about, surfing. And we try and follow this passion. But this book argues that passion actually develops from mastery, from becoming really, really good at a skill where people start paying you money for it, where you become respected in your field and people have admiration for you. And when you become really, really good and master at your craft, well, that's when you become content with your life. That's when you feel like you're providing value to people. And that book has really, really shaped the last couple of years for me. It's why I've really gotten into coding and I've really started to enjoy it more and more. It's because I've become better and better at it. So I highly recommend that book. Finally, the third book is Smart Cuts by Shane Snow. And this is the book that I recommend to everybody taking the course, especially those that don't come from a computer science background. It talks about how you can actually climb the ladder of success, not by just following the traditional path, but by jumping from side to side. If, for example, you were an actor and now you want to become a developer, well, this book argues that that's actually better because you're able to use whatever you learn into that field and jump on this other ladder of developing and use those skills that no other person has, such as communicating well with people and being empathetical and mimicking body language from each other. That's something that not a lot of developers know. So using those side skills to your advantage. You can definitely check out the book. It's really, really good. Highly recommend it. All right, next question. Your opinion on the blockchain technology. Very, very cool stuff. I'm actually really interested in it, and I'm writing a blog post on it. I think everybody should learn the blockchain data structure. You can actually do it in JavaScript and build this simple one quite easily in a day. And I think it's very, very exciting. I think there's a lot of hype around it. I wouldn't recommend investing in it. But to each your own. I think the technology is actually very interesting, and there will be big changes in 2018, and the field will grow really, really fast. All right, this is getting long, so last 2 questions. We have, what is the meaning of life? I'm probably the worst person to ask that to. I have no idea, but I can tell you one thing that I live my life by, and I heard it somewhere. I wish I could credit the person that I heard it from. Provide more value than you capture. And I think that's really interesting. And this is what I did try to do with the course. I tried to provide a lot of value, as much as I could, and there are times that it really sucked making this course, because it took a lot of hours, a lot of editing, and a lot of times where I didn't like the video, so I had to redo it over. But I wanted to provide something really valuable and just capture a little bit of the benefit. And I like this way of thinking. I like this idea of providing out as much value and not necessarily capturing it and getting upset if your course gets copied and torrented and people download it for free. If you're able to help a bunch of people, that's great. If you're able to capture a bit of the benefit, that's great as well. But I think that's a really nice way of looking at things, and if we all strive to do that as web developers, to capture a little bit of the value that we provide to the world, I think the world would be a better place. All right. Last question. How many messages do you get every day from your students? I mean, well, this number has definitely increased. I'm very excited about it. I can't believe that we have over 2,000 students now, and I definitely spend a lot of time. I wish I kept track of things, but I wake up in the morning, I spend about an hour answering messages, then in the afternoon I spend another hour or two answering messages and questions, and again at night I do that as well. And if I don't do that 3 times a day, I won't be able to keep up with it. I'll have to figure out a better system to it, because I do want to answer each student, and I want people to feel comfortable asking me as many questions as they can, but I do also want to continue providing new videos and evolving the course to be better and better based on feedback. So we'll see. It's been so much fun right now and so exciting that, as some of you know, I've quit my job to focus on this course full time. So all the feedback, all the community, and everybody that's helping me out on Slack, answering questions, and trying to form open source projects. It's been really fun, and this is probably the most fun I've had working in my life, and for that I really thank you. I think you're all amazing, and I think what I provide to you is perhaps 20% of the value. I think the community and the support that we're creating with this course is the big benefit, and I hope it keeps growing, and I hope it becomes something bigger than I ever envisioned. And I hope all of you, by the end of this, get what you want out of it, whether to improve your skills to get a job or just to get a little bit smarter. So I'll see you in the next video. Thanks for watching my face talk for, I don't know how long this video is, but it felt really long. I really appreciate all of you. Thanks so much. Bye-bye. Hey there, this is my face, Andre. I'm usually sitting in front of a computer, not in front of a camera, which I'm not comfortable with, but this is the AMA video, and wow, I want to just absolutely thank all of you, because we have officially hit 100,000 unique students, which is insane, absolutely mind-blowing. I did an AMA video when we hit 1,000 students, and I thought that was just extraordinary. And to be at 100,000 now is absolutely incredible. I feel extremely lucky. I feel extremely blessed, and not to get too sappy here, but I'm very thankful for you watching this video right now, because I don't really do any marketing, and it's all grown out of word of mouth. So thank you for telling your friends, your family, your kids, whatever it is. I am extremely thankful that I get to do what I do, and it's all because of you. All right, so no more sappiness. Let's get to it. I asked you on Discord some questions that you might have for me. There were a lot of questions. Unfortunately, I won't be able to answer all of them. I don't want to make this into a boring 1-hour video. So I've picked the ones that I thought had a lot of people interested in them, and hopefully I can give you some answers. Keep in mind that you should form your own opinions and decisions based on these. This is just one person's view, my view. It doesn't mean that I'm 100% correct. If I thought that, then I would have a YouTube channel. But take it with a grain of salt. These are just my opinions. I may be wrong, I may be right. It's just what has worked in my life. doesn't necessarily mean that it will work for you or the answers are right for you. All right, let's see. First one here. We have Nick Solar, who asked, what's the best way to get into machine learning and artificial intelligence? That's actually a question that kept coming up. A lot of people are interested in machine learning, data science, anything related to AI, because it is extremely popular and a hot topic right now. I actually have a course coming up on it that tries to tackle that question, because machine learning right now, it's a bit of a buzzword where it solves all your business problems, when in fact maybe it's not necessarily so. And I think there's developer interest to learn about machine learning, as well as business analysts and business decision makers to use machine learning and data to improve their profits and their business. So I didn't really give you an answer for that one, but it's one of those topics that I think in order to learn about it, you should at least learn to code, become a web developer first, or perhaps have some understanding of business data analysis before you get into it. All right, next question is from NK. Talk about your life as a developer from start until now to learn from you. Well, I think some of you know from my previous MMA, I did not come from a computer science background. I came from a business background. I did also a minor in psychology and learned to code in my 20s. I'm 33 now, by the way. Hopefully I don't look 33, but that's my age. And yeah, I would break down the developer lifecycle into 3 phases. So the first one is where you're just learning. You're learning to code. Everything is completely new. You feel extremely overwhelmed. You don't know what to learn, what person to trust, what mentor to have, what course to take. That's a really big challenge, and getting to the point of understanding and being able to build something from scratch yourself. I think that's the first phase. The second phase was when I was employed for the first time, and the first couple of years working as a developer, where you feel the imposter syndrome, right? Where you feel like you just don't know enough, or somehow they hired you by mistake and, well, everybody else around you is smarter than you. That phase really goes by. The one advice that I have for that phase is to honestly be comfortable with being uncomfortable. That is, ask as many questions as you want. Don't feel like by raising your hand and asking a question, it's going to make others look at you like you're dumb or not good enough. The more questions you ask, the better you'll have the answers, and you'll find that the successful people through this phase are the people who ask a ton of questions. When they don't understand something, they try to learn and try to grab as much experience as possible from those around you. And then the third phase is when you start to become a little bit of a senior developer, when you start to get confident in your abilities. You perhaps start to lead projects, perhaps other junior developers look up to you and ask you questions. One of the biggest things with that phase of a developer is to not almost get a God complex, where you feel like your opinions are the right ones and everybody else's is absolutely wrong. I've seen way too many really good developers get overconfident in themselves and have really strong opinions where they don't take anything else into consideration. I think through that phase, if you're able to understand that everything has pros and cons, everything depends on the situation, and that you're not, oh, I only use GraphQL, oh, I only use TypeScript, and dynamic languages are trash. When you avoid those strong opinions to almost make yourself feel like you're smart, you're doing something wrong there. You want to be open to ideas, open to suggestions, and not forget to keep growing from that phase, because as you start to get more and more recognition, maybe you feel more confident, it's very easy to think that you've reached the pinnacle and you need to stop learning. This whole industry is all about learning and constantly evolving, and what you know 2 years from now will probably be different than what you know now. So those are the 3 phases, kind of the ones that I went through. Obviously, I'm teaching now, but for me, learning doesn't stop. I'm constantly learning. I'm constantly trying to improve myself, both in teaching, but also as a developer. And I hope that that is the case with you as well. All right, next question. Next question is from SG. How many countries have you visited during the last year? Any suggestions to travel while working remote? So for some of you that don't know, I work completely remote. I carry my recording equipment online, and I set up my studio wherever I am in the world. So my courses have been recorded in Ecuador, in Nicaragua, Colombia, in Greece, in Romania, pretty much anywhere that I'm traveling. I bring my recording equipment, set up my little studio, and record. So last year I traveled to, I would say, about 7 or 8 countries where I lived in them long term. My favorite was I actually recorded the Master the Coding interview course in a little house on the side of a volcano in Ecuador. We're the last house at the very top of the volcano. So we had to hike down and grab groceries every time we needed to eat or wanted to cook dinner, and hike back up with all our groceries. That was a lot of fun. Any advice for remote? Honestly, it's one of those lifestyles that it sounds nice, but it also requires a lot of dedication and commitment to work, instead of just not being committed to a schedule and making it really easy to go off and pretend like you're busy without actually accomplishing anything. So you do need to have a bit of structure. But for those that are self-motivated and determined enough and can keep track of tasks and don't get distracted often, it's definitely a lot of fun. All right, this next question, I think I got asked maybe 5 times from people like Dorjan, Shupar, Scramblelock. All of them essentially said, why did you quit your full-time job? How come you're not a developer anymore? Well, let's say that I'm still a developer. I do a bit of consulting work on the side. The reason that I quit my developer job was mainly because I wanted to travel a bit and take a break. I had spent a couple of years working for other people and working on projects that perhaps I didn't care too much about. I was working for other people's passion projects or businesses, and after a while that kind of gets old, or at least it did for me, where I found that I stopped learning as much. It was just repeating and doing the same thing over and over. So I decided to quit and kind of figure out what I want to do next. And along the way, I decided to record some videos, my first course, Zero to Mastery, to just keep myself busy and keep doing something and help people who were like me, where they didn't have a CS background and wanted to get into web development, but there wasn't a clear path for them to do so. So I recorded that course, and it took off, and all of a sudden this became my full-time job. And now I would 100% still go back to being a full-time developer, but I'm having so much fun teaching. I still get to code every day. I still get to learn every day. And if anything, I think this way I have a bigger impact on people's lives than I did when I worked on a single project. So that's why I quit my job, and at the end of the day, it was one of the best decisions I ever made. I have another question here, which is, what is my biggest regret? I feel like I'm in an interview right now, so I'll give you my interview answer in case you ever get asked this in an interview. So my biggest regret, honestly, there's nothing. I'm really, really happy that I learned coding when I did, in my 20s, and not when I was young. Because when I was young, I was able to learn different skills. I was able to learn about business, about psychology, about communicating with others and people. And those skills helped me get my first job as a developer. Although maybe I started to code when I was a lot later on in life, it's not like I didn't do anything before my 20s. I was learning different skills. And for those people that perhaps are thinking, am I too old to learn to code? Or I'm in my 30s and there's people, in their teens that are learning to code right now. There's no way that I'm going to be able to keep up. Keep in mind that most likely you have skill sets that other people don't. And when it comes to regret, honestly, there's nothing. As long as you're learning every single day and learning something useful, over the years, that's going to compound. And honestly, every single mistake, every single decision that you make leads you to where you are now, which sounds a little hokey pokey, but it is true. Honestly, there are no regrets. If you're learning, you're never going to have regrets in life. All right, Yex, how's it going, Yex? Asked me what annoyed you the most about being a developer. I usually don't get annoyed. I'm pretty easygoing,
but the one thing that I did notice was that as people get more and more experience, they tend to form really strong opinions. And everybody wants to feel like they're part of a group. And I think we see that a lot on Twitter and YouTube and all these people with really strong opinions that kind of gang up on other people that have different beliefs than them. I think it's very easy in the developer community to have something like that where you're thinking, my React team is better than your Angular team, or TypeScript and static typing is the way to go, or REST is dead and let's all use GraphQL. I think when you have that type of mentality, it's really, really hard to actually have smart discussions and decisions within a project. It becomes really, really easy for those who feel superior to others and feel confident in their opinions to really impose their opinions on others, especially junior developers that are susceptible and have less experience, so they start to believe these senior developers that perhaps have really strong opinions. And in turn, that kind of creates this wave of more and more people that think it's a good idea to have strong opinions and debate with others and argue with others and telling people that their code sucks and their code is the right way of doing it. I think that was a little bit annoying to deal with because I think it influences junior developers a lot, and I don't think it's a good attitude to have when working with others. I think being somebody senior, being a lead, being a project lead, it means you're a person that doesn't put other people down, but it lifts others. And that was a little bit annoying because I saw that was a little bit prevalent, where everybody's trying to almost outbeat each other and be a better developer than this person and this person, instead of all of you growing together and learning together, because there's enough developer jobs for everybody. You don't need to beat out everybody to be the number one developer. So that mentality was a little bit annoying to me, but then again, I worked in Toronto and Silicon Valley, and I think those areas especially have really, really strong individualistic philosophies. All right, this is another question from DH. From where and how did you learn and become a developer? So when I started to learn to be a developer, I probably spent, I would say, $20. I think I bought a book on HTML and CSS, and the rest was all online for free, just using online resources. The only difference was that when I started to learn, there were very few resources online. I think I used one blog post that told me to use Photoshop and GIMP and some tools that I actually didn't even need, but it was really hard to find resources online when I started to learn. So I essentially just try to grab as many resources as possible and create my own curriculum, but it's not like it is now. I think right now we have a lot of resources online. It's a lot easier, and there's more of a clear-cut path to become a web developer. So I'm a little bit jealous, but I also did the same thing that you probably are doing, which is watch a lot of online courses, read a lot of books, read a lot of articles, and most importantly, building my own projects and coding as much as possible. That nothing beats actually coding. You can watch videos all day, but if you're not doing anything, if you're not producing anything, it's like watching a tennis match and trying to become a better tennis player. It's just not going to happen. We have Jamie who asked, what's the best way to practice code? Is it good by imitating someone else's code for practicing? Again, goes back to my last point. The best way to practice code is to code. The more you code, the more you practice, the better it is. But keep in mind that the best way to code is to solve your own problems, create your own projects. I actually don't recommend just watching all my videos and following along without coding, because then you're not going to be able to do things on your own. The best way to code is to code by doing your own thing. You can watch 100 videos on people coding and follow along, but if you don't understand why we're doing things, then when you're left to your own device, you're not going to be able to do anything. So the best way to code is think of a project today, think of a task that you have to do over and over in your life, and see if you can automate it with code. That's the best way to learn. Tai Lim Ask, what is your favorite tech stack? My favorite tech stack is the one that lets me accomplish my goal as fast as possible. That's a very vague answer, but honestly, anything that lets me finish fast and deliver something fast is my favorite tech stack. Because I tend to work by myself or in small teams, I really prefer things that are efficient. So for example, I'm not a big fan of TypeScript because although you get type safety and static typing, it's a lot of extra code. It's the same reason that I personally am not a big fan of Java programming, not because it's not a great language, but because for my personal use cases, I'm not working at a big company with thousands of developers for, let's say, a financial institution. If I'm building a personal project, I'd rather use something quick and easy like Python or JavaScript to write a few lines of code and accomplish a goal. So there's really no favorite tech stack. It's the stack that allows me to accomplish the goal the fastest, which happens to be usually dynamically typed languages and usually the languages that I'm comfortable with. I don't need to learn something new until I have a need to learn something new. All right, S. Morales Jr., that's what it is. Any advice on escaping the golden handcuffs and going freelance? I have a cushy non-developer job at Google, and it's hard to imagine leaving when a family and a mortgage, but I long for freedom. And this topic of freelancer is another topic that has come up many, many times. So let me address it right now. You know, I get to work remotely. I get to work for myself, which I feel very fortunate about, and I'm extremely lucky. But when it comes to freelancing, I actually am against freelancing. Obviously, every situation is different, but let me explain why I think freelancing might not be the best option for most of you. Not all of you, but for most of you. You see, when it comes to freelancing, let's say you're just starting to learn. You're just learning to code. If you go straight into freelancing, you lose the ability to work with others, to learn from others, and actually be in a company and understand how their processes work, how they work with developers. You gain a lot of experience by working on projects with others, with other developers, working with management teams, working with project managers, scrum masters. That's a really, really valuable experience that I really recommend for people just getting into coding. Now, let's say that you've had a couple of years of experience. You've worked with teams, you have that experience. Should you go into freelancing? I think you should go into freelancing if you have a clear edge or a clear advantage over others. For example, you have an existing client base and you have people that really trust your work, or you offer a really unique skill. The problem with freelancing right now is that you're essentially battling with thousands, potentially millions of other freelancers to get a job. A lot of people might go to places like Upwork or any type of place where you can bid on projects. What happens is, in those scenarios, people just bid and it's a battle to lower and lower prices. So what happens, you eventually become an employee of a contract that you probably didn't charge enough for. So it's really hard for you to compete with people that keep lowering and lowering and lowering prices, and you'll see that if you're a freelancer, that's what will happen. Unless you have an established client base, unless you have a really distinct advantage, maybe you're extremely skilled in graphic design and you're well known, then yes, maybe you can charge more for it. But people that are usually looking for freelancers are usually looking for the cheapest price. And when you do that, you stop valuing your time. You stop being a slave to the person that created the contract, and you're trying to fulfill and please this person so that they give you a good review for the next contract job. I think freelancer jobs can be good, but there's also a lot of issues that come with it. If you want to be a freelancer or perhaps be your own boss, I think there's better ways for you to go about it. I think there's smarter ways to go about it instead of competing with others on price. So I know that's not really helpful. It's just my personal opinion when it comes to freelancing, but it is a question that I get asked a lot. Freelancing essentially involves you taking a lot of time finding clients, working a lot for clients, and at the end of the day, why not just work for a company that already has the clients for you so you can gain that experience? You might think you have the freedom of being a freelancer, being your own job, but instead you're an employee of whoever your contractor is. That's my advice. I know it's not very, very helpful. But like I said, it's not for everybody. I think there's better opportunities for you to work remotely. You can work for remote companies. There's tons of websites right now of showing companies that hire remote workers. I think that's a better option for you than being a freelancer because the reasons that I mentioned previously. JT Avares 8 asks, how is life as far as time spent with family and doing what you like now as an instructor and before when you work for a company? Do you enjoy work more now or before when you work for a company? Hands down, I absolutely love what I'm doing now. I wake up every day and all I can think about is work and what I'm going to teach or what video I'm going to record or what coding challenge I'm going to do. I feel so extremely lucky to be at a point in my life where I absolutely adore and love what I'm doing. And I wouldn't trade it for anything in the world. Being a developer was absolutely great. Working full-time for a company, I loved it. I had a lot of friends. I got along really well with my bosses, with my clients. But having the freedom to work on what I want, to work on my projects, but most importantly, knowing that the work that I do maybe impacts just a little bit of the world, I think is a really rewarding feeling, and I'm extremely thankful to know that not everybody's going to love my courses, but at least there are some that do enjoy my courses and gain a bit of help in their career through it, and that is the most rewarding feeling. And honestly, the past 2 years since I've started to teach have been some of the happiest moments of my life, and I know this thing isn't going to last forever. I know I'm not going to teach forever, but I'm really appreciative of this moment to have this opportunity, at least for now. All right, Mr. Luciferus asks, a safe, secure, and stable life being a skillful employee working for someone else, or dreaming big and starting a business on your own and being your own boss? What path do you suggest? Honestly, it really depends. I think everybody wants the ideal work for yourself, own your own business, work remotely, live wherever you want. It sounds sexy, but it's not for everybody. And before I started teaching, before I was a developer, I started a bunch of businesses. I was running surfing yoga retreats in Nicaragua. I was doing adventure tours. I was doing adventure race businesses. I was trying all these different things that in the end weren't extremely successful, but they were a lot of fun. And meanwhile, I had friends who were doing their MBAs. They were becoming lawyers, and they have really nice life right now. They have families. They're very comfortable, and there's actually an advantage there. As you start to work at a company and you see people leave that company, most people think, oh, I should leave too. But you can also look at it as an opportunity for somebody else has left. Now you are one step closer to going up that corporate or company ladder. So I think it's not one is better than the other. It really depends on what you prefer, what kind of lifestyle you prefer. Do you want more of a stable, comfortable life to make sure that you can provide for your family? Or are you at a stage in your life where you can perhaps take more risks and you're okay with the high ups and high ups and high downs that may pay off, may not in the end. But I think every day, if you're working towards what your ideal life should look like, eventually you will get there, but don't expect to get there overnight. It's hard work. Nothing comes easy. There's no easy solution. So all you can do is kind of work towards that goal and learn every day and improve every day, and eventually you'll get there. But it really matters it's the best thing you can do is to have a plan for yourself and write down what you value, and based on those values and what makes you happy, decide what type of path you want to take. I got all philosophical there for you. All right, let's get back to some coding. Justin W. Lin, hey Justin, asks, how do you decide to learn next in this ever-changing landscape? From Redux, GraphQL, React, Angular, Vue, SSR, there's so much to learn, so little time. So I guess, how do you decide what to learn then, and how you actually learn and make time for it? I think this is actually something I'm pretty good at, or I think I'm good at, and that is because when I started to learn how to code, I realized how much is out there. I've become really good at selecting only the right things to learn. And there's the famous Pareto principle, which says the 20% usually accounts for 80% of value. So what's the 20% that's going to give you 80% of value when learning? And things like GraphQL, for example, they're extremely popular, so a lot of people want to learn it. But at the end of the day, how many people actually use GraphQL in production? How many people have actually built something with GraphQL that creates a value? I like to look at technologies and see what's hot and what's trending, but not necessarily jump really deep into them until there's a clear need for me to learn it. So, for example, Vue.js. Yeah, I know a bit of Vue.js, but I wouldn't call myself an expert because I haven't had to use Vue. I can use React, or I can use Angular. So being selective in what you learn instead of trying to learn everything is going to be a better long-term strategy over the course of your career, because learning never stops. And the more you learn, the more you start to realize that it's not about the syntax, it's not about learning the libraries, it's not about reading the documentation from start to finish. It's about understanding the higher principles, the why was this tool built? Why are we doing things the way it is? What problem is it solving? Being able to understand those and discuss those is going to be really, really important, because at the end of the day, the fundamentals is what matters, not the syntax. If you learn the fundamentals, if you learn to think like a developer, think about systems and how things communicate, that's a lot more valuable than learning the newest React hooks API. I mean, that could still be important, but as you can see, I'm very selective in what I learn. And I'm not trying to learn 10 languages at the same time. If I want to learn something, I'll dedicate maybe a year to get really, really good at something, and then move on to the next thing. So really being picky, as if you're dating a new technology, and making sure that it's the right one is the way to go. Oh, and with that said, you obviously have to enjoy what you're doing. If you don't enjoy learning, then that's going to be really hard. So that's just something that has to come for yourself, and being able to enjoy the learning process, because that's going to be your biggest asset. If you enjoy learning, you're going to learn more. Adrian asks, how long do you plan on continuing doing courses? Because, well, this isn't going to last forever, right? Honestly, I'm not sure. It's been close to 2 years now that I've been doing this. I don't imagine doing this for a lifetime. There's only so much I could teach. I'm going to keep going until I stop enjoying it. Right now, I really enjoy the process. I get a lot of reward by hearing your reviews and how pleased you are with the courses. So that really drives me to create more. But eventually, I will have to stop. I can't just keep creating courses. They do take a lot of time and effort. So I hope that I can keep going for a few more years. But one day, maybe retire and spend a little more time with family, or move on to something else. But for now, don't worry, I'm not going anywhere. Balloon asks, do you play any instruments? No, I am the least musically talented, artistically talented person you'll ever meet. I took piano lessons, guitar lessons when I was a kid, and I'm hopeless. Thank God coding exists, and thank God sports exist, because if I had to do anything in the arts, I would not be very good. Garasan asks, it would be really inspirational for all of us to what do you want to do with the next 10 years of your life? Coding, business, looks like he's the same age as me, so just asking what what's the next 10 years of my life look like? The next 10 years of my life is going to involve learning every day. I want to, whether it's coding, whether it's different things, I have different hobbies that I want to keep improving at. I really like surfing, so I want to become a better surfer. And there's so many things that I really want to improve. So honestly, every single day, my goal is to learn. I want to hopefully have a family by then and have a house and just enjoy life. And hopefully in 10 years, I'm retired, being able to spend every single day with my son or daughter and just enjoying life. But honestly, what I'm doing now is not much different than what I hope to be doing 10 years from now, because I am really, really happy with how life is right now, and I wouldn't really change anything. Dorian again asks, do you think all the races you do and yoga and exercises help you mental clarity and have helped your career as a developer when things get rough? Yeah, so fun fact, I'm also a yoga instructor on the side, and I do a lot of adventure racing as well, and both of those things I think actually really help with being a developer and dealing with different situations at work. I think for adventure racing, it puts you in situations that are extremely uncomfortable that you have to just survive through, and then with yoga, obviously, it stills your mind, especially with meditation as well. I think those are extremely important, especially when compared to coding, when you're staring at the screen and everything is usually fast-paced and it's really, really easy to get lost in your head. I think balancing out coding with something that's complete opposite, like yoga or meditation. Again, not to get a little hippie here, but I think doing different things is important, and being physically active, being mentally strong this is your vessel and this is your body, and you should take care of it, and it will only improve you as a developer and as a coder. So I 100% think that although for some people it may be silly to meditate, although for some people they don't enjoy exercising, everybody has their different things, but I think doing something other than coding is really, really important for that balance and to not burn yourself out. Asim Ahmed asked about interview and the fact that he's really worried about interviews and that he doesn't know enough. And honestly, just keep this in mind, because this is something I hear from so many people. Everybody is just a child trapped in an adult's body. No human knows everything perfectly, and most likely the person sitting across from you that's asking you a question on an interview doesn't know everything, has their own insecurities, has their own areas that they're not an expert in. So go into an interview knowing that this person is not God. It's not the ultimate smartest person that you'll ever meet. They have their flaws and their issues. And if you start to realize that there's no such thing as a perfect developer, a perfect coder, and everybody is just trying to pretend like they're smart, everybody's just trying to pretend like they're an adult. Remember, everybody's just a kid trapped inside an adult's body. You start to realize that this whole world that we live in, this whole system that we're in, is just a game. Just like you're a coder, just like you're a programmer and you're trying to create a system, this is simply a system that you need to learn, to adapt to, and to try to essentially beat or improve. So put yourself in their situation. They want to feel important. They want to feel like they're doing a good job. So maybe asking them questions during the interview, maybe praising them for something that they did, even though they're the ones being interviewed, is going to make them feel better. That perhaps will make them ask you better or easier questions. Again, think of it as a system. Think of it as a game, and realize that there is nothing is extremely serious and important. Everything is just a game that you can play and that you can improve. And if you start looking at life, at interviews as a game, I think it becomes a lot more fun, and it also removes some of those insecurities. I don't know if that answer helped, but kind of went on a tangent there, but hopefully that helps a little bit. All right, last question, because this video is getting a little too long. So Charles Mansion asks, what's a typical day for you at the moment? Your courses are that's very kind of you. seem to be your healthy way of living and your sporty attitude, it'd almost be worth a course on how to balance your life and the way you do things while you code. I guess I kind of already talked about this, but my everyday life usually involves in the morning drinking coffee, reading articles and catching up in the industry, learning a little bit. I really like morning for learning. And then I usually either record or plan recording or edit videos in the afternoon. Then around 1, 2 o'clock, I usually go out for a run, do some exercises, try to get outside, not stare at the screen and be active. And then I come back. I usually check out my emails, answer questions, go on Discord and chat with other students. And then usually by 5 o'clock, I'm done. I don't do any work. I stop whatever I'm doing because I know after 5 o'clock, for me personally, I'm not productive. So I usually spend time with family, with my girlfriend, or do social activities, or maybe go play some tennis, go play some soccer, go for a hike, just to relax. And I usually go to bed at 10 o'clock. Not that very exciting. I don't enjoy going to bars or clubs anymore. I'm an old soul, and at 10 o'clock I'm ready for bed and I'm ready for the next day. So a pretty boring day. Nothing too exciting, but it's what I like. All right. Anyway, this was the AMA video. Again, I want to thank you. I cannot believe that there's 100,000 students that are taking my courses, and honestly, if it was just me, I would never get to 100,000 students. It's every single one of you that talk to others, recommend my courses, that really help me get to where I am, and I cannot express how thankful I am for everything that you have done, that you have shown support for, and I hope to continue to keep impressing you and keep helping you with your learning journey. And I'm really, really thankful. So thank you.
And welcome back. We're going to get into some more advanced tags. And probably the most important tag that you'll use, other than the ones that we've covered so far, are tags that we need to create forms. As you know, when you go to websites, usually there's some sort of a login or registration form. So we're going to build that out today. To get started, let's just create a new file here. We'll save it and call it register.html on our desktop. Perfect. And we know that we want an HTML, so we use our little shortcut and we'll title it register. Save that. And now in the index.html file, let's add another link that references register.html, and it'll just say here register. All right. We'll save both of these files and let's refresh. We have register. Click register. Well, we have nothing yet, but it looks like it's working. Let's add this on a new line just because it looks prettier that way. So to do that, if you remember, we're going to add a break tag. So let's refresh. There you go. We have new page and register. Okay, so let's build out this form. If we go into register.html, the way we write forms in HTML, well, conveniently, there's a form tag. Okay, but this form tag itself, it needs to have the actual form inside of it. So what kind of form elements do we have? Well, again, if we remember our good old friend W3C, let's type in forms. And we can see over here that we have HTML forms. And refresh, we'll make that full screen, and you can see over here that there's a ton of information on it, but you can look that up yourself. For now, I'm going to introduce you to the most common ones, probably the ones that you'll use 90% of the time. The first one, as we do with any form, and let's go to that page for now, is, well, we want to enter our name. So how do we do that? We have a input tag that has a type of text because, well, our name will be in text form. And we can close that off. And it's actually a
closing tag. So now if I save and refresh, okay, we have a little box here. Hopefully you can see that, but well, we should probably title it because we won't know what to enter that way. So we're going to put in here, we're going to say first name, semicolon, and save. Let's refresh. We have first name. And now, let's make this a little bit bigger. There you go. Now you can enter your name in here. Awesome. Well, let's add another one for last name. And again, we'll have our input type. So that's an attribute and a value of text. And if we refresh, we have last name. Okay, but it kind of looks ugly. Remember that HTML just reads line by line and doesn't really know that we want a space here. So again, we can add a break tag here and refresh, and we have first name and last name. Okay, that's fairly self-explanatory. Now, what else do we have in a form? We have email. So let's add another field, which is email, and we'll do input, again, type equals text. We'll add another break here because we're going to need that spacing. And let's save, refresh. Awesome. Okay, so we have our general registration form. And obviously with any form, we need some sort of buttons, right? Like we need to submit this somewhere so we can register. Well, again, there's a nice input type for that. So we do input. Instead of a text type, there is a submit type. So this, if we add another break in here, and I save this, I refresh, it has a submit button now. Now, where did this submit come from? Well, when you put in input type submit, it automatically creates a button. And if you don't specify what to say, it'll just have this text. But we can change that. So we can put value, and we'll put register. Save that, refresh. We now have a register button. Okay, but what if we make mistakes in this field? We write stuff and, well, we want to reset this form. Again, there's another input for that. And the type of that input, as you can imagine, is reset. So now, if we close this, add another break in here. Actually, we can keep that on the same line. We'll save, refresh, and we have reset. So now if I type in anything in here, and let's say I don't like this, I need to reset the form, I can just click reset and it clears everything for us. Okay, you may be asking yourself, what happens when we click register? Before we get into that, I want to just go through all the common input types and then we'll click register to see what happens. With the email, we ideally want, first of all, for it to be required so that when you click register, if you haven't provided an email, it won't let you register. And there's an attribute that we can use for that, and that is required. And here, we don't actually have to specify a value because automatically it's assumed that required equals to true, which means that this form field is required. So if I save that, I refresh, and I leave it blank and I click register, it'll say, please fill out this field. Now, we also want to make sure that it's an appropriate email field. So if I type something like this, we still want to make sure that, this is an incorrect email. We don't want to register. So the input type of text that I told you for email is actually wrong. There's a specific one that we can use, which is, as you can imagine, email. So now, if I refresh and type in something that's not an email, and I click register, I'll say, please include an @ in the email address. Very nice. It's kind of like magic. It does this for you, which is very, very nice. Let's expand on our knowledge of inputs and add a few more fields that we'll most likely need. Usually want to
know somebody's birthday. So let's add birthday here. And for this input type, let's do type date. So if I save this and I refresh, look at that. We have a nice little date picker. So I can pick anything in here. All right, what else do we need? We also need gender. So we'll do input type. And for gender, well, there's no specific input type for gender, but there is something called radio. And radio is, as the name suggests, radio buttons. So now I click refresh and, well, I have one radio button, but we ideally want to have options, right? So how do we do that? So for the radio, we also need to say whether it's male or female. Let's have, within the gender, we're going to have a break over here in the line. And we'll say input type radio, and we'll say male. And we also want female, and we also want other. And when we refresh this, we have male, female, and other. But you see a problem here. I just click the radio buttons and I can't deselect them. And ideally, you should only be able to select one. And right now, the way the radio buttons are, they don't know of each other's existence. We want to make sure that they know that they're connected. They're family and only one of them can be picked. So how do we do that? The way we do that is through the name attribute. So for the name, we'll say gender. And this name attribute needs to match on all the radio buttons so that they know they are together. They're part of the gender input field. So if I save here and refresh, now you can see that I can only select one. All right, perfect. What else should we have? Well, let's say I really want to know if you have pets. So with pets, we're going to have input type. Well, you can have multiple pets, so it won't be radio buttons. We want checkbox. So checkbox, we want it to have cats, or let's just put cat. And we want to have, can't type today, checkbox. And we want to have dogs. So let's save that. Let's refresh. And look at that. We have pets, but this time it's checkboxes, which means I can select multiple. I want to introduce you to one last form element, and it's actually not an input with a type. As we've described before, it's a little bit different, but the idea is still the same. So let's add cars here, and we want this to be a drop-down menu. Again, something that we see very often in form fields. However, unlike an input tag, we have to do a select tag. It needs a closing select tag as well. And within here, we can put in our options. So the option will be, we'll have a value of Volvo, not Volco, and we'll say Volvo because we want that actually printed to the screen. And again, we have to close that tag. We'll add Audi, and we'll close that tag as well. And we can keep adding them, but for now, just 2 is fine. If I save this and I refresh, we have cars. Let's add a break here, just so it looks nicer. There you go. And here, now we have a drop-down menu. Let's say you want to extend this, or you want to see what kind of properties you can put with select. The way you go about it, as you know, we've done this before. We type in HTML select tag,
And actually, Google gives you a nice little info page over here with attributes. So you can see over here, we can use multiple, which specifies that multiple options can be selected at once. So let's do that. Let's minimize this. Perfect. And within select, we'll put multiple. We refresh, and we can actually select multiple elements. But that doesn't look that pretty, so I'm going to take that out and refresh. I actually realized that we forgot one important input type, so I'm going to throw it in there as a bonus. And as you know, with any registration form, we want a password. So let's add that right after the email. We'll do input type. And yes, there's a password type that we can add. And this password type will have another attribute that's kind of cool, and that is min, which is the minimum characters that a password needs. Okay, so let's save that, refresh, and let's add a break here so it looks pretty. Refresh. And now the password field, look at that. It acts like a password field. All right, let's submit this form and see what happens. Okay, Andre, can we finally submit this form? All right, in this video, we'll finally see what happens when we submit this form. But there is one last thing that we need to include, and that is the name attributes. And I'll explain towards the end of this video why we need those. So we want to add in each one of our fields a name attribute. So this one will be first name, and I'm just going to copy and paste here just so it'll be a little bit faster. We have last name, email, password, birthday. We already have these for the radio buttons, which is good. And we need here cat, dog, Volvo. Okay, and we don't need it for the buttons because, well, there's no user information there. So I'm going to save that, and I'm going to make this full screen so you can see. I'm going to refresh the page, and let's enter some fake data and see what happens. So I'm going to say fake, man, email address is fake, password would be 123, birthday will be male with a cat and has an Audi. I'm going to click register now, but keep an eye out up over here to see what happens when I click. Did you catch that? Let's copy this because when I clicked register, this got attached. I'm going to minimize this and print this out here so we can see it for ourselves. First, we have a question mark, then first name, fake. That's exactly what we entered. We have last name, man. Email is fake something gmail.com. Password 123. Oh, they know our password. Birthday, gender, and cat on. We didn't select Volvo. I'm not sure why. I'll take a look at that later. But you can see over here that the values that we entered into our form were just attached to this link. And this is actually called query strings. And what it is, it's one way for us to send our information to the backend or the servers, because we have to store this form information somewhere so that when we come back onto this page, the website remembers us. This was automatically generated in HTML5 with a form, but form was using an attribute called get. And this get, if I left it as this, will do the exact same thing where it will attach the form information to the URL and send it to the server. There is another option where you can do post, and you can try it on your own here, but you wouldn't see any query parameters. So this wouldn't change, the bar at the top won't change. And that is because it will be attached to the body of the request, which we'll get into when we get to that section. I don't want to confuse you too much, But you can see the difference here of why we might want to use post instead of get, because, well, what if somebody was over my shoulder and they could see my password right there in the bar? I just wanted you to get comfortable with the idea that we are sending this information to the backend. The way we handle that, we'll get into later on in the course. Right now, we're just focusing on the front end. The last thing I want to show you was that form also has a action attribute, which used to get used a lot. If you saw old PHP-based websites, they'll have some sort of a action.php, which said, submit this form, and when you submit this form to the backend, to the server, run this script, this file that's on the server. But there are better ways of doing this now, so I'll show that later on in the course. Let's take a look at this. So we have a question mark, and this is the standard. Anytime there's a query string, so we're adding a piece of data to our URL, it starts off with a question mark, which states, hey, coming up, we're going to have a bunch of data for you. The first one is first name, which again corresponds with the name that we have in our form. And that was equal to fake. So that's property and value. So you can think of name as property and the value as man. So last name, first name. You can see here that there's an and sign. So that's again saying first name equals to fake and last name equals to man and email equals to fake, some gibberish, gmail.com. So this is because of something called URL encoding. And because the URL has special meaning for some characters, such as this and the question mark, it encodes the @ sign with something that it understands, but it won't affect its encoding. We have password 123, birthday, gender on, and cat on. And I've actually realized why the Volvo and Audi information didn't register. And that is because for the query string to work, as you can see, it needs to have a name associated with a value. So we have first name and fake. If we look at the radio buttons, we have a name, which is gender, and we have on. So you see over here how we didn't send any value. We know that the gender, some button was clicked in the gender, so it's on, but we don't know which value. And that is because we should have included a value for the male, so that if that's the one that's selected, a value will be sent. And finally, value. And now same with the select. We should have had our name of the select field be cars, so that now the name can be associated with the value. So let's give that a try one more time. I'm going to delete this. I'm going to save the changes that we just made. I'm going to make this full screen. Let's refresh and enter some new information. Fake, new, email is newfake@gmail.com. Password is 1234 this time. Birthday, let's do female, dog, and Audi. I'm going to click register. And let's see what we have here. We have first name fake, last name is new, email, newfake@gmail.com, password 1234, birthday, gender is female, good. Dog is on. Okay, so we've selected dog. That's great. And then cars is Audi. There you go. And that's as complicated as forms are going to get. You'll encounter this a lot, and there's definitely in most websites that you build, whether it's a landing page, a website that requires registration, this is something that you'll see a lot. Once you understand this, once it makes sense, you can call yourself an HTML developer. So I'll see you in the next one. Bye-bye.